Hello everyone, welcome to this Java full course from Simplilearn. Before we begin, let me tell you guys that we have daily updates on multiple technologies. If you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now without further ado, let's get started with the agenda for today's discussion. In the first segment, that is the core Java, we will understand how to install Java, install Eclipse in our local systems. Followed by that, we will have the fundamentals, that is, the data types in Java, data conversion, arrays in Java, operators in Java, and followed by that, we'll have the control statements in Java. Moving forward, we will discuss the data structures in Java. Next, we have the loop statements in Java, then Java collections, Java streams, access modifiers in Java, inheritance, encapsulation, and next we will discuss the abstract classes in Java, interface in Java, polymorphism in Java, static keyword, exception handling in Java, and finally, to sum up the core concepts in Java, we will try to create a calculator project based on core Java concepts. Now moving ahead, we will discuss some of the advanced Java concepts that we will be discussing in this particular tutorial. The topics in advanced Java are enumeration in Java, annotations in Java, serialization in Java, multi-threading, synchronization, auto-boxing, input and output streams in Java. Moving ahead, we have Java database connections, generics in Java, Java.Lang and Java.Util, concurrency utilities, regular expressions, and advancing ahead, we will have the Spring frameworks, Spring MVC, and finally, we will have Spring and REST API. And also, to make things more interesting, we will have Spring Boot project at the end. I hope I made myself clear with the agenda. Now, over to our training experts.
Let's get started with installing Java. We will basically look at how we can install Java on a Windows machine. So the first step to install Java is to download it from the official Oracle website. So for that, let's open a web browser and let's type JDK Java download and hit enter. Then you need to find the link which says oracle.com because like we discussed in the previous lecture, Java is owned by Oracle. So we need to download it from the official website only. So we can click on this link which says Java SE downloads. It will bring us to the downloads page and we will see different versions of Java. You can see the Java SE 15, you can see Java SE 14, you can also see Java SE 11 and all the previous versions. Another thing which you will notice that it says LTS here, which means long-term support. Basically, long-term support are the releases for which Oracle is going to provide long-term security patches and updates. For the non-LTS releases, Java will not provide long-term support and long-term patch fixes and long-term security fixes. So it's a good idea to analyze and evaluate on which version you want to develop your applications on. For this demo, I think it is fine. We can go with the non-LTS version. And even for your customer-facing applications, you can start with the non-LTS version and then upgrade to the latest LTS version whenever that is available. So for this demo, we can download Java SE 15, and you can also do the same on your machine. It will work exactly the same way as an LTS works. So you can click on the JDK download option here. Let's click on that. It is going to bring up the downloads detail page. And you can see there are multiple options given here in terms of what platform you want to install Java on, whether it is a Linux platform or it is a Mac OS machine or it is a Windows platform. So like I said in the beginning of the demo that today we are going to see how we can install this on a Windows machine. So I'm going to download the Windows x64 installer here. If you are working on a Linux machine or a Mac OS machine, you can download those respective installers as well. So you can see the exe here. So let's click on this. Once we click on this, we'll get this pop-up, which will ask us to accept the Oracle Technology Network License Agreement. So we can hit this checkbox and click on download JDK 15. And this shall start the download and you will see some exe getting downloaded in your download box here. But as the download is going to take some time and I'm not going to wait for that. And that's the reason I have already downloaded the JDK 15 for this particular demo. And that JDK is sitting here on my desktop, which I've downloaded prior to this demo. So we'll just run this particular exe, which is exactly the same exe as the one which is being downloaded. So let us double click on this. It will ask you for this pop-up in some cases. So you can just hit yes. Basically, it is asking whether you trust this exe or not. But as we downloaded this from official Oracle website, then we can trust this particular exe. So I will hit yes. And now the installer is going to unpack, and you might get a screen like this, which will be an installation wizard for the Java SE Development Kit 15. Another thing which, before I proceed, I just wanted to highlight that as well, that you might have noticed the word JDK here. It's exactly the same term which we covered in the last lecture, that when you install Java, you basically install the JDK, which is the Java Development Kit. And this is also visible here when it says Java SE Development Kit 15. So let's hit next. Then on this particular page, you have the option to change the installation location of Java if you want to. By default, it is going to install in C program files /java/jdk15. But if you want to change the location and you want to install Java to a particular custom location of your choice, that is also possible. You just hit change here, and then you can choose whatever directory or folder or place you want to install this Java on, and you can basically select the appropriate location. For this particular case, I don't want to change that. I'm happy with the default location, which is available here. So I'm just going to proceed with this particular location here. So I will just hit next. And then Java is going to install. And it's very fast installation. It generally takes few seconds, as you will see in this demo. Basically, it is going to unpack all the libraries and all the runtime libraries and all the class path libraries, which we discussed in the previous lecture, and put all that into the location which we specified to install Java. It will also set up the rest of the prerequisites which are required to run Java successfully. So looks like the Java has been successfully installed, as is visible in this message. And there's also a next step if you want to access the tutorials or the API documentations, the developer guides, the release notes, etc. I don't want to do that, so I will just hit close here. And now if we want to just verify if Java is installed or not, then we can verify that from the command line prompt. Let me just exit this, and let's go to the command prompt to verify to see if Java has been successfully installed. So to do that, we'll just open the search bar and we'll type cmd. It is going to show us this command prompt here. We'll click on this and it will open the command prompt for you like it has opened for me. And there you just need to type Java-version and you hit enter. If you get a message like this, it means Java has been successfully installed. If you get a message saying that Java is not recognized as a command, it means that Java is still not successfully installed and something has gone wrong in your installation. And in that case, you might want to restart. You might want to go back and reinstall this Java exe again. So in this case, it looks like it has been successfully installed. And we can also get some interesting information from here. We can see which version of Java has been installed. It says Java version 15. We can also see that the JRE is also installed. The Java SE Runtime Environment, or JRE, is also installed. And we can also see that the JVM is also installed, which is Java Hotspot Server VM. VM means the virtual machine. So if I connect this back to the previous lecture, we can see that the Java JDK basically installed the JRE as well as the JVM as well. And the complete Java package has been successfully installed. Now we are ready to use Java, a Java program and run Java programs on this machine. Let's get started with installing Eclipse on a Windows machine. So the first thing which we need to do is to download Eclipse. So for that, I'm just going to open my web browser and type Eclipse download, press enter. And then you need to find the link which says eclipse.org/downloads, which is the first link in my search results. You can also see it says Eclipse downloads, the Eclipse Foundation. And Eclipse Foundation is the organization which maintains the Eclipse installers. So we can click on this. Once we click on this, we will be redirected onto the Eclipse downloads page. And there again, you will see a bunch of options. you will see the default option highlighted, which would be the Eclipse installer for JRE for Mac OS, Windows, and Linux. And then you have some other tool platforms option as well, like Eclipse G or Orion, which you might want to use for advanced cases. But for running Java applications, all you need is an Eclipse installer, which is coming from here. So based on your machine, Eclipse will automatically detect whether you want a 64-bit installer or a 32-bit installer. And you can just click on this particular link, which says download 64-bit here. So I'm just going to hit download 64-bit. It is going to open this particular screen where, based on your current location, Eclipse will suggest the nearest possible distribution mirror. Distribution mirror is basically a server which is present somewhere in this world, which contains this Eclipse installer exe. And Eclipse has created these servers all across the globes. These servers are basically called the mirrors. And based on your current location, which will be taken from your ISP, from the internet IP address from which you are accessing this particular website. So based on your ISP location, it is going to suggest you the nearest possible mirror location so that your download is the fastest. So in my case, the nearest location is Netherlands here, as you can see, and I get a download option. This is the file name, which says Eclipse installer JRE Windows 64.exe. And if you think that this mirror doesn't make sense, just click on this option, select another mirror, and then you can choose another mirror. But generally it works really well. It works based on your IP location, and it's generally the download speed is pretty good based on the suggested mirror. So I'm not going to change the mirror location because I think this works fine for me. So, and I'm just going to click on this particular button, which is going to start the download of the Eclipse installer. So now I have hit the download button, and you can see right now an exe has begun to download. It is going to again take some time, and I have already downloaded this particular exe just to save us some time, and I'm going to use that exe to showcase how we can install it. Another thing just wanted to highlight is that Eclipse is an open source organization. It works on donations. So if you feel generous about it, and if you feel that Eclipse is doing really great work, you can also donate to it, which will show here. So we can move to the next step, which is about installing. So you can see here, I have an installer here, an exe file basically, which I have pre-downloaded to showcase this demo. I'm just going to double click on this, and it is going to unpack the installer. You can see this icon will be presented to you, which says Eclipse installer by Oomph. Oomph is basically the provider for this particular installer who manages the installer. And based on your computer's capacity and speed, it is going to take few seconds. And in the background, what it is doing is basically it is unpacking this installer and creating all the installation files which it needs to successfully install it on your computer. Once that is done, you will be presented with this kind of screen, and you will see that Eclipse provides multiple different kind of IDEs for different set of developer communities. You will see an option which says Eclipse IDE for Java developers. You will also see Eclipse IDE for enterprise Java developers. You will see the IDE for C++ and C developers, web and JavaScript, PHP, Eclipse committers who basically contribute to the Eclipse organization, or RCP, RAP, tester, scientific computing. There are tons of IDEs which Eclipse maintains. For our use case throughout this series, I think we will be focusing on this particular IDE, which says Eclipse IDE for enterprise Java developers. You can also use this particular IDE, but this is a very bare bone IDE with very limited set of integrations. Like it says, it includes a Java IDE, a Git client, an XML editor, a Maven plugin, and a Gradle plugin. But if you look at the enterprise, you will get more integrations. You can use this particular IDE to work on whatever you work here. So these all will work here. But in addition, you can also use this IDE to build a web application, build a web service, build a JPA application, data tools, Java server pages, faces, etc. So this is more advanced, I would say. And we will go with this particular IDE. And you can also choose this IDE if you want to, but for this demo, we are going to choose this one. I will click on this. Then it is going to show me which virtual machine it is going to use. So if you remember in the previous lecture, we installed Java 15. It has automatically detected that location by reading my C program files folder, and it has automatically taken that. If you have multiple JDK installations on your machine, you can click on this icon and change a different Java virtual machine. I'm going to leave it as is. Again, the installation folder is also by default taken to your C users username / Eclipse / the JEE version number. And again, if you want to change this, you can also change a different installation folder. I'm going to leave everything as default. It will automatically create a start menu entry and a desktop shortcut. And now I hit install. It might come ask you for a user agreement. So you can hit accept now. And now it has begun the installation. The installation generally takes a bit of time to complete in some cases. So again, it depends upon your computer's capacity and speed. Basically, if it's a good robust machine with good capacity, the installation might be very fast, as you can see in my computer. And if you have a computer which is not very strong on configurations, you can just be patient and wait for some time, and the installation will be finished. Once the installation is finished, you will see this launch option here. You will also have an option to keep an installer if you want to, show the README file. But I think the main option here, which we are going to use, is the launch option. So if you hit the launch option, now the actual IDE is going to start up. It's again going to set up some configuration files and some bootstrap configuration files, which it needs to. And then it will ask you to choose a workspace. Again, workspace is up to you. Where you want to create your workspace? The workspace is basically the location where you will create your projects. It will store those project files and the source code of those projects. So it is up to you where you want to create it. Again, I'm going to leave it as default here, but if you want to change it, just hit browse here and choose whatever location you want to. You can see, you can go to PC and you can choose whatever location you want to. I'm going to leave it as is. And you also have a choice that you don't want Eclipse to ask this every time. So you can check this box, and next time Eclipse is not going to ask you to choose a directory as workspace. And every time you start Eclipse, it will automatically go to this particular directory. So you can either check it or uncheck it based on your convenience and hit launch. Once you hit launch, it is going to start the actual IDE as a desktop application, and you will get a nice interface and a welcome screen from Eclipse, which will basically show the basic overview of the screen, something like this. So now you can see that the Eclipse IDE has started. It has a welcome page, which has multiple options. You can check out a project from Git. You can import an existing project. You can go to the marketplace, create a Java web project or whatever, or you can just close this. You have a nice navigation project explorer bar here. So all the projects which you're going to create will be listed here. There are also some quick shortcuts here for creating different kind of projects. And if you don't want to use that, just go to File, New, and choose a kind of project you want to create, whether it is a Maven project or enterprise application project or dynamic web project or just a project. If you just hit just a project, you can choose a basic Java project to start with, click Next, give a project name. Let's call it Test Demo. You can choose an execution environment here, the JRE, and currently this particular IDE has support up to 14, but I think this is going to work fine. We don't need to worry about it. We can also use a project specific JRE, like in this case, Java 15, which is the current installation. So I can use this option because I want to use Java 15 environment because I have Java 15 installed. So you can basically choose whatever option you want to choose. It gives you a flexibility in terms of choosing the JRE, whether you want to choose an external JRE, whether you want to choose a project specific JRE, or you want to use the default JRE JDK installation. So you can use this option as well if you want to. Project layout is either you want to create separate folders for source and classes, or you want to create use the project folder. Again, these are just basic configurations which you can play around with if you want to. I'm just going to leave it as is and hit next. And then it is going to just give me a review screen here. If I want to change anything, I can. Otherwise, I can just hit finish. I can create a module name here if I want to, but I don't want to create it. So I just hit on don't create and open the Java perspective. And that's it. You have a Java project here where you can create your Java files under this SRC, and you can start executing those files. Let's get started with primitive data types in Java. We are going to learn about the primitive data types in Java, and we'll also see a short demonstration of it. So let's get started. Let's first just learn about those data types. I've just opened the official Oracle documentation. And don't worry, if you see how this link appears here, you can just open a browser window and just type Java primitive data types. And if you hit enter, the first link which you will be given is this particular link, and this is the same link which I have opened. So let's learn about the data types now. So Java has these primitive data types, which you can see here. Some of them store numbers, some of them store Boolean values, and some of them store characters. So the data types which store numbers are byte, short, int, long, float, and double. These 6 data types basically are used to store any kind of numeric value. Let's understand these a bit more. Byte is the shortest possible data type value which you can use in Java to store numbers. You can only store numbers within the range of -128 to +127. So you can see the range is very small, and Java has created this variable for use cases where you want to store numbers which have very small value in this range. Why do we provide these kind of options? Just to save memory, because the smaller data type will require less memory to be used in the Java program. Similarly, the next bigger data type is short, which is a bit bigger than byte. And the range of this particular data type variables will range from -32678 to +32767. So that is the range for this particular variable. And you can see that it has a very big range as compared to the byte data type. So if you want to store values which lie in this range, you can use short. The next one is int data type. You can use this one to store even larger values, which range from -2 raised to power 31 to +2 raised to power 31 minus 1. The next one is long, which is even bigger than int, and it can be used to store the values within the range of -2 raised to power 63 to +2 raised to power 63 minus 1. So as you can see, as we go from top to bottom, from byte to long, the size of the value which can be stored using this data type increases. And that's how you will basically take a decision of whether you want to use byte or you want to use short or int or long, based on what size of the value that variable is going to contain. Then the next ones are float and double. These two have been created for the use cases where you want to store the values, numeric values, which have decimals, which are precision values. I should also mention that byte, short, int, and long are only used for storing absolute numbers which do not have any decimal representation. Even if you try to store a decimal value in these variables, they will automatically be trimmed. The decimal values will automatically be removed, and you will only be shown the absolute values. And in case of float and double, they can maintain those precision and decimal values. So we use float for the use cases where you want to store decimal representations of the values. And you can see that the float value can store a smaller precision value, but double can store even a bigger precision value. So if you have really big precision values to be maintained, very big decimal values to be maintained, you should use double. And the float is used for storing a bit smaller size of the precision values. I mean, its range of values basically beyond the scope of this discussion. If you want to read more about this, you can go to these particular links, which will explain this in detail. But the basic idea is that float is good for storing 2 precision values. And if you want to go beyond that, you want to use double. In some cases, some people also use float to store even beyond 2 values as well. So it completely depends. The decision factor is how long the value you are going to store in the decimal. And that will decide whether you want to use float or double. The next one is Boolean, which is used for storing the Boolean values. Boolean values can be either true or false. So there are only 2 possible values. And then we have char, which is used for storing characters. It is using 16-bit to store the value. And this is a very popular Java question for beginner level programmers, that why does it need 16-bit to store the character? It's because it stores a Unicode representation. Unicode representation is the representation which can be accepted across platforms across the world in different character encodings. So let's move on to Eclipse now, where I have prepared a very short and simple demo. I'm just creating a variable for each data type and I'm printing them. You also see some things here like these keywords, and don't worry about these keywords. I will cover these keywords in detail in the upcoming lectures. You also see this. And you can just, for now, you can remember that system.out.println is used for printing anything in Java. Anything you want to print on the console, you would be using system.out.println. What is system, what is out, and what is println? Again, we will cover these in the upcoming lectures. For now, I'm just creating a bunch of data types here, variables here basically. I'm creating a char type variable, a byte type variable, a short type variable, an int type variable, a float type variable, a double, and a boolean. The way you create variables is basically you put the data type name, you put the variable name, which can be anything, you put an equal sign, and you put the value, actual value which this variable is going to store. And I've done the similar thing for all of these variables. Java wants semicolons to be there when you write your statements. So please remember that your statements always end with semicolons. So I've declared all of these variables here, a byte, a short, an int, float, double, and boolean. And then I'm printing all of them basically. Here I'm printing the char variable. Here I'm printing the byte variable. Here I'm printing the short, and so on and so forth. So how do we actually run this application or this program? You just double click on this or right click on this. You go to this run as option. You see this run as Java application option. So you can hit this option. It will run the application and it will present all the output here in the console tab. Let me just bring this up. So you can see all the variables have been printed here, and this is coming from these print statements. Like I said, this is used, system.out.println is used to basically print anything. And I've used that to print all the variables here. First, I'm printing the char variable whose value is A. Then I'm using the byte variable, which is denoted by B and whose value is 2. So you can see the value is 2 here. Then I'm printing the third variable, which is C, which is a short type variable, which has a value 22. You can see short, and this is coming here. The next print statement is int. So you can see int here with the value 45, and this value is coming from here. Then we have float. You can see the float value being printed here, and you can see the float value declared here. You also see an F here, and this is the standard naming convention which Java proposes, that whenever you declare float and double, you end them with F or D based on whether it is float or it is double. Then you see the double value, which is having a bigger precision than float. So I've printed the double value using this particular print statement, which is printed here. And then we have the Boolean value, which is stored as G, and the value of G is true, and the same value is printed here. So whatever I write here basically is printed here. This is just a placeholder, and this is the actual value. So you can see that we are able to use all the variables here, all the primitive variables basically, which range from byte, character, byte, short, int, float, double, and boolean. Let's get started with non-primitive data types in Java. First of all, let's understand what is the difference between primitive and non-primitive. So the primitive data types are the ones which are by default supported by Java, and non-primitives are the ones which are a bit custom in nature, where you as developer have the liberty to define the nature of that data type. We'll look at some examples of that as well. But when we talk about which all are the non-primitive data types, we broadly talk about arrays, we talk about classes, we talk about strings as well. And we will cover some of them in today's lecture. And we have a detailed lecture upcoming about the classes as well. In fact, in the after a few lectures, we'll cover how we'll create classes as well. But for today's lecture, we are going to focus on string data type and array data type. And like I said, for classes, we have a dedicated lecture upcoming. So don't worry about that. And again, for this particular case as well, I have already prepared a demo for this, and we'll basically do some look at some hands-on examples to see how do we create these variables, what does these variables mean. And the first non-primitive data type we are going to talk about is string. And before I go on further, I should also mention that it's very debatable in the Java community to call string as a non-primitive data type. And actually, technically speaking, string is a special data type. It neither fully lies in the primitive category, nor it fully lies in the non-primitive categories. I'm covering this as a non-primitive data type because it's a bit inclined towards the non-primitive category. Why do we do this? Is because Java does provide native support for string handling in the JDK. And that's the reason some of the developers feel that string is a primitive data type, which is primitively supported by Java. But at the same time, string is so customizable and it's so special in nature. It's the way it stores the value, the way it provides the operations and handlings. It's so different than primitive data types that it cannot fully be put in the same bucket as the primitive data types. So that's why I said it's a special data type, a bit inclined towards the non-primitive category. So what is string basically? We covered about the char data type in the previous lecture, and in char data type, you can only store a single character, right? But if you want to store a complete name of somebody, then it's a list of characters. It's basically a lot of characters together. Then in that case, you would need a data type to store that continuous sequence of characters. And that's what string does. String can store a continuous sequence of characters. Technically, string is basically a character array. You can call string as a character array. And don't worry if you don't understand about the word array. I will explain that in the same lecture. So basically, it stores the continuous sequence of characters. That's how we define string. And you see this string. This is basically the keyword, the data type basically in Java. So whenever you want to create a string, you need to write string with S capital. You need to give a name to the string. This can be anything. And then you can provide the value, which this particular string is going to contain. So you can see this is a continuous sequence of characters. TEST are the 4 characters which this string is going to contain. And after that, again, I'm printing this particular value. And like I said, don't worry about this. We'll cover this when we'll write our first program in Java. So this is just to print the string value. I'm just putting a string placeholder here, and then I'm actually printing the values of the string variable. Now, string can be created in multiple ways in Java. This is one way of creating it. There's another way of creating a string variable, which is this one, which says, again, the string data type, some variable name, a keyword called new. Again, don't worry about what is this new keyword. We'll cover this when we'll talk about running our first program in Java and writing the first program from scratch. Then we again say string, and then we provide the value. So if I compare this line number 4 to line number 7, you can see the difference is that I'm still storing the same value, test, but the difference is that here there is no new string keyword, but here we have this new string keyword. So what is the difference? The difference is this, that in this case, in this particular case, string is going to reuse the same object multiple times. But in this case, every time you call this, it is going to create a new object. Again, what is object? It's just, you can think of it as, for now, you can think of it as a memory block. We'll again cover objects in details. But these are 2 different ways in which you can create string. This is generally the most popular way of doing it because this is memory efficient, because you can reuse the same variable again and again. So I'm creating the string variable here and creating another string variable str1 here and printing both of them. Then I've created this strange looking thing here, which is basically an array. Array, like I said, is also a non-primitive data type in Java. And array can store a continuous sequence of anything. That anything can be a number, that anything can be characters, that anything can be a floating number as well. So basic idea is that if you want to store a collection or a sequence of multiple values, how do you do that? You do that with the help of arrays. Array is a data structure, a non-primitive data structure in Java, which can store lot of values of similar type. We also call it as homogeneous data structure, because it can only store same data type values or homogeneous data type values. So the biggest way to identify array is this square bracket. Whenever you see this square bracket in Java, it means it's an array variable. So here I am creating an integer array variable with the name ARR. This is the name of this particular array. It is only going to store integer values because I've specified int. And the moment I provide the square brackets, it means that it is an array. So you can declare an array like this, and then you need to assign a size to the array. Size is basically denoting how many values this data structure is going to store. So I'm saying new, again, it's a keyword, and I'm saying that, okay, create a memory block for storing 2 integers. So this particular array ARR can store at max two values at continuous locations. The next thing about array is that it stores the value in a zero index based location. So like I said, it can store two values. So the first location will always be array of 0. And this is how you specify the location or index of the element which is going to be stored. So at the 0th location of this array, I'm storing 0. The first location of the array, I'm storing 1. And this is just to show an error scenario, but I will just comment this for now. You can just put double slashes and comment any line. So I'm just storing, filling up this array for two values, and the two values location would be 0 index and first index. These are just continuous memory locations, and we denote those memory locations as 0 and 1. Array indexes always start with 0, and I'm just putting some values here. You can put any values. And then I'm printing the whole array, and I'm also printing the first value of the array. And we'll see how this pans out, and we'll also see how we can change this. So now we are going to run this application. So I'll just go to run as and click on run as Java application. And once I hit that, I get this output here. So let's understand this output. The first one is I'm just printing the string, which has the value test. And you can see it has printed here. It is coming from this line. Then the next line which is printed is line number 8, where I'm saying another string str1, and str1 also had the same value. So you can see another string has the same value. And then I have printed the array here, the complete array. And you see this strange value here. It also tells us that if you want to print the array, then you cannot just put the variable name and print it. The reason is because this is a non-primitive data type. And once you do this, it is basically printing the memory footprint of this array, the whole memory location where this array is stored. That's why you see this strange looking number, which is the memory hash code. And if you want to print any particular value or any particular element inside this array, then you can do that by providing the index location of that element. So here I've said that print the 0th location element of the array. The 0th location array element of the array was 0. So you can see the value 0 here. Let me put some other value just for fun and show you how this works. So I've just changed the values, and now let's see what do we get for array 0. You can see now I get value 3 because now at the 0th location, the 3 value is being stored, and that is what is being printed here. We can also print the first value. I'll just go run as Java application. You can see now the array of first index is being stored, which is basically technically the second element of the array. But because array always works on a 0 index based value format, that's why when we say array 1, the second element is printed. When I say array 0, the first element is printed. So always remember that array is a 0 index based collection or data structure basically. What happens if I do this? Now there is no third element in this array because the array has the size only of 2 elements. And when I say ARR of 2, which means I'm trying to print the third element in this array, which does not exist. So let's see what happens in that case. I get an exception. Exception is basically an error. I get an error saying that index 2 is out of bounds for length 2. It means that the array length was actually 2 and index 2 does not exist. Remember, it's saying index 2, not the element 2. Index 2 doesn't exist because only index 0 and index 1 exist. This makes 2 elements and the actual size is also 2. It does not have capacity to store third element. It does not have third element location anywhere. That's why it complains that you are trying to print a non-existing value. Let's get started with how to write your first program in Java. Once you have created your Java project, so your Java project might look like something like this. You will have an src folder here. So, and under the src folder, you see some namespaces sort of things created here, right? We call these as packages. And in Java, you can think of package as something which can group multiple related artifacts together. This is simply a grouping mechanism, I can say. It's a way to put all the related artifacts to a particular business problem into a certain place. For example, if you are working in an e-commerce application, so you might have created multiple Java files for, let's say, for checkout, and then some more Java files for the filters flow, I would say, then some other Java files for designing the advertisements. So you have multiple Java files and these Java files now belong to these 3 different domains. So you want to group them together for easy accessibility, for referencing each other files within the code. So if you want to achieve that kind of flexibility, you would group the checkout code files into a single package. You can name it as checkout package. Then you can similarly do the same thing for the advertisement package and for the filters package. So similarly, I have created some packages here, which you can see. You see a package here which says IO GitHub Vikesh Pandey Hello World. And how do you create a package? You just right click on this. So you go to the SRC and you right click, you go to new, and here you will see this option which says package. So you can just click on this and write anything which you want as the package name. Let's call it as test package. It says invalid because the package is a keyword, so it is not allowing me to put package here, but let's call it test package 1, and you can just click finish and you will see a test package popping up here. Then you can right click on this again, go to new, and then you can create a Java class. Now what is a Java class? A class is basically a blueprint for an object. It's basically the specifications of an object. Like I covered in the very first lecture, everything in Java is an object, or most of the things in Java are object, I would say. So object is basically an instance of the class. So let's say you create a class for, if I take the same example of e-commerce, you create a class for writing the business logic of checkout, and then you create instance of this particular class to work for a particular customer order. So class is basically a blueprint. It's the specification, it's the skeleton of the object. So once you click on this, you can create a class. Now Eclipse is a pretty smart IDE. It will provide you with bunch of options on how you actually can create a class, and it will also provide you with some sensible defaults. For example, it will automatically select a source folder in your project which you have created. It will automatically select a package. In fact, they currently selected package. And if you want to change the package, just hit browse and choose any other package which you want to choose. So your class file will be created in that package. Then you can provide a name to the class. So let's call it as test hello world. And you can see I have followed a sort of a naming convention here. The first character I've kept it as capital, and then any other new word which is coming in my class file name is also capitalized. So Java would expect you and it would encourage you to follow this naming convention, that whenever you are creating a class, always start with a capital letter, then small letters, and every new word you are writing can start with a capital letter again. Java will not throw an error if you don't do this H capital or W capital, but it's a good practice. The next thing is the modifier. We are going to cover the modifiers in details in the upcoming lectures, but for now you can understand that anything which is marked as public is accessible to every other Java class in this whole project. That's the basic meaning of making a class as public. Public, as the name suggests itself, it means it's visible to everyone. You can select a superclass, and again we'll talk about this superclass later, but this is the Java.Lang object is the superclass of all the classes which are created in Java. Again, interfaces again an advanced concept, and there are some other interesting defaults it provides. For example, if you want to create a main method. Now what is a main method? We'll just cover it in a while. So I will not do that. I will leave everything as default and I will click on finish. So I have this new file coming up here, and you can see it has automatically picked up the package which I selected, and it has also written public class test hello world with a starting and ending curly braces. In the previous lecture, we covered about these curly braces, that all the code block have to be in the curly braces. Whenever you write a Java class, the very first statement Java would expect to have in the class is package name. So make sure that you have package as the keyword and then the actual package name as the package name for that particular class. You can see the package follows a dot convention and it always ends with a semicolon, like all the Java statements end with semicolon. So that would be the first thing which you will write in your class. Second thing is the access modifier of the class. Like I said, you want this class to be accessible to every other file in this project. Then you can mark this class as public. The next thing is the class keyword. You need to write this particular keyword as is, otherwise your class will not be detected. So you write this as class. then you write test hello world or whatever name you want to write. But make sure that whatever public class name you provide here, that name should match with the file name. These two things should match, the file name and the class name. If they don't match, you would experience weird behaviors as the class will not be compiled or class might not be able to run, etc. So always make sure that whatever file name you provide, you always have a class with that name in your file. So my class structure is ready, but there's nothing here in this class. In fact, you cannot even execute this class, because for executing the class, for executing any class in Java, any class at all in Java, you would need a main method in Java. Main method is the entry point method of the Java. Whenever you are trying to run any application, be it a very small or very large Java application, you would always need a main method in the class, in the project somewhere. And you need to tell the Java runtime to execute that class, and then the class will have a main method and your program will start executing. So always have a main method, otherwise your program will not execute. And how do you write the main method? So you first write public, then you write static, then you write void, and then you write main, and then you provide a parameter to this method as this. Now let's understand what did I actually write here. First keyword is public, because this method has to be public, because like I said, Java runtime needs to be able to access this method. So the similar concept which applied on the class is applied on this method as well, that the entry point method has to be public. Otherwise, Java will not be able to find this method. So you need to make this method exactly as public. The next keyword is static. You again need to write this keyword as is. And the reason we write static here is because we want to run this particular class without creating an object of the class. Static is again a keyword which we'll cover in the upcoming lectures. But for now, you can understand that whenever you want to access something within the class without creating an object, then you need to create it as static. The next is void. Void is basically the return type of this method. The method name is main, and it has to be main. It cannot be main1 or main2. Otherwise, if you do that, Java will not be able to run your program, because it will expect you to write this particular method exactly as what I have written here. No changes at all should be there. If you make any changes, Java program will not run, because it will not be able to find the entry point method, which is the main method. So public, static, void, main. Remember that you need to have this in your program. So void is the return type, which means that this particular program, it will not return anything back to the runtime, because a method can have this capability to either return something or not return something. For example, a method which can add two numbers will return the result of addition, right? So we return the result. Return is the word here. In this case, this method is not expected to return anything, because there's nobody consuming it, right? Java runtime will not do anything with the return value of this particular method. That's why Java will force you to write void here, and main is the exact method name which you need to use. Java will expect you to supply a string array argument. If we covered arrays in bit detail in the previous lectures, and we will cover arrays in the next lecture in very detail. But you can, as we discussed, that array is basically a sequence of characters or words or integers or anything, right? So in this case, this is basically the mandatory parameter which you need to write as is. This parameter name can be anything, obviously. It can be arg, args, or whatever you want to write it as. But the basic fundamental is that Java will basically supply all the command line arguments using this particular string array. That's why you need to provide this. Then let's write something in the program, because this is a hello world program. So I will just write system.out.println, and I'll type a string here which says hello world and a semicolon. So again, I have been saying that I will explain this, and now I will explain this. Why do we need this and what does this mean? So as I've told earlier, that whenever you want to print something on the console in a Java program, you need to write system.out.println. Now system here, if you just hover over it, Eclipse will show what it is. So system is basically a class which contains several useful class fields and methods. It cannot be instantiated,
means you cannot create an object of it, and it provides many facilities like standard input, standard output, and error output. Exactly what we want to focus here, because we want to use system class to print something on the standard output. The standard output in this case is the console. So if you want to input something, or you want to output something, or you want to output an error, then you need to use system class. And all of these standard input, standard output, and error are streams. And that's what comes to the next word. What is this out? Out is a stream to print standard output. Similarly, we have system.err, which is for printing the error output streams. Similarly, we have system.in for taking its standard input streams. So system.in, system.out, system.err, these in, out, and err are streams. And then println is the actual method. Let's hover over that. Let's first see out here. So you can see this is a stream object which is used to print anything, which is ready to accept output data basically. And then we go to the println method, and it says prints a string and then terminate the line. So like I mentioned earlier as well, this whole syntax is used to print, and actually this is the core method. This is the real method which prints something on the console. So system class uses the output stream to print something on the console using the help of println method. There is also a print method. So there are two methods. One is print and one is println. The difference is that in case of print method, the print method will not provide you or terminate on a next line. But in system.out.println, the ln means line here. It will print something and it will bring the cursor to the next line. If you do not use this, and if you again use another print statement, then both of the statements will be printed on the same line. I will show that as well. But and then we provide any random string here which we want to print. So you right click on this particular program, you go to run as, and you run as Java application, and you want to save this. So you can say always save resources before launching, and you see the output here. So this is how you can run your first Java program. Now let's also see the difference between system.out.println and system.out.print. So I will just copy this here and I'll say hello world 1, let's say. And this time I will not use system.out.println, but I will use system.out.print. Just put a space here so that it's visible. So if I use print, how does that look like? I go to run and I go to run as Java application. So now you see both of the outputs are printed on the same line. There is no, this output hasn't gone to the next line. And now if I run the same program with system.out.println methods, now both of these outputs will be divided on two lines. The first output, then a line break, the hello world 1 goes to the next line. In the previous run, the hello world 1 was printing right next to it on the same line. So that is the difference. So this is how you can build your very first program, the hello world program in Java. Let's get started with arrays in Java. We discussed about arrays in a bit detail when we talked about the non-primitive data types, but this is a concept and a topic which needs to be understood well. So that's why we'll do a deep dive on arrays in this particular lecture. So as I described earlier, that array is basically a container which can store values or a sequence of values or sequence of numbers or sequence of characters into itself. We can think of it as a box which can store all the values in a continuous fashion. As you can see here, this is just a pictorial representation, and this is coming from the official Java docs. And you can see that if we create an array of size 10, then we have these 10 blocks created here. You can see 1 to 10th. So the whole length of boxes, the number of boxes here are 10. But the way arrays are designed is that the index is basically used to access the element in this particular box. The index of the boxes start from 0. So it goes from 0 to 9. So remember, the array length is 10. The array can contain 10 elements, but the index of the array starts with 0 and will always end at length minus 1, which is 10 minus 1 in this case, which comes as 9. So it will always be length minus 1. It will always the index will always start from 0 and go till length minus 1. Length can be anything. In this case, the length is 10, so the index ends at 9. If the length was 20, the last index will be 19. But in total, you have these 10 memory locations. We also call them as continuous memory locations because they are continuously placed. An array basically blocks 10 memory locations and creates a container over it. So this is how an array basically looks like inside the memory. And whenever you want to access the elements of the array, you will say array of 0 or array of 1 or array of 2. You basically need to specify the index to access the element at index. For example, if you want to access the element which is sitting in this box, you need to say array of index 8. And we'll see how we can do that. But this is the basic understanding and idea of the concept of arrays. So let's try to understand this with the help of an example. I will switch back to Eclipse IDE. And I've created a very simple program here to demonstrate the functionality of arrays here. So we already covered in the previous lecture of what is package and what is public and what is class. How do we give the class name and what is the meaning of this particular method. So I'm not going to cover that again. We'll start directly from here. So here the first thing which I'm doing is I'm declaring an array of integer. This is a variable name, the identifier basically. It can be anything. And this is the data type. It's an integer array, and as we covered this as well, that whenever you put square bracket in front of a data type, it becomes an array data type. So this is an integer array representation. Now we just declared an array, but we still haven't allocated a size to it. So you can do that with this particular syntax. So you can put the variable name of the array and say new int and put the right size here. This size can be anything. And once you do this, now array will actually allocate those memory boxes which we covered here. The moment you do new int 10, these boxes, continuous boxes will be placed in the memory and the memory is allocated to this array. We call this memory allocation. This is how you allocate memory to the array. So we allocated memory to this array for storing 10 integers. The next thing is now we can start storing elements in those boxes. So like I said that the array index always starts with 0. So if you have to store the first element, you actually have to store it at index 0 location. So you give the array name, you provide these square brackets and you put the index value within the square brackets. That is how you basically point to a particular element inside the array. So we say an array of 0 and we put the value 100. Then we initialize the second element which will be index 1. Then will be the third element which will be index 2, fourth element index 3, fifth element index 4, sixth element index 5 and so on until we store till the last element. So this is the 10th element which is accessible as index 9 and the value is 1000 basically. So from 100 to 1000 we stored 10 values in this array and we stored them by accessing the index, and this is actually the only way you can store values in the array, by pointing to the indexes. So we go from 0 to 9 and we stored all the values, 0 being the first element and array of 9 being the last and the 10th element. Remember the length minus 1 concept. Okay, so now we will try to print all the elements one by one. That's pretty much what we are doing now. So as we covered in the previous lecture that we use system.out.println to print anything, and we understood the whole meaning of this, so I'm not going to repeat that. Now we want to print the first element. The first element is sitting at index 0 and we can access that element with this syntax by providing the variable name and the actual index value. So I'm just writing a random string here which says element at index 0, and then I'm putting this plus here and putting the variable name. This plus is basically used to concatenate the output of a static string with a random variable, or basically you can print anything with using plus. Plus is used for concatenation. So I'm just trying to print this whole value, but here this is a string value which is a static string, and then I have a value coming from the array. So whenever you have to print some value from a particular data type or variable or collection, then you can use this plus syntax to concatenate a string, static string, with your actual value. So that's what I've done here by saying plus and array 0. And similarly for index 1, I'm printing the first index, then for 2, 3, so far and so on so forth till the index 9. So basically I'm just printing all the values of the array starting from index 0 to index 9. So That's all which is written in this program. Now let's try to run this program. So I will right click, go to run as, and go to Java application and hit on this. And now if I just expand this console, you can see all the system.out.println statements have been executed and they printed this. So this is the static string part, in fact including the colon. This is the static string part, element and index 0, printing exactly as is, and then dynamically the 0th index element of an array is printed here. Similarly, we have printed the index 1 location element, index 2 location element, index 3 location element, and so on and so forth till the index 9 location element. So in total these are the 10 elements, but the index always works from 0 to length minus 1. In this case it will be going from 0 to 9. So this is basically all which I wanted to cover in this lecture. The whole idea was to give you more understanding of arrays, and remember this is just an integer array. You can similarly create a character array. You can also create a string array for you as well. So it's completely related to the data type you are using. If you create a char array, then you can only store characters into it. If you create a string array, then you can only store strings into it. And now you can probably relate back to this particular thing which I explained in the previous lecture, that we create this string array for the reason that when you run this particular program, and if you want to provide any command line values, command line arguments to the program, those arguments will automatically be stored in this args, and then you can access this as args of 0, args of 1, etc. in your program. That's the whole concept. Let's get started with operators in Java. When we talk about operators in Java, there are multiple types of operators like assignment operators, arithmetic operators, unary operators, then we have conditional operators and logical operators, and we also have bitwise operators. And we will cover all of these operators one by one. We will understand what these operators are and how they work, and we will also look at a demonstration of it. So let's get started. The first operators we are going to discuss is about arithmetic operators and assignment operators, and we will also see if we can cover unary operators. So when we talk about assignment operators, I have again opened the official Java docs here. If we understand assignment operators, we have been using these operators all the while in all of the demos so far. And the basic idea is very simple. Whenever you assign a value to a variable, you use the assignment operator, which is nothing but the equal sign. We have already covered this in multiple demos, so I will not cover this as part of the demo. But what I'm going to cover in detail is about these arithmetic operators. So arithmetic operators are basically used to perform any kind of arithmetic operation on a Java program. It can be an addition operation, it can be a subtraction operation, it can be a multiplication operation, a division operation, or an operation by which you can find the remainder of the division. So we will look at each of these with an example. And as you can see, the symbols are expectedly what you generally use in mathematics. So you see the plus sign here, which is for addition. You see the minus sign, which is for subtraction. You see the star sign, which is for multiplication. You see the slash sign, which is for division. And you see the percentage sign, which is for finding the remainder of a division. So let's see an example of each of these and how we can use them in a Java program. So for the arithmetic operations, I have prepared a demonstration of it in the Eclipse IDE. Again, I'm using the same Java project which I have shown you we created in the previous lectures. So for all the demonstrations, I will just continue in the same project. So again, the way to create a class remains the same, exactly the same as how I covered in the previous lecture in the Hello World program where we created a class. So here also I created a class. I named the class as arithmetic demo, and I have a public static void main method inside this particular class. And I have basically tried to demonstrate each of the operation. So let's start with the addition operation first. So I create an integer variable here named as result, and then I try to use the addition operator to make this variable store the result of this addition. So it's a simple 1 plus 2. You can also create two different variables for 1 and 2. Let's say x equal to 1 and y equal to 2. And you can also do int result equal to x plus y. It will have the same effect. But just for simplicity, I have put the literal numbers here. So result is storing the expression value of 1 plus 2. And then I'm printing this value here. You can see I'm printing the result variable here with using system.out.println. Then I'm storing this result into a variable, into a new variable, original result, with using the assignment operator. And then I'm trying to subtract something from it. So now I'm saying result equal to result minus 1. It means whatever the current value of result is, subtract minus 1 from that value. So the value was 3 here, and here 3 minus 1 becomes 2. So the new value of result becomes 2. The original result still holds 3 because it is storing the old value. The new value of result has now become 2. So I'm printing the original result, and then what I'm doing, that I'm again assigning the new result, which is 2, to the original result. So now original result and result both are at 2. Then I move ahead and I try to demonstrate the multiplication operation. So I take the same variable result and I say multiply it by 2. So whatever the value of result was, which at this place should be 2, multiply that value by 2. So 2 into 2, the new value of result should become 4 after this multiplication operation. And again, I'm assigning the value of original result to this particular variable. And then I'm showcasing the fourth mathematical arithmetic operation, which is division. So you can see result by 2 here. So basically, whatever the current value of result is, I'm dividing that value by 2. So 4 divided by 2 should become 2. So again, the new value of the result variable should become 2. Then I'm printing the value and again storing the value back into the original result. Then the next operation is again an addition operation, where whatever the value of result is at this particular point, which is 2, add 8 to that particular value. So the new result value becomes 10, and then I'm printing that particular value, again assigning the original result to the result. And then to showcase the remainder operation, I'm doing result. We call this particular operator as mod or modulus. So result modulus 7. So the current value here is, in this case, would be 10. So I'm saying 10 mod 7. So 10 mod 7 would become 3, because if we divide 10 by 7, the remainder should be 3. And this modulus operator is used to calculate the remainder of a division operation. So that 3 will be stored in this result variable, and then we print that particular variable. So that is what I'm doing. If I take you back up there, I'll just minimize this window and this window as well. So if I take you back to the starting, I'm doing an addition first here at line 7. Then I'm doing a subtraction at line 12. Then I'm doing a multiplication at line 17 and a division at line 22. And then again an addition at line 27. And then a modulus at line 32. And I'm printing the respective values. So let us run this program and see what results do we get. So I right click, I go to run as, I go to Java application. There is also a shortcut for it. If you want to use the shortcut, you can use that. So I click on this and the output is displayed here. So you can see, let me bring this output back to its original position. Yeah, I just dragged it here to the top, to the bottom. So if we start from the top and see what all results did we get printed. So line 9 says 1 plus 2 equal to the value of result. So 1 plus 2 equal to, at this particular point, the result value was 3, because 1 plus 2 equal to 3. Moving on, the next variable here is minus. So the current value was 3. We said 3 minus 1, which becomes 2. And we store the value of result, or 3, into this result variable, and we print that value at line 14. So original result plus original result is 3. Then a string here, minus 1 equal to. So this is just a string. And then the actual current result value, which is 2. So far so good. We move ahead, and then at line 19 we are multiplying the current value of result by 2, and again displaying the original result and the current value. So 2 is the original result here, because here 3 minus 1 had become 2. So original result value was 2. Multiply that by 2 becomes 4. Then moving on to the line 24, 4 by 2 should become 2. So 4 by 2 equals 2, the current value of result. Then again moving on to the next variable at line 29. Now the result value should become 10 because 2 plus 8 is 10. And again we are printing the original result and then the current result value. So the original result was 2, then we added 8 to it, and the new result value had become 10, which is coming from this particular variable. Moving on to line 34, we are again printing the original result, which was 10 here, and then we are saying this particular string, which is modulus 7, and the current value of result is coming from this expression, which is 10 modulus 7. And like I said, modulus or mod operation is basically used to calculate the remainder of a division operation, so 10 divided by 7, remainder is 3. So that becomes 3, and that's why you see the value 3. So this is a demonstration to show you how we can use the addition, multiplication, subtraction, division, and modulus operators, which are all the arithmetic operators.
Let's get started with equality and relational operators. When we talk about relational operators, they are sometimes also called comparison operators. And the basic idea behind using these operators is to compare things or compare the values of variables or compare the objects in Java. So in Java, if you need to compare anything, for example, if you want to compare if something is less than the other thing, or something is greater than the other thing, or something is equal to the other thing, then you need to use the comparison operators which are provided by Java. Here you can see I have opened the official Java docs, and you can see a bunch of comparison or relational operators. Both of the terms are used interchangeably. Some people call them comparison operators and some people call them relational operators. So you can see if I want to compare if an object or a value is equal to another value, then I use the double equal sign. If I want to compare for non-equality, I will use exclamation with an equal to, which means not equal to. If I want to do a greater than comparison, then I will use the mathematics greater than symbol. If I want to do the greater than equal to or less than equal to, they again follow the same kind of terminology as we see in mathematics. So this is all we have in terms of the relational operators. So let's understand the usage of these operators with the help of some examples. So as you can see, I have created a class here, which is called comparison operator. There is a public static void main method inside this class. And this method has two variables of integer type called value1 and value2. Value1 has the value 1 and value2 has the value 2. And then I am trying to compare the value1 and value2 variables using the different relational operators we just covered. For doing that, I need to use a conditional operator as well. We will be covering conditional operators in much detail in the upcoming lectures. But for now, you can understand that when we talk about conditional operators, we talk about if and else statement. So if is again a keyword in Java, which can be used to compare things. And the syntax is very straightforward. You write the if keyword, and then you write the actual comparison syntax or the actual comparison expression. So in the first example, we can see that I'm writing a condition which says evaluate if value 1 is equal to value 2. I should put a curly braces around here. You can see there are no curly braces here, but that is for a case when you have only one statement under it. But again, I will cover this in detail and I don't want to confuse the audience here. So I will just put curly braces around all of these if statements so that it becomes easy to interpret what is actually going on in these code blocks. As we know that these curly braces are used to define a code block. So the first if block says compare if the value 1 is equal to the value 2. If yes, then this condition will become true and the control of the program will go at line number 10. If this condition is not true, then the control will not go inside 10 because this condition is false. So it will never go to line 10 and it will move to line 11 or 12 instead. Similarly, the next condition is we are comparing the value 1 is not equal to value 2. So this condition will only be true if these two values are not equal or unequal. And if that is the case, then line 14 will execute it. Otherwise, line 14 will not be executed. Similarly, in this condition, I'm saying compare if value 1 is greater than value 2 or not. So if the actual value holded by value 1 variable is greater than the value 2 variable, then this condition will become true and the line 18 will be executed. Otherwise, it will be skipped. Then similarly at line 20, I'm doing the reverse. I'm comparing if value 1 is less than value 2. If that is the case, then line 22 will be executed. Otherwise, it will be skipped. And at last, I'm also showcasing an example of less than equal to operator, that you put less than and equal to together, and again you compare the two variables. Similarly, you can also use greater than equal to variable comparison operator as well in this example. So we have an example of equality, not equal to, greater than, less than, and less than equal to. Let's run this example to understand. So for running the example, I will just right click here, go to run as, and click on Java application. And we can see the output here. So as the value 1 holds the value 1 and value 2 variable holds the value 2, obviously 1 is not equal to 2. So the first condition is not going to be evaluated to true. So line 10 will never be executed because 1 is not equal to 2. Similarly, if I talk about the next condition, which was if value 1 is not equal to value 2, then execute statement 14. And yes, 1 is not equal to 2. That's why we see this particular system.out.println here. We see this printed. Moving on, is value 1 greater than value 2? So is 1 greater than 2? No, it's not. So line 18 will never be executed. Then the next one is value 1 less than value 2? So yes, 1 is less than 2. So line 22 will be executed. And we see the line 22 output here, system.out.println output. Moving on, is 1 less than equal to 2? Yes, 1 is less than equal to 2. So this particular condition is also true and line 26 will be executed. And that's why we see this here. And that's all. So we can see that we are able to use these comparison or relational operators to evaluate different conditions. And we write those conditions using the if block. And again, if you do not understand the if block fully, don't worry, we will be covering the if blocks in detail. But the focus here is in using the operators, the not equal to operators, the greater than equal to operators, less than equal to operators, etc. So I hope these operators give you better understanding of how to use them. Now moving on to the next section of this comparison operators, sometimes we also use some logical terms to do the comparison. For example, if I just move down here and I show you these conditions here, we call them conditional operators. Conditional operators are used to evaluate the conditions like and or, and we use them in two ways. Either we can use it as ampersand or double ampersand, or we can use them as pipe or double pipes. So the idea is basically to evaluate if one condition is true and other condition is also true, or one condition is true or other condition is true. So whenever you want to combine two conditions together, that's where you're going to use these logical operators or conditional operators. You can also use the simple English keywords like and or you can use the logical representation of these keywords. For example, ampersand, ampersand, or double ampersand is equivalent to and. Similarly, double pipe is equivalent to or. So we can use these as well interchangeably. You can use either of these operator representations to run a conditional check in composition, meaning you can compare two conditions saying, okay, if one is true and second is true, or one is true or second is true. So the whole focus is here in and or comparisons. So let's switch back to the IDE and let's look at an example of this to understand this in detail. So I will again take the similar kind of example. Again, I have created two variables here, value 1 and value 2. Value 1 has value as 1 and second variable value 2 has value as 2. And then I'm writing two conditions this time in the same if block. You can see I am writing first condition saying is value 1 equal to 1 and is value 2 also equal to 2. So this whole if condition is only going to be true only if both of the conditions are true. That's the property of and will force that both the conditions on the left hand side of it and the right hand side of it hold true, and then only the whole expression is going to hold true. Even if one of the conditions evaluate to false, the whole if expression will evaluate to false. Similarly, for or conditions, we again write a left hand condition and a right hand condition, and in between we write this double pipe. We can also write or in English. that will also have the same effect. And this will evaluate in a way that this whole expression will evaluate to true if even a single condition, either on left side or right side of it, becomes true. So OR will just need one expression to be true to make the whole if condition true, whereas AND will force both of the conditions to be true to make the whole expression as true. So AND will require two trues to actually become true, but OR condition will require only one true to become true. So if we try to understand this logic, here I'm saying that if value 1 is equal to 1, which is correct, and value 2 is equal to 2, then make this condition as true. So yes, in this case, this condition will evaluate to true because value 1 has value 1 and value 2 has value as 2. So it will print the line 10. Whereas in the next condition, I'm saying evaluate if value 1 is equal to 1 or value 2 is equal to 1. So either of the expression if becomes true, either the left side, this expression, or the right side, this expression. Either of the expression becomes true, this whole condition will become true and line 14 will be executed. Line 14 will not be executed only in a case when both of the conditions here become false. For example, if I write it like this, then we know that value 1 is not equal to 4 because it's 1 and value 2 is not equal to 5 because it's true. In that case, both of the expression will become false and then line 14 will not be executed. If I write it like this, then the left hand expression is evaluated to true because value 1 is 1, but the right hand expression is false. But it's fine. The line 14 will still be executed because either of these side is true, so the whole expression becomes true. Similarly here, AND will require both of the expressions to be true, and if either of them becomes false, then the whole expression becomes false. So in the current state, line 10 will be executed, but if I change this to this, then the left hand side of this ampersand will evaluate to false, and the whole expression will evaluate to false in that case, and line 10 will never be executed. Let's try to run all of these scenarios to make a better understanding of this. So in this case, both of the conditions should work fine. So I will just right click and run as Java application. And yes, we see this line 10 being printed, and we also see this line 13 being printed. So both of the lines are printed correctly. Both of the conditions are evaluating to true. Now let's try to play around with it. Let me change this value to 4. So now value 1, this left hand side expression is false, which should make the whole expression as false, and it should not print the line 10, which is this statement. So let's run this program and see if that works. Yes, we see that this particular line is not printed now because this whole expression became false because the left hand side of this expression became false. Similarly, in the OR case, either of them have to be true. You can see currently value 2 equal to 5 condition will actually result in a false condition because this is not a true. Value 2 is actually 2, not 5. And still we see this particular expression because either of them have to be true. If I make both of them as not true, now both of the conditions on the left hand side of pipe and right hand side of pipe are false conditions. What will happen now? Nothing will be printed. The reason for that is that value 1 is also that this condition is also false and value 2 condition is also false. So the whole expression became false and this was already false. So this is all I wanted to cover in this lecture. We covered about the comparison operators and how to use them. And in the next lecture, we are going to talk about the bitwise operators. Let's get started with bitwise operators. Now, bitwise operators are very less commonly used in the Java programming world. Generally, we don't use them, and generally, we don't need to use them. You would generally use them when you are doing really complex bitwise calculation where you need to manipulate the bits. Now, what are actually bits? So if you remember when we talked about the integer type variables, we talked about how much memory each of the variable type or data type was going to consume. We said that this will take 1 byte and this will take 2 bytes, etc. 1 byte is basically made up of 8 bits, and bits are nothing but positions where either a 0 is stored or 1 is stored. Actually, the whole machine will convert your whole program ultimately in zeros and ones, which are nothing but bits. So if you want to do the manipulation at that level, so now you can understand you are actually working right at the machine level understanding. So if you want to manipulate the bits which are going to be understood by the machine at that level, then you can use bitwise operators. But like I said, generally we don't need to use them. Now, when we talk about bitwise operators, there are multiple ways in which we can use them. We can use them with the standard AND or operations. If you remember, we covered this AND or operations in the previous lecture. You see a difference here that in case of AND, we are using a single ampersand and not double ampersand. This is one of the concepts which we did not cover in the previous lecture. And I would just like to brief you about this concept that if you use double ampersand, that is also called a short circuit operator. And if you use a single ampersand, that is called a standard operator. To build an understanding about this, I will just quickly recap of what we covered in the last lecture and we'll try to explain these concepts as well. So let's go to the logical operator demo. And here, if you remember, there were two ampersands and two pipes. This is also a valid expression. A single ampersand is also a valid expression. The only change is, in this case, even if the left hand condition evaluates to false, still the right hand condition will be evaluated. Although we know that in case of AND, either of the expression needs to be false and the whole expression becomes false. So Java provides an advantage with that if you use double ampersand, and if the left hand operation becomes false, then it will not cover the right hand operation. It will not even evaluate the right hand operation because it doesn't matter. If the left hand operation has already returned to false or evaluated to false, then no matter whether right side is true or false, the whole expression is still going to be false, right? That's the property of AND. One of the side has to be false and the whole expression becomes false. So why evaluate two sides? Why waste the memory in evaluating the right side when the left side has already turned as false? Java takes advantage of that. And that's why if you use double ampersand, you save a bit of processing power of your computer by just evaluating the left hand condition. And if the left hand condition is false, it will skip evaluating the right hand condition and just make the whole expression false. But if you use this, a single ampersand, then both sides of the expression will be evaluated irrespective of their output. So in this case, even if the left hand expression is false, it is still going to evaluate the right side expression. And similarly, it works for the OR case as well. In this case, in OR case, as we know, if one of the condition is true, the whole condition becomes true. The whole expression becomes true. So if the left hand side becomes true, and if you use a single pipe, then it will still evaluate the right hand side. But if you use double pipe like this, then if the left hand side becomes true, then it knows that it does not matter if the right hand side becomes true or false, because ultimately the whole expression is going to be true if either of the side is true. So if the left hand side is already true, it will not evaluate the right hand side and it will say the whole expression is true. That's why you see the single ampersand being used for bitwise, just to explain why it is used and how it is used. For OR operations in bitwise, you use this cap or whatever you want to call it as. And for the inclusive bitwise or operation, you're going to use a single pipe. You also use some shift operations where you shift the value of bit of a particular variable to either left or right. Again, these are very complex calculations. If you want to use that, please read about this and use that. But in today's demo, what we are going to cover is the and or examples of bitwise operations. So here I have again created a class called bitwise operator. I have a public static void main method. I have two variables here, which are int a equal to 5 and int b equal to 7. Now these 5 and 7 are actually stored as bits, as zeros and ones in the computer's memory. So how they are actually stored? They are stored in a standard bit representation, which you may have studied in your mathematics. If to give you a recap, this 5 will basically be written in the memory as this 0 1 0 1, and it starts from here. 2 raised to power 0 into 1 becomes 1. 2 raised to power 1 into 0 becomes 0. 2 raised to power 2 into 1 becomes 4, and 2 raised to power 3 into 0 becomes 0. So 0 plus 4 plus 0 plus 1 becomes 5, and that's how 5 is displayed to you. Similarly for 7, 2 raised to power 0 into 1 is 1, plus 2 raised to power 1 into 1 is 2. So 1 plus 2, 3, plus 2 raised to power 2 into 1, which is 4. So 1 plus 2 plus 4, 7. and 2 raised to power 3 into 0 is 0. So 0 plus 4 plus 2 plus 1, which is 7. And that's how this 7 is built and stored. And now if you try to do this, if you try to write this condition, you can also write the condition into a system.out.println block, and it will basically evaluate this condition. So now if you say A and B, in this case, this is going to do a bitwise operation because this is bitwise operand. It is going to do a bitwise operation, and what would be the result if you do an AND on this? So again, use the same logic as if in case of AND, if 1 is false, then the whole expression is false. So 0 and 0 becomes 0, 1 and 1 becomes 1, 0 and 1 becomes 0, because 0 means false and 1 means true. So if either of them is false, the whole evaluation becomes false. So that's why 0 and 1 becomes 0, and 1 and 1 is always 1. The value of this is again 5, as we already have evaluated. Similarly, if we do a bitwise OR, and if we do this, again, we are doing an OR operation. So 0 or 0, or basically false or false, becomes false. True or true becomes true. False or true should be true because one of them needs to be true. So this is false, but this is true. So the whole value becomes true. And finally, true or true is also true. So this is the final bitwise OR result. And if we convert this into an integer representation, that becomes 7, because 2 raised to power 0 into 1 is 1. 2 raised to power 1 into 1 is 2. So 2 plus 1, 3, plus 2 raised to power 2 into 1, which is 4. So 4 plus 2 plus 1, which is 7. And plus 2 raised to power 3 into 0, which is 0. So 0 plus 4 plus 2 plus 1 becomes 7. And that's how you get actually 7. So let's see if we get 5 or 7 in this bitwise operation. Yes, we can see the values as 5 and 7. So this is a bitwise operation happening. Similarly, you can also use the shift operations where in case if you're using this particular kind of representation or this particular kind of representation, they are called left shift and right shift operations. So if you use this in front of a variable, then for example, this 1 will be shifted here, and this 0 will be shifted here, and this 1 will be shifted here. So that's how the whole value is going to shift. Whole bits are going to shift one by one towards left. Similarly, if you're using the right shift, then all the bits are going to be shifted towards right by 1 bit. That's the whole concept of left shift and right shift bitwise operations. And if you want to know more about this, please read some official examples from the Java doc and some other examples available on the internet to build an understanding on this. So this is all I wanted to cover in this lecture. So in the next session, we are going to talk about the control flow statements like if, else, etc. Let's get started with control flow statements. So what are control flow statements and why do we need them? Control flow statements are the ones which can help you control and define the flow of execution in your program. Now, why do we need them? Is because if we want to evaluate some conditions, or we want to create some branches of execution saying that if this condition becomes true, do this, and if this condition becomes false, do that. So you can see there are two different branches of execution of a program in this kind of approach. And that's where control flow statements can help us. There are a lot of different types of control flow statements like if, then, else, and switch, and for, and while, and do while, and we are going to cover all of them in detail in this series. So let's get started with the first one, which is the if statement. We covered briefly about this when we talked about operators, and I promised you guys that I will be covering this in detail, and this is the session where we will go deeper into this concept. As we have already understood that if condition is basically used to evaluate a condition if it is true or false. The result of an if statement will always have only two values. It can either have a true value or it can have a false value. There is no other possibility or there is no other value of an if statement or of an if expression. Now, like I explained, if you want to do a simple programming execution where you say if a particular condition becomes true, do this. And if this becomes false, then do that. It means you need to write this else condition as well, that if this doesn't hold true, what do I do and how do I write that? So let's understand that with the help of an example. For this particular example, I've created a class and there is a public static void main method, which is the entry point of this program's execution. I have a variable which is called test score. This is an integer variable with the value 76. And I have a char variable, which is grade. Basically what I'm doing, that based on the test score marks, I'm trying to define the grades which a student will get. So for that, I have built a condition here. So you can see it starts with if, which is a keyword. Then you put these standard braces or brackets and you write your condition inside it. In this case, I'm writing the condition saying that if test score is greater than equal to 90, then the student should get an grade A. So here I've defined this grade variable, and here I'm just assigning the value to the grade variable at line 11. If the test score is greater than 90, the grade should be A. But what if the score is not 90? What if this condition becomes false and you want to do something? In that case, you can write this else block here. We call this else block. So you write else as the keyword, you start the curly braces, and then you define the grade. If the score is not greater than 90, what should be the grade of the student? So in this case, we are saying the grade is F. So if we try to run this example in our mind, we see that the value is of the test score is 76. So 76 is not greater than equal to 90. So this particular condition will not be true. So line 11 will not be executed, but instead else block will be executed, because if the condition goes false, then else block should be executed as per Java. So this block will be executed and grade will get a value of F. And then we are printing this grade value by just writing a system.out.println, a string plus the value. So let's run this particular program and see what happens. We get a grade equal to F here in this sysout or system.out.println. Because this condition was false, so the flow of the control of the program went to line 12 and then to line 30, because this was the else block. So this is one understanding where we can write an if and else logic. In some cases, you might not need an else block. So else block is not mandatory. It's an optional block. If you want to remove this, and if you just want to do a sysout here, that is also fine. Sysout means system.out.println. For shorthand, we sometimes call it as sysout. So you can do something here as well if you don't need the else block. If you need the else block, feel free to write it, but this is an optional block. But in some cases, your conditions will be more complicated than just a single condition. If you try to understand it from a real world example, in real world, you will not have only two grades as A and F. You will have more grades, right? A, B, C, D, so on and so forth. So what are you going to do in that case? For that kind of case, Java provides us with a keyword which is called else if. Else if is just a continuation of if, saying that, okay, if this condition doesn't hold true, evaluate the next one with an else if. So I've commented out this code. Let me put this code back into its place, and then we will walk through this code to understand it. Okay, so I have put the code back to where it should be, and this is how it looks like. So let's just walk through this. The line 10 and 11 doesn't change. It's still the same. But then I have added some additional conditions saying that, okay, if the score is greater than equal to 90, the grade should be A. But if the score is not greater than 90, but greater than equal to 80, then the grade should be B. Similarly, if the score is not even greater than 80, but greater than equal to 70, then the grade should be C. Similarly, if the score is not even greater than equal to 70, but greater than equal to 60, which means basically between 60 to 70, then the grade should be D. And if the score is even below 60, then the grade should be F. So you can see I have basically defined the whole logic for defining the grades here. And it always works in a top-down approach, one by one. The way in the sequence in which you will define the else if block will be the sequence in which they will be executed. So after the condition at line 10, and if this condition fails, line 12 will be naturally executed. If this condition also fails, line 14 will be executed, and so on and so forth. It will never be the case that if this condition fails, then suddenly line 16 is executed and then again line 12 is executed. It will always work in a line by line fashion. So make sure whenever you are using the else if statements, write it in a sequence in which you want the natural program to be executed. So this is all we have here. And now let's try to run this example. Let me just bring the system.out.println line up, save this file, right click, run as Java application. So we see the value is grade equal to C, which means this particular code block was actually executed. Only this condition held true. Now let's try to understand how this happened. The value was 76. So 76 greater than 90? No, this condition becomes false. So line 11 is never executed. It naturally goes to line 12 because that's where we have defined the next else if block. Is 76 greater than equal to 80? No, it's not. So line 12 condition also becomes false. Line 13 never gets executed and the control shifts to line 14. And there we have the condition saying that is 76 greater than equal to 70? Yes, this condition is true. So the line 15 gets executed. And once this condition gets true, none of the further conditions will be executed because you only need one true statement, one true execution in the whole if else if block. If that one code block gets true, that code block is executed and then the execution jumps out of the if else if blocks and it will directly go to line 22 and it will execute that. Had it been the case that this particular block was also evaluated to false, it would go to line 16. And if this was also false, it would go to the block which is else block. Let's see that. Let's make this value as 56. So now 56 is not greater than 70. So line 15 will never be executed because this condition will evaluate to false. 56 is greater than 60. No. So this will also be false. And ultimately the grade should fall to else block where we are assigning the grade as F. Let's see. Yes, we get the grade F because ultimately this block was executed because all of the above conditions evaluated to false. Let's get started with using nested if statements in Java. Now, in the previous lecture, we saw how we can use an if-else block and also an if-else-if-else block. But there is another case where we can use these if statements, and that is when you have nested if blocks. When would you use it? Let's take an example. Let's say you have multiple conditions to check on a particular program and where the output of the first condition is the input of the second condition and the output of the second condition is the input to the third condition and so on and so forth. If you have that kind of situation, you can write it in a nested if statement kind of block. So let's understand this with the help of an example. As you can see, I have opened an example here, which is about nested if statements. I've created a class which is named as nested if demo, and I have created a public static void main method inside this particular class. And now I have declared an integer variable with the value 50. Then I'm checking the first condition saying if I equal to 50. If that condition is true, then I will check the next condition, which is if I is less than 75. And then I am adding one more hypothetical condition saying if this is true, then also check if I is less than 55. So you can see if I equal to 50 holds true, then only this condition will be executed. Similarly, if I is less than 75, then only this condition will be executed. So they are dependent upon each other. This condition block is dependent upon the previous block to be true, and this if condition block is dependent upon this if block to be true. If either of these if blocks don't go true, the next subsequent nested if block will not be executed. So in this case, I'm checking it for first equality condition, saying if the value is equal to 50, then execute this statement at line number 10. Then check if I is less than 75. If that is also true, execute the statement at line number 12. And then if I is also less than 55, then also execute line number 14. I can also add an else block as well anywhere in this nested hierarchy if I want to. If I add an else block here, that else block will be corresponding to this block. If I add an else block here, then that else block will be corresponding to this if block. And if I add an else block here, then that else block will be corresponding to this particular if block. So you can also use those else if and else blocks as well with nested if blocks and make it as complicated as you want it to be. So that's about this program. And let's see if we run this program, what output do we get? And let's interpret that output. So I've just right click, run as Java program, and I see some output in the console. First, I get I is 50. So line number 10 gets printed because I is 50. Then I also see the next line output as I is smaller than 75. It means this condition was also true because 50 is less than 75. So line 12 also got executed. And then I'm checking if I is less than 55. So yes, 50 is less than 55. So line 14 also gets executed and we get this statement on the console. So this was a simple way to see how we can implement the nested if conditions. Now we are also going to talk about another concept which is used in writing the if conditional blocks, which is called ternary operators. So ternary operators are used as a shorthand of writing if else block. As you can see that these if blocks are quite verbose. We have to write a lot of code to actually write some conditions. In this case, I'm executing 3 conditions, but the code is almost 7 lines or 8 lines. So we will see how we can simplify this if we use a ternary operator. And for that, I have created another class, which is called ternary operator demo. And this particular class again has a public static void main, which is the entry point of this particular program. And then I have declared a couple of variables. First is int a equal to 1, and second one is int b equal to 2. I have also declared a result variable, and we will see how we can use this result variable. And at line 10, I have written my if-else expression. So you can see this if-else expression doesn't look like the one which we have seen before. So let's understand how do we write it. If you're trying to write an if-else expression with ternary expressions or ternary statements, then the first thing which you need to understand is the structure of it. So here, at first, you will specify the actual condition which you want to test in your if block. So this is my condition. Then after that condition, you're going to put a question mark. And after the question mark, you're going to put the actual result which you want to be executed if this condition becomes true. So if the if condition becomes true, what do you want to do? Whatever is that, you will write it here. And then if the condition becomes false, then the logic should go into the else block and the else logic should come after this colon. So all you need to remember is this question mark and this colon. Before the question mark, you're going to write the condition. After the question mark, you're going to write the statement which is going to be executed if this if condition becomes true. And after the colon, you are going to write the else block condition which is going to be executed if this condition becomes false. Another thing to notice is that ternary operators can be used only in cases when you have only one statement to execute in if block and one statement to execute in else block. It cannot be more than one statement. So instead of this, you can also write system.out.println here, which will also be fine. If I just write this system.out.print, not printf, but I want to write println, so I'll just write println. You can also do this. This is also fine. You don't need to store the result, obviously, but you can also write this condition in a way. But this only has to be a single statement. It cannot be more than one statement because this expression can only hold one statement at a time. So use it in situations where you have to check a condition and do something in the if block, which is only one statement, and again one statement in the else block. The same expression can also be written in a verbose if-else way in which we have been seeing it before. And I will also show that to you. And here, where this A and B is going, this is getting stored in this variable called result. So if this if condition holds true, then the result is A, and this is going to be stored here. And if it is going into the else block, then B is going to be stored in the result block. Let's run this program. So we can see we get the value 1 because we have set the condition as A less than B. So yes, 1 is less than 2. So this particular statement gets executed and this value gets stored here in the result variable. So that's how you can use the ternary operators to write shorthand if-else statements. The same expression can also be written in a verbose way. For example, you can write it in this way, saying if A is less than B, then result equal to A, else result equal to B. this code has exactly the same effect as this one line of code. So you can see this is pretty simple to write, pretty short to write. The code which I'm writing here in 4 lines can be written here in 1 line, and that's the power of ternary operators. So this is all I wanted to cover in today's session. So we talked about nested if statements and the ternary operators here, how to use them. In the next session, we are going to discuss about switch case statements. Let's get started with using switch statements in Java. So let us first understand, why do we need switch statements? Generally, whenever you want to check a condition, you can use an if-else block. But what if you have multiple conditions to check? What if you have so many possible execution paths that it becomes too verbose to write it into an if-else kind of block? What if you have to check on constant values of certain expressions? How do you do that? It becomes even more challenging and the code becomes even more verbose. So in such cases, switch statement can be used, in which you can write switch statement to have as many possible execution paths as you want, and it will work with constant values as well. So let's understand this with the help of an example as how and why will we use the switch statements. So for that, I have created this class which is called switch demo, and it also has a public static void main method, which is the entry point. And in this program, what I'm doing is I'm trying to accept a number as the month number in the program. And then with that particular number, I'm trying to print the corresponding month's name. So that's the logic. Pick a month number and you should get the month's actual name. So now in this case, you can imagine there will be at least 12 if-else if blocks, which is a long line of if-else statements. At the same time, if we try to do this for other conditions where the value is constant, please understand that the value of month is going to be constant. It's going to be the same number. So it's not similar to you evaluating a condition. It's similar to you evaluating a condition to a particular constant value. Imagine if you have to do some sort of a classification of employees in higher salaries and lower salaries, and there are hundreds of salary bands in the company. So are you going to write 100 if-else logics? That is going to take a long time. And then what if new bands get introduced? Then it gets even more complex. So we will use switch case statements in cases where there are lots of if-else conditions and the expression evaluates to a constant value. Remember, in the if-else cases, the expression evaluates to a Boolean value. So here I'm supplying the month value as 6. Then I'm also creating a string month string variable just to print or store the name of the month. And then the way you write the switch statement is to write the switch keyword, and then in the brackets you supply the month integer value, and then you start writing your conditions. So you can see you write the case as keyword, and then you write the number or the possible values this particular variable or this particular expression can hold. So all the possible values this particular expression can hold will be written individually as cases. So case equal to 1. Here 1 means the value of month is 1. In that case, the month string which we created here shall store January. And then we see a statement called break. So break is again a keyword in Java, and this keyword has a special meaning. It has a special usage. You will use the keyword break to abruptly break the control of execution from the current code block, and the code block is identified with curly braces. So here you can see the curly brace starts from here and it ends down to line number 51 at here. So the moment your Java program is going to encounter this particular statement, it is going to jump out of the current code block execution and continue thereafter. That's the basic logic and usage of break statement. So use it whenever you want to skip the rest of the code after the break statement. If you don't want to execute the rest of the code, you will write break, and the moment the Java program sees this particular statement, it will jump out of the current code block specified by the curly braces and will resume execution after the code block. So in this case, it will resume the execution after the line 51. That's the usage and meaning of this expression called break. So In this case, we are saying that if the month value is 1, which we denoted as here, case 1, then store the value of the month string as January and break out of this particular code block because we don't need to execute any further. We have found a match. Then another case would be if the month value is 2. So you write case, which is a keyword, and then the exact expression value, the constant value, which is 2. And if that's the case, then month string becomes February. And again, you break because in this particular case, there will only be one condition true at a time. There will never be a case that month with the value 2 will have two meanings, will have two month names. A month with the value 2 will always have a meaning called February. It will never have two meanings or two month names attached to the same integer value. And that's why you do not want to execute any further. And that's why you write this break statement. If you do not write this break statement, it is going to evaluate all of the cases one by one. Even if the cases are not going to be true, but it is going to waste a lot of processing time evaluating all the case conditions which you have written here, which does not make sense because we know that only one condition at a time can be true here because we are evaluating and checking for a constant value, which is an integer value. So that's the reason we put a break in each case. If intentionally, if you want to check multiple cases, do not put a break statement, but the program can become really confusing in that case. So take your wise call. So here we put a break in each case. Similarly, case 3, the month string becomes March. Case 4, the month string becomes April. Case 5 becomes May. Case 6 becomes June. Case 7, we have month string as July. Case 8, month string is August. Case 9, we store the month string as September. Case 10 as October. Case 11 as November. And case 12 as December. After that, you will also see an interesting block called default. This is the another capability of switch statement, that what if none of the above conditions hold true? What if we specify a value which is not between 1 and 12 and it will not match any of the cases which we saw just above? And if you want to execute some code in that case, if none of the conditions matches, you may want to execute some default execution. Also, in such cases, you're going to use default. Default is the code block which will be executed if none of the case matches. So here you can see that if none of the cases match, then we are going to store the value of month string variable as invalid month, and then we'll eventually break out. And once we break out of this program, we just want to print the month string. That's all we are doing in this program, that we take an integer value as the month number, and then we print the corresponding month name here by looking at the case blocks. And we also define a default case block if none of the conditions hold true. So let's run this program. We have specified the value as 6, which should result in the month name as June. And yes, we can see we get June. Let's change the value and let's put the value as 10 and see what do we get. So right click, run as Java application, and we got October. Yes, exactly correct. Let's put an invalid value as 13 and let's see what happens now. Now we get invalid month. So our default code block just got executed because we entered a value which is not matching any of the case conditions which we have specified. So this is how you are going to use the switch and case statements while writing your conditions whenever your condition evaluates to multiple constant values. Remember, the key here is to understand if your expression is evaluating to multiple constant values which do not change. And in those cases, using a switch case block is a better idea than writing if-else statements. Let's get started with understanding arrays in detail. We have been talking about arrays throughout this course of Java in the previous sessions as well, and we have covered some basic understanding of how to create arrays, how to declare them, how to fill values in the array, and how do we print the array with positions as well as the array as whole. But whatever examples which we took previously were one-dimensional arrays, because arrays can have more than one dimensions as well. You can create a one-dimensional array, you can create a two-dimensional array, you can create even a three-dimensional array, and you can go up to as many dimensions as you can handle in your Java program. So it depends upon the kind of complexity you want to have in your program and the kind of values, the kind of structure you are going to store in your arrays. And based on that need, You can choose whether you want to use a 1D array or one-dimensional array or a 2D array or a 3D array and so on. In these sessions, we are going to talk about 1D arrays, 2D arrays, and 3D arrays. And after that, we'll leave up to you to try out more dimensionals if you want to. We have already covered the basic array structures, which were one-dimensional arrays. So I will just give you a quick walkthrough of how we actually handled one-dimensional arrays. So this is a sample program to demonstrate one-dimensional arrays. If you remember, this is how we used to create arrays. We write the data type of the array, and then we write the square boxes, which denote that this is an integer array data type. We assign a variable to this, and then we initialize the array with the size 4. So new is the keyword which is used to initialize anything in Java. And we are going to use this heavily when we talk about classes and objects and even collections. Literally any object which you want to create in Java requires a new keyword. So here I'm writing new and then int 4, which means create an array of size 4. And then I'm filling the value of the 4 positions which I have created as part of this array. And if you remember, when we create these kind of arrays, we store them in a 0 index based position. The first value gets stored at 0th index position and then so on and so forth. So it will always start from 0 and never start from 1. Remember that. And after that, we just print all the values of individual positions of the elements in the array. And if I just run this program, all of the elements of this particular array should be printed one by one. So if I just show the full console of the output, you can see that element at index 0 was 10, element at index 1 was 20, element at index 2 was 30, and element at index 3 was 40. So this was just a quick refresher of how one-dimensional arrays can be written. And whenever you declare a very simplistic array, it will generally be a one-dimensional array. Now let's look at the two-dimensional arrays and how do we write them? When do we need them? For that, I have created another example, which is says two-dimensional array. I just created a class and it has a public static void main method. And I've created a two-dimensional array this time. So let's understand this two-dimensional array in a bit detail. And when do we need that? Generally, you would need to use two-dimensional arrays whenever you are trying to do any matrix calculations. If you understand what do you mean by matrix, it's basically a 2 by 2 structure which stores the values in the form of rows and columns. So imagine a table of 2 rows and 2 columns, then it will be a 2 by 2 matrix. So if you want to store that particular table in a Java program, you would need to store that as a matrix, as a two-dimensional matrix, rows being the one-dimensional and column being the other dimension. And that's what we are doing here. And if you want to store that 2D matrix in a Java program, the approach and the procedure for it is pretty similar to how you create a one-dimensional array with slight changes. The first change is instead of a single square bracket, you're going to write 2 square brackets because it is a two-dimensional array. So remember, the number of square brackets you are going to put while initializing and declaring the array is the number of dimensions which your array is going to have. Since this is a two-dimensional array example, that's why you see 2 brackets here. If this was a 3-dimensional array example, you will see 3 square brackets here, and so on and so forth. So that's the first part of it. Second part to understand is to how to store the data. Remember, I told you always imagine the structure of rows and columns whenever you are trying to store a two-dimensional array in Java. So what are rows and what are values and how do you represent them while you declare and initialize a two-dimensional array? So you start with the curly braces as a normal 1D array, but inside the curly braces, you create nested curly braces blocks. You can see 3 blocks here. They start with their own curly brace and end with their own. Then this curly brace starts here and ends here. And then this curly brace starts here and ends here. Idea is that you provide this outer curly braces to define the overall structure. And then inside each of the curly braces is going to represent a row in your two-dimensional array. So each of these values, these blocks, is going to represent a row. So I can say that this is the first row, this is the second row, and this is the third row. And if I try to visualize it in terms of columns, then this is the first row, first column, first row, second column, first row, third column. Similarly, second row, first column, second row, second column, second row, third column, and third row, first column, third row, second column, and third row, third column. So individual values are going to be represented as columns, and the whole curly braces is going to be represented as arrays. That's the basic mental idea or mental image you should have while declaring a two-dimensional arrays. Remember to declare the rows inside the nested curly braces, and whatever elements you have will automatically be indexed as columns. Another thing to remember that since this is an array data structure, everything starts from 0 and nothing starts from 1. So this will be row 0, this will be row 1, and this will be row 2. I'm talking about the position. We can still call it as first row, second row, and third row, but the position of this particular row element is 0. The position of this particular row element is 1, and this particular row element is 2. Similarly, for column as well, this is column 0, column 1, and column 2. Similarly, column 0, column 1, and column 2, and so on and so forth. Once you understand this data structure well and you have defined it correctly, then everything should fall in place. If you want to do a matrix addition, or if you want to do a matrix multiplication or a dot product, all of the kind of calculations can be performed using the 2D array concept. Here in this program, what I'm doing is I am printing the values of this particular 2D array into a matrix style. And you see some strange code here, which is for etc. Don't worry about this. I'm going to cover in detail what this for means and how do you write this. For now, what we can understand that we just want to print this. You might not need to print this in your Java programs when you write a production grade application, but you might want to do manipulations on these arrays as metrics. Maybe you want to create a transpose of a matrix, or you want to do a dot product or addition or subtraction or whatever be your use case. In this case, just for demonstration purpose, I'm printing the values as rows and columns, nothing else. So this all of this code from line 8 to line 14, or in fact line 13, is just showing how to print the values. You can see some system.out, and you can see some construct here. And like I said, don't worry about this. I will cover this in detail. Let's run this program and see if my Java array is stored correctly and how can I represent this. So you can see I have represented it in a style of a 2D matrix, where this is the first row, this is the second row, and this is the third row. Similarly, this is the first column containing the value 237. So column 0 will have value 2, and column 1 will have this value 3, and column 2 will have this value 7 for row 0. Let me also do something here which can help you understand this concept better. Let me do a system.out.println, and let's print an individual value, because like I said, the for loop can be confusing here to understand. So let's say I want to print ARR of 0th row, first column, and see what kind of values do we get. Let me comment this code. Comment is control \, and this code will be commented, and this code will not be executed. And now only line 15 will be executed instead of the for block. So if I run this, I get the value 7. So row 0 and first column, row 0, first column is 7. Let's try with 1, 1. I want to print the row at 1 position. Remember, not the first row, but the 1 position row, which is basically technically the second row. So second row, second column, and see what kind of value do I get in this case. I get 6. So second row, second column. Similarly, if you change this value to 2, then third row, second column, which should point to 4. Yes, we get 4. Similarly, you can write a value here as 0, and you can write a value here as, let's say, 2. This will print the 0th row and the second column. So similarly, whatever kind of value you want to write, you want to access, you can access it in this fashion. And remember, the column and row indexes will always start from 0. So this is a simple demonstration of how you can use two-dimensional arrays. Let's get started with how to create and use a three-dimensional array, or how to go about using multi-dimensional arrays in Java. So as you can see from this image, we talked about 1D array, which is having just one axis. Then we talked about 2D arrays in the last session, where we had rows and columns, basically an x-axis and a y-axis. And then we can also have a 3D array, which will have 3 axes, which will have an x-axis, a y-axis, and also a z-axis. Think of a simple box, which every box in this world will always have at least 3 dimensions. And from here, you can go even build more complex arrays, which can have 4 dimensions or 5 dimensions or as many dimensions as you want it to have. And today we are going to look at an example of how can we build a 3D array and how do we access those elements. But this picture is just to show you the mental model of when you will be creating a 3D array. So for example, generally an image data is stored in 3 dimensions. So you might want to store the image data into a 3D array. And there can be many other use cases in the mathematical and research computational use cases where you might want to use a 3D array. So, but remember, there's an x-axis, there's a y-axis, and then there is a third axis, which is called the z-axis. So let us look at a Java program to understand how we can build a 3-dimensional array. And for that, I have created this class, which is called multi-dimensional array. It has a entry point method, which is the public static void main method. And then I have created an integer array. And this time, instead of 1 or 2 square brackets, I have 3 square brackets. And if you remember, I mentioned this in the previous session as well. The number of square brackets which you're going to put while initializing the array is the number of dimensions of the array. And since in this particular program, I'm going to demonstrate a 3-dimensional array, that's why you see 3 square boxes. Let me just minimize this. Yep. So we have 3 square boxes here, and we have created the variable name as ARR, or short form as array. Then we start with the outermost curly braces as is. Then we put another curly braces which starts from here and it ends here. Then another set of curly braces which starts from here and end here. So this is the first dimension. This is the second dimensions, and these are the third dimensions. That's how you're going to define the different dimensions. Remember, this is the first dimension when the first curly brace starts. Then you have this second dimension which covers this hole and this hole, and then you have third dimension which are these. So that's how you're going to visualize and put the 3 dimensions in use while declaring a 3-dimensional array. And the values work in the same fashion. It's a 0 index based position. So since we do not have an official name for the third dimension, so I'm just going to use x-axis, y-axis, and z-axis to refer to the 3 axes. So this would be x of 0, this would be y of 0, and this would be z of 0. Similarly, x of 1, y of 1, and z of 1, and so on and so forth. So now if I try to access the value which is at 0th x position, first y position, and second z position, what's the value do we get here? Let's run this program and understand and interpret the output. Okay, so when we ran this program, we got the output as 11. So let's understand this output. So when we say the 0th position on x, the first position on y, and the second position on z. So this is the 0th position on x, and this is the first position on y, and then this element is 0, 1, 2 is the second position on the z-axis. So to describe it in a nutshell, this defines the x-axis. So we have 2 elements on the x-axis here, this one and this one. Then we have 2 elements on the y-axis on each x-axis. So this is 1, this is 2 on the first x-axis, and this is 1 and this is 2 on the second x-axis. So 2x and 2y, and then on the z-axis, I have 3 elements each. So hope this helps you understand and visualize this. So x-axis, and this one is other x-axis, and then y-axis, and then elements inside this are z-axis. So I'm saying 0th x-axis in this block, first on the y-axis, which is this block, and then second element or the z or second position element on this particular axis in this particular block, which is 11. And that's why we get 11. If I print 0, let's say I change this particular value as 1. So now the output should be coming from this side. So second x position, because it's 1, second y position, so this will go here, and then the 2 position, which is the third element of the z-axis, which is 13. So let's see if we get 13. Yes, we get 13 here. So this is just to show you how you can interpret this particular array and always be mindful of how you are structuring this array. If your structure is gone wrong, then your program will become useless and it will give you a lot of unpredictable outputs which might not make sense and which may introduce errors in your program. So be very careful how you define the structure of the elements here. That's the key. And after that, you just need to understand the x-axis, the y-axis, and the z-axis. Always remember all the axes start from 0. So when I say 2, I'm basically referring to the third element and not the second element. So this is all I wanted to cover in this particular session where we describe how we can use a 3-dimensional array. And from here, you can go to any lengths. Like I said, you can add more square brackets here and go to 4-dimension or 5-dimension or 6-dimension. But remember, the more dimensions you add, the more complexity of the program will be having. The program will become more and more difficult to debug and understand. So always try to take a wise call as to how many dimensions you want to use in your array. Let's get started with how to use do-while loops. Now, in the previous session, we covered the usage of while loops, but we have another type of while loop, which is called a do-while loop. So let's understand when do we need that and how do you actually use that. Let me switch to the Java documentation and if I can find some syntax of it as well. Yep. So as you can see here, if I just highlight this portion, this is how you actually write a do-while statement block. So you write do, you start a code block, you write some executable statements, and then after the code block ends, you write a while expression and end it with semicolon. This is the syntax basically. It starts with do or curly braces, some executable statements, a while block or a while statement basically with an expression ending with a semicolon. Let's understand this with the help of a program to understand the structure better. So for this, I have created a sample program here, which is called do while demo. Again, having a public static void main method, and it has a variable which is count, and it is initialized as 1. Then I write do, I write this code block or the curly braces, and then I am just printing the value of count. Then I am incrementing the value of count, and then I am writing a condition which says while count is less than 10 and semicolon. If you compare this with the previous demo we ran, if I just put them side by side, we had while condition statement and the state change condition. Here we have do statement, condition change statement, and then we check the condition at the end. So the idea is that if you have a use case where before you even evaluate the condition, you want to print something, even before you evaluate the condition. If you want to do something, in that case, you will use the do while loop. Even before the actual while loop starts, if you want to execute a statement, you will use do while loop. For example, if you want to print the initial value of the count even before the condition checks, then you can use do while loop. If that is not your use case, you can use the simple while loop, which is described here in this program. So coming back to the do while, so I say do, and then I'm saying print this particular statement without checking anything. This condition will be executed for the first time without any condition check at all. This will just work as is, like a normal Java statement. After that, I'm incrementing the value of the count, and then I'm checking the condition. So remember, when this particular condition is being checked, the first increment has already happened. But in the while case, we did the comparison before even the first increment. The first comparison happened with the original value of count. But here, the first comparison is happening with the incremented value of the count. Hope you get the difference in a better context now, that you will use this when you want to write some initialization code before you actually hit the condition. So this condition will be evaluated with 2 less than 10, and then the value will be printed. Let's print this example, and we'll also try to play around with this example a bit more to build our understanding better. If I run this program, there is no difference in output if you compare this with the previous program we ran for the while. So it prints the count value. So this is coming here. Then it increments the value. Then it checks the condition saying is 2 less than 10. Yes, that holds true. If that holds true, it will go back to statement number 9, again print this, again do an increment on the count, and again check the condition with the updated value of the count, which will say 3 less than 10 now. Similarly, print the value, increment, check. This will continue to happen till this particular condition becomes false. And once this condition is false, it will exit out of this whole do while loop and it will go to the line number 12. And if you have any statement written there, you can that statement will be executed in this case. So let's try to change some values here and let's see if we can make sense of this program if we change the value. Let's say if I put 11 here, what will happen now? Let's run this program. You will say now you will see that this particular output is displayed which says count is 11. So what happened here, that count was 11, it entered the do while block, it went to this particular statement which said count is 11, then it incremented the value, so the value became 12, and obviously 12 is not less than 10, so it did not print it again. It only printed once, even if the first time the condition was checked, the first condition execution itself resulted in false. Still, line number 9 got successfully printed, and that's the whole idea behind using the do while. What if I change this value to 10? Let's see what happens. And after that, we'll run one more combination to just make it more interesting. This time again, count is 10. Line number 10 will be printed as count is 10. Then at line number 10, the count is incremented to 11, and 11 is not less than 10. So in this case, the loop ends and it will move out. Now, what happens if I do this? If I say less than equal to here, let's run this program and interpret the output. Now, again, only one statement is printed because in this case, the count is 10, 10 is printed here, and we are saying 10 plus 1, 11. 11 is still not less than equal to 10, and that's why the loop just exits. Let's make it 9 and see what happens. Now you see two values. So count is 9, it enters the do while loop, goes to statement number 9, prints the current value of count, which is 9, then increments the value to 10. Then at line number 11, this while statement is executed and the condition is checked. Is 10 less than equal to 10? Yes, 10 is not less than, but 10 is equal to 10. So this condition will hold true. It will go back here, print count is 10, make count 11, again check the condition, is 11 less than equal to 10? No, it's not. And then the condition will return to false and loop will be exited. So hope this will give you a better understanding now, since we ran different permutations and combinations of the values and we saw when this will be executed and when this will not be executed. But the bottom line is very straightforward, that whenever you want to write some pre-processing logic, even before checking the very first condition of your loop, then in that case, you will be using a do while loop. Otherwise, a normal while loop or a for loop will absolutely work fine. Let's get started with understanding the loop statements in Java. So first of all, understand why do we need loop statements? So generally, whenever you are dealing with some data structures in Java, which can store multiple elements, for example, we saw array, which can store multiple elements. String is also basically technically a character array, which is storing multiple characters. So whenever you have these kind of data structures where you have multiple elements being stored in the same, then in that case, you would like to have a way to iterate or access all of the elements in a seamless fashion. One of the ways is to access them individually one by one, but that's too much of work. That's too much of code. There has to be a simpler way of accessing all the elements one by one if I want to. And that's where the majority of the use cases for using loops coming to picture. Now, Java provides multiple constructs to write loops in Java. There is a while loop, there is a do while loop, there is a for loop, there is also an enhanced for loop. And in the previous versions of Java, a use case of iterator was also very popular. So there are multiple ways in which you can actually iterate over a collection and access all the elements of the collection one by one. And you can use it to multiple useful cases. For example, if you have a huge array of employee salary and you want to give bonus to each of the employees and add the bonus to the salary, then you need to do this addition for all the employees. It would be nice to have to return a while loop and the while loop can automatically access all the employee salary one by one and keep adding the bonus to the salary. This would be an easier way to do this rather than individually updating each employee's salary. And the first loop statement we are going to understand is a while loop. So the syntax of while loop is very straightforward. You write the while keyword, you enter the actual condition which will be evaluating to a Boolean true or false. So you write the expression which will be a Boolean expression, exactly similar to the conditions which you use to write in your if statements. So you write your condition which will evaluate to either true or false, and then you write your statement. And these statements will keep executing till the time this particular expression evaluates to true. So generally the way it works is that it will enter the while block, it will evaluate the expression. If the expression becomes true, then the statements inside this particular while block will be executed. And after the execution of the statement, it will again go back, again evaluate the expression. We call them steps basically. So it will go to the next step, again evaluate the expression. If this still holds true, it will again go inside, execute the statement, move on to the next step. It will again go to the evaluation. So this loop will continue to go till the time this condition will hold true. If it still doesn't make sense for you, don't worry, we will have a demo of it to make you understand how to use the while loops. And maybe it's a good idea to switch to the IDE and look at an example of it. So I have already created while demo for it. Here it is. It looks very small and simple, but it will get to the point where we can understand how and why will we be using the while loops. So I've created a while demo class. I've added a public static void main method here, which is the entry point. I have declared a variable which is int count equal to 1. So the count value is 1 right now. And then I'm writing a condition here. I'm saying while count is less than 10, do this. So it will print the current value of count. And after that, I'm using the post increment unary operator. If you remember, we covered this in the previous sessions. What is the meaning of this? It basically will increment the value of count by 1. This expression is equivalent to if I write it in this way. If I write count equal to count plus 1. This is exactly the same as this. No difference. So this will have the same impact. I will just remove this line because we already have the count plus plus here. So if we try to understand this, we are basically incrementing the count and then checking the condition again. So at first time, it will be 1 less than 10. Yes, that is true. It will go inside and print the count value, the current count value, which will be 1. And then it does count plus plus. So now the count value becomes 2. It will again go back here, again check the condition saying is 2 less than 10? Yes, that is true. So the while condition again becomes true. It will again go inside this, print the current value of count, which is 2, then do count plus plus. So it will again increment the value of count. So now the count value becomes 3. Again go back here at condition and saying is 3 less than 10? Yes, that is still true. Again come here, print the 3. Again go here, make count as 4. 4 less than 10, prints 4. Again count plus plus, count becomes 5, and so on and so forth. It will keep doing that till the value becomes 10. So at a step when count plus plus results in the count value being updated to 10, it will go here and say is 10 less than 10? Now that is not true because 10 is equal to 10, but 10 is not less than 10. So this condition will become false and it will exit of this while loop and it will come here and it will execute if there was anything written after the while loop that will be executed. So that's the idea, that you want to do something till a particular condition holds true. Then you can use the while loop, define your condition and execute the statements and try to do something which changes the state of this condition. Here I'm changing the count so that every time a new evaluation happens. If I comment this will result in an infinite loop because 1 will always be less than 10. I will not be incrementing the count here and it will keep running forever. It will never stop. It will just keep printing 1, 1, 1 every time till your computer program runs out of the memory. So always remember not to end up into an infinite loop. That's probably one of the biggest mistakes any beginner programmer does. So please try to be aware of that particular loophole, not try to run an infinite loop. Always try to write something in the code block which can change the state of the condition, and also make sure that that state condition sometime should become false. You should also make sure that always becomes false, because if I do this, then this condition will always remain true because it is already 1, then it will become 0, then it will become -1, -2, -3, so on and so forth. But that value of count will forever be less than 10. And again, you will never be able to exit this loop. Your program will be stuck in this loop till your program runs out of the memory. So always remember to write a statement or a statement of execution in your code block, which can change the state of the condition, which results in some eventual time when this condition becomes false. This condition has to become false eventually, otherwise you will never come out of the loop. Always remember that. So if we run this program now, let's observe the output. So we can see here this particular statement is printed for 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. After 9, the moment the count plus plus resulted into the count value becoming 10, it checked that condition and then it just came out of the loop because 10 is not less than 10 and the condition became false. So always do something inside your code block which results at least of one scenario where this condition becomes false. And that is how you can use the while loop. Now you can see this is a pretty generic code and you can write any kind of condition here, write any code you want to execute here, and then do something to change the state of the condition as well in a positive way, in a way which results this particular condition to be false at some point of time. And then your while loop will run fine. So this is all I wanted to cover in terms of the while loop. Let's get started with for loops in Java. So far we covered about while loops and do while loops, and we also saw different examples of using different types of data structures like arrays. But one of the core requirements whenever you are working with any kind of collection is to iterate over it. Exactly similar to what I explained in the do while and while lectures, that you would often require to iterate over a collection or a data structure. And for that, one of the most sophisticated and easiest way to do that is using for loops. So let's understand the syntax of for loop first, and then we will also look at an example of it in the Eclipse IDE. So I have just opened the official Java docs here. So if you see, this is basically the syntax of a for loop statement. So let's understand it, and let's also try to compare it with a while loop so that we can understand how it compares with the while loop. So if we see the syntax, we first see the term initialization, then we see the term termination, and then we see the term called increment. Now, if I try to compare it with a while loop, there also you basically did these three things. You first initialized a variable outside the while loop, which is called initialization, and then you wrote a condition which is your termination condition. You wrote a condition saying, let's say, while I is greater than 10 or while I is less than 10. So that is the condition, which is also the termination statement. The loop will continue to execute till that condition evaluates to false, and that's when the loop terminates. That's why we call it as termination. And then the third piece of it is the increment, the I++, which we used to do in the while loops. So these three portions together make or constitute any kind of loop in any kind of programming language. And for loop, if you see, the kind of code which you use to write in a while loop in multiple lines, where you first initialize a variable, then you write a condition in the while block, and then inside the while block, you use to increment the variable. All of that can be done in a single line in the for loop. And that's why I said it is the most sophisticated and easiest way to write loops in Java. So you write all of these three things, the initialization, the condition, and the increment or decrement values in the single line. And then you start with the curly braces and you write the code which you want to keep executing till the condition evaluates to false. That's the basic syntax of it. So let us try to understand this with the help of an example. So here I have opened a class which is called forDemo. And this is a class which will demonstrate the usage of a for loop. So again, we have a public static void main method, which you can see here, which is the entry point. And then I use the keyword for. I put standard braces or the brackets, and then I do the initialization. So this part is the initialization part. You initialize the variable. So I just say int I equal to 1, initialization done. You end it with a semicolon, so that it is a single statement understood by Java. And then you write this condition. which is your evaluation/termination condition. So this condition is basically the deciding factor of how long your loops should run. It's exactly similar to what you used to write in the while block. If I just show you the example, this is what we used to do. So we did the initialization at line number 7. Then we wrote this termination condition inside the while syntax or the construct. And then we did the increment here. So we are doing all of these 3 steps, but we are doing it in a single line. So this is the condition, and then we write our increment or decrement values, which are going to change the evaluation condition every time at every step. So we are saying I++. So technically what I am saying here is that start with I equal to 1 and then check the condition I less than 10. So in the first step, it will be checking if 1 is less than 10. If the condition holds true, go inside the for loop, execute the statement at line number 7, and then go back to this particular statement. So we do I++. So I becomes 2, and then you again go back to the condition. And again you check if 2 is less than 10. Yes, it is. So again you go inside the for loop and do whatever is written there. There can be multiple statements here. For now, I have just written one system.out.println. So that happens. And once all the execution is finished inside the block, it will again go back to the increment. Does the increment, so 2 plus 1 becomes 3. Again does the evaluation. And if the condition holds true, it will again go inside. So this will continue. This condition checking, execution, and increment will continue till the time this condition holds true. The moment this condition becomes false, the control will come out at line number 9. So that's the basic anatomy and control flow. It's very important to understand the control flow of a for loop. Otherwise, you might end up into a program which is forever running and which will just eat up all the memory available in your JVM. So be very sure of what you write in your for loop. Be very sure of especially these 2 parts, the condition and the increment or decrement. So this is very important piece. The initialization happens only once, and then this condition evaluates. If the condition holds to true, some code executes, goes back to the changing statement, which can be an increment, decrement, whatever, and again compares the updated value with the condition. So this will keep happening. Let's run this code to interpret the output. So I will right click, go to run as Java application. And if I interpret the output here, I can see that it started with count is 1, 2, 3, 4, 5, 6, 7, 8, and 9. It stopped at 9. So what happened there? Let's try to evaluate the termination condition. So let's say I has become 9 and 9 is less than 10. So it goes inside and it prints count is 9, which is I. Then it goes here and it says 9 plus 1. I++ means 9 plus 1, the current value of I plus 1. It becomes 10, and then it again compares the condition. So now 10 is not less than 10. 10 is equal to 10, but it is not less than 10. So the condition becomes false, and count is 10 is never printed because this condition has become false. It will jump out. So let's say if I do this, if I put an equal to here, and if I now execute the same program, this time I will see 10 here. And because I have said that, okay, check the condition, if 10 is less than or equal to 10, that will become true. It will print count is 10. Then it will increment and the count will become 11. The I will become 11. And then it will check 11 is less than or equal to 10. No, it is not. So condition becomes false and the control comes out of the loop. So that's how you should always try to interpret the loops. You can also run some infinite loops. For example, if I say I equal to 1, I leave it that, and I say I minus minus. So what happens? I equal to 1, 1 is less than 10. Yes, it goes here, prints the value, and then I decrement the value. I don't increment the value, I decrement the value. So whatever value comes out will always be less than 10, and this loop will run forever. For fun, let's try to run this, and I will have to kill this program manually, but just to show you what happens and what you should not do in your Java program. So you see, it will continuously keep printing the values till the program runs out of memory, till it eats up all the available memory. It is forever running. It will never stop because the condition will never evaluate to false. This condition will forever be true. So the loop will run forever. So I'm just going to kill the program, but this is something which you should avoid whenever you are writing Java code. And this happens quite often with beginner programmers. let's get started with enhanced for loops in Java. So we covered about the for loops and the structure of it and the control flow of it in the previous session. And today we are just going to talk about another way of writing for loops, which is a bit even more smarter than the traditional for loops, which we call as enhanced for loops. We generally use the enhanced for loops for scenarios whenever we have to iterate over a collection of items or an array of items. Those are the most popular and common use cases of using enhanced for loop. And this for loop is even simpler. Like I said, it's even simpler than writing a classic for loop. And the syntax is simply like this. You again start with for, put the standard brackets, and then let's start from the rightmost, because then I will be able to explain it better. You specify the collection in the rightmost side of the bracket. The collection can be an array, it can be a list, it can be a map. So whatever different kind of collections which are available in Java, and we are going to cover collections in detail. So don't worry if you don't understand what are lists and what are maps and what are sets. We will go into detail of each of these one by one in the upcoming sessions. But the idea is that you put the collection to the rightmost, then you put a colon, and then you put a representation of the member of this collection. So for example, here this numbers is basically an int array. So this int array means that this array can only hold integer numbers, and that's why we write int here, because this array is only having integers. Then we put any placeholder variable name. This can be anything. You can even write it as I if you want to. You can write it as anything, any variable name which you want to write. This is a temporary variable. So now this code is going to execute in a manner that it is going to iterate over this array one by one, starting from the first element, going till the last element. You don't need to write any initialization code. You don't need to write any termination condition code, and you don't need to write any increment or decrement code also. And how these three values are actually taken care of, let's understand that as well. So when we talk about the initialization, as I have put an array here, a data structure here, the automatic initialization index is going to be the first index. So when we do the iteration, when this for loop is going to execute, it is automatically going to initialize a temporary variable with the value at the first index, which is the index 0. As you know, that array is a 0 index based structure. Then comes the condition part. So the condition evaluation is going to be again based on the size of the array or the size of the data structure which you are using. It is going to start from the first index, which is the index 0, and it is going to iterate till the array's last element is reached. So technically start from the index 0 and go till the last element. That's your evaluation condition. And then comes the increment part. So at each step, after it has successfully accessed the first element, automatically the index is going to be updated to pointing to the next element. So if it starts from here, once the first step iteration is complete, I is automatically going to be incremented to index 1. And then it will basically, this I will be holding 2. Then in the next iteration, the same I is going to be holding 3. Similarly, I will keep holding the new value of the collection item one by one till the collection item's last element is reached. So this is the basic premise, that you can write a collection variable here and keep iterating over it, and this whatever variable you write here will hold the current item's value one by one. So in the first step, this I is going to hold 1. In the second step, this I is going to hold 2. In the third step, this I is going to hold 3, and so on and so forth. That's the basic idea. So now let's run this program to see what kind of output do we get. So you can see we basically are able to print all the elements of the array. And that's probably one of the most popular usage as well, that if you want to just print all the elements or access all the elements of a array or a collection one by one, then just use enhanced for loop. So you can see at each step, it is printing the value of I, and the value of I is basically the subsequent elements of the array. That's the whole idea with enhanced for loop. Under the hoods, if we talk about how does it work under the hood, it is actually using the classic for loop construct itself. But for developers, it is making it easier because it knows that if you are iterating over a collection, you will start with the first element and you will go till the last element. So it knows the initialization value, the termination condition, and it also knows the increment condition. And that's the reason you will use enhanced for loops in Java for iterating over collections. Let's get started with nested for loops in Java. So we talked about the while loops, the do while loops, the classic for loop, also the enhanced for loop. So now we are going to look at a variation of the classic for loops in a condition where we have to use more than one loop in a nested fashion. And how do we do that? What are the use cases when we use that? So in front of you, you can see an example which I have prepared for nested for loops. And in this particular example, I have created a two-dimensional array. As you can see on the line number 6, I have created an integer array and I have put two square brackets here, which are basically symbolizing that this is a two-dimensional array. So this two-dimensional array is going to hold technically a 2D matrix. And we are going to use the concept of nested for loops to print this 2D array in a 2D matrix style where you will be able to see the rows and columns clearly. Let's first try to interpret this particular 2D array. So we have a curly braces outside, and then we have these three inner elements, which symbolizes three rows basically. So this is the first row, this is the second row, and this is the third row. And then each of the rows have three elements each, which symbolizes the column values or the item values. So it's basically a 3x3 2D array, which has three rows and three columns. So we can say that this is basically a 3x3 array, which has 3 dimensions on the row side and 3 dimensions on the column side, or just a 3x3 matrix or 3x3 2D array. So as we know that in case of arrays, everything starts from 0. So technically, if we talk about the indexes, it would be the index 0, index 1, and index 2 on the row side, and similarly index 0, index 1, and index 2 on the column side. So that's something which you should remember, because we are going to use this particular concept when we write the for loop. So let's try to write the for loop now. If you look at line number 8, we put this keyword called for, and then we write the initialization. So we say int I equal to 0. Then we are writing the termination condition, and we are saying run this particular loop, run this whole loop which ends at line 13 till I is less than 3, and keep incrementing I at every step. That's what I'm doing in the line number 8. Then inside the for loop, I'm writing another for loop which has another different variable called j. It can be anything, you can name it anything you want. And this also starts with 0. And this also has a similar condition which says run this particular loop, the line 10 basically, or this loop which is signified by this curly braces. Run this particular loop till the time the value of j is less than 3, and keep incrementing j at every step. And at line number 10, print the element of array which has the current value of I and the current value of j. These are basically the positions. These are not the elements. The element would be represented by this hole, but print the element which is at current I and j's position values. That's what this code means. So let's try to do a dry run on this particular code to understand how this is going to work. So at first we have I equal to 0. 0 is less than 3, and it goes inside. It initializes j as well with 0, and 0 is also less than 3. So this condition went true. That's why we went to line number 9, and line number 9 condition also went to true. So we went to line number 10. Remember that in this particular case at line number 10, the values of I and j are 0 and 0 respectively. And we are saying print the array of 0 and 0. So 0th rows, 0th column element should be printed. So this is the 0th row because this is the first subblock, and this is the first element. So in this case, in line number 10, 2 should get printed. Then it goes here and it increments the j to 1. So 0 plus 1 becomes 1. it again checks the condition, is 1 less than 3? So yes, 1 is less than 3. It goes here. Remember, it did not go up at line number 8. It just came back from line number 9. So when it comes here, I is still 0, but j has moved from 0 to 1. So now we are trying to access the element which is at 0th row, first column, which is going to be 7. So 7 is going to get printed. Similarly, on the next iteration, j is going to get incremented from 1 to 2. And again, the condition will be evaluated. So 2 is less than 3. All good. It will again come back to line number 10. And now it will say print the value of 0 row, third or the second column or the third element. So 0th row, third element, which is the 9. So 9 will get printed. Then again, j will be incremented and j will become 3. 2 plus 1, 3. And now the condition will be evaluated. Is 3 less than 3? No, it is not less than 3. The condition becomes false. So it breaks out of the loop, goes to line number 12, prints an empty line because we are not writing anything here. So it will just print a blank line. And now it will go back to line number 8's condition and it will do an increment of I. And now I will move from 0 to 1. And now the evaluation will happen. Is 1 less than 3? Yes, 1 is less than 3. So it will again go to line number 9. Again, initialize j with a fresh 0. The previous j got destroyed the moment you came out of the loop. So this is a new j. So this j again gets initialized to 0. 0 is less than 3. It goes here. Remember, I was 1 in this time. So now it will print the value of this 2D array, which is sitting at 1, 0. Basically second row, first element. So second row, first element, which is 3. Again, j is going to get incremented and it will become from 0 to 1. So 1 is less than 3. Yes, it will again come here and it will print the value of the array, which is sitting at array of 1, 1 for a row equal to 1 and column equal to 1, which will be 6. Similarly, j will get incremented again. Again, 2 is less than 3. Come back here, will print 1. Then again will increment j. J will become 3. 3 is less than 3. No, it's false. The condition is false. So it jumps out of the loop, goes to line number 12, prints a blank line, again goes back to 8, line number 8, increments I, and I now becomes 2. 2 is less than 3. Yes, it will again go here, initialize j again with 0, and again does the same thing for the row 2 and column 0, 1, 2. And again, it will come out of the loop. This time, again, when it will go here, the value will become from 2 to 3, and 3 is not less than 3. So then it will break out of the outer loop. So the idea is execute the inner loop for every value of the outer loop. Remember this line because that is how you will be applying your knowledge of nested for loops to be used in certain condition. So whenever you have a scenario where you have to iterate over a collection based on a certain value of another collection, then you can use nested for loops. Or you have a scenario where you have to iterate over 2D or 3D arrays. For example, if we were dealing with 3D arrays, then you would have seen 3 nested for loops here, and where it will apply the same logic that iterate over all the collections, all the values of the inner loop on a particular value of the outer loop. Then increment the value of the outer loop and do the same thing again. Iterate over all the values of the inner loop based on a fixed value of the outer loop. So let's run this program and let's see what kind of output do we get. So like I said, our motive, our target was to print this in a matrix style. And you can see that it is printing in a sort of a matrix representation. So the first row gets printed here, then the second row gets printed here, and then the third row gets printed here. If you try to decipher it, it will work exactly the same way as I explained. So I equal to 0, 0 less than 3, condition becomes true, comes here, j equal to 0, j less than 3, condition becomes true, comes here, prints the array of 0, 0, which is 2, then prints the array of 0, 1, which is 7, 0, 2, which is 9, then j becomes 3, it breaks out of the loop, goes up here, I becomes from 0 to 1, 1 is less than 3, yes, again comes here, reinitializes a fresh for loop with a new j setting to 0, and it will print the array of 1, 0, 1, 1, 1, 2, then similarly array of 2, 0, 2, 1, 2, 2. So that's basically what we are doing. We are iterating, we are picking the first row and iterating all elements of it, picking the second row, iterating all elements over it, and so on and so forth. You can do this for any n-dimensional kind of array or a collection. Let's get started with collections in Java, or the collections framework in Java. I must say that this is probably the most important concept of the Java programming language, which you will be using heavily whenever you are working in any production grade application. So let's understand the collections framework and the different classes and the utilities available inside the collections framework. This is going to be a theoretical lecture because there is a lot of ground to cover in this lecture. So we will only focus on understanding the relationship between the classes, why those classes are created, because each class has a different purpose in this framework. And we will obviously talk about the hierarchy as well. In the upcoming sessions, we will go into the hands-on exercise of some of the most popular collections. We will not be able to provide hands-on of all the collections classes which you can see on the screen, because then it is going to take a very long time to complete this concept. But we will cover the most popular ones or the most used ones out of this particular framework. So let's get started. As you can see, let's first understand some of the symbols here. And let me just zoom this in a bit so that it's visible. Yep, now I have just increased the resolution a bit. So you can see there are three different symbols or legends here. You see this oval shape, which is called interface. So you can see some interfaces here. Then you see this rectangular blue box, which is called abstract class. And you can see some of these blue boxes. And then you see the purple box, which is called the class. And you see some classes here, these ones. So for now, we haven't covered the concept of interfaces and abstract classes, but we will cover that in the coming lectures. And for understanding the collections hierarchy right now, at least the concepts of it, you don't need to be fully aware of the concept of interfaces or abstract classes. So let's dive deeper into the framework. Iterable is basically an interface. To give you a very simple definition of an interface basically is sort of a declaration which will tell you what kind of classes will be present under the interface. For example, if you have to, let's say, store all the cars and all the bikes and all the bicycles and all the trucks from all around the world, then you can create an interface called vehicle and create all of these classes under the interface. And these classes will be about cars, about trucks, and about other kind of vehicles. So an interface is a generic blueprint of specific class implementation. That's a very simple definition of an interface. And like I said, we will go deeper into this concept in the upcoming lectures. So that was about interfaces. Similarly, when we talk about abstract classes, the next legend here, abstract classes are also similar to interfaces where they provide you a generalization, but at the same time, abstract classes provide you a way to also write some concrete implementation. For example, if we take the example of a bank account, so there in a bank, you have different kinds of accounts. You have savings accounts, you have recurring accounts, you have current accounts, and there are many other different types of accounts. So there would be some common implementation and logic which will be applicable to all the account types. For example, an account must have an account holder. That account holder must have a valid KYC done, for example. So there would be some sort of common logic which will be applicable to all of these, right? So that common logic, so you have two options. Either you can write that common logic again and again in the savings account class, in the current account class, in the loan account class, etc., etc. Or you can write it at a central place and just refer it from there. So that's where you will use abstract classes. So you will create an abstract class of an account, and then you will create these child classes under this account class, which will be the savings account class, the loan account class, the current account class, etc. So this is a very lightning introduction to you about interfaces and abstract classes. And class, as we know, is basically a concrete blueprint which holds data and logic together. So here iterable is an interface which will just specify that all the kinds of data structure which can be iterated, which can be looped over, should be present under this particular interface. That's why we created this interface. So under iterable, we have this collections interface, and this will govern that everything which will present under the collection interface will be holding some sort of a collection of items. Now we look at the next set of interfaces. We see a set interface, we see a list interface, and we see a queue interface. When we talk about the set interface, these three different types of interfaces represent three different properties of collection, and these properties are exclusive of each other. For example, if we talk about set, so set has a property that everything which you put into set will be unique. It will never ever tolerate or contain any duplicate elements. That's the property of set. So now you can see whenever you have a scenario where there is a strict constraint that your collection should never have duplicates, you will use sets. When we talk about lists, list is probably the most lenient representation of a collection. It can store anything. It can store duplicates as well. It will not raise an error or a warning if you store same element multiple times. It will happily store it. But at the same time, the list is basically an index-based collection. You can access the elements starting from the index 0 till the last element. That's the basic value proposition. So whenever you have a requirement where you want to access the elements into a predefined sequence and one by one, then you should use list. Also, the order is fixed here. The first element will always come after the 0th element. The second element will always come after the first element. So whenever you iterate over this particular list, you will never have a scenario where you do not know the order of the elements being accessed. They will always be accessed in a predefined order. So it's basically, we can call it as an indexed ordered collection which can hold duplicates. Then the third one is queue here. So queue is basically, as you can, this is basically inspired from real world. So think of any queue. If you go to buy something at a grocery store, or if you go to buy a ticket at a railway station, or you go to the check-in counter at the airports, so you stand in a queue. And the concept of queue is that it works on a concept of first in, first out. The person who first went into the queue will be the person first being served and coming out of the queue. And if the second person comes, that has to be standing behind the first person. And once the first person is served and goes out of the queue, the second person comes at the front of the queue, and that particular person is served. So you can see it's if you have to store that kind of behavior, or if you have to implement that kind of behavior in a Java program, then you would use queues. So this was about the top level interfaces, which are set, list, and queue. And out of these, list and set are very, very popularly used, very heavily used in any kind of Java enterprise grade application. Now there are more interfaces like sorted set, navigable set, and dequeue. Sorted set is basically forcing additional constraint on the set that the elements will be unique. At the same time, you can also have the elements into a sorted order. That sorting can be an incremental sorting or decremental sorting, that depends. But the whole idea is that it will be sorted. Similarly, navigable set brings another navigation kind of properties. DQ is basically a double-ended queue where the elements can be inserted and removed both from the front and from the back. So there are the different properties of these interfaces. But like I said, the most popular ones are these three ones. Now let's talk about the abstract classes. So the abstract classes you see here are abstract collection, abstract set, abstract list, abstract queue, abstract sequential list. Generally, you will not be using these directly. You don't need to use them directly, but you should be aware that they exist. If you have a very specific case where you want to use these abstract classes, you can use them in Java program, but most of the time you don't need to use them. And most of the times you will be dealing with either the interfaces or you will be dealing with the concrete classes. Now this lecture is getting a bit long, so I will like to stop this lecture here. So we covered about the interfaces part of the collection, and we also understood a bit about the abstract classes, though we are not going to use abstract classes in much detail in the programs. Let's get started with discussing the concrete classes in the collections framework. In the previous session, we talked about the interfaces part of it, where we discussed about sets, the lists, and the queues, and we also touched a bit upon the abstract classes. And like I mentioned earlier, you don't need to generally use these abstract classes directly in your Java program, but you must be aware that they exist. You see some arrows here, right? If I just scroll up, you see multiple kind of arrows here. These arrows mean that if the arrow goes from bottom to top, it means this particular element is a type of the parent. It's basically denoting a parent-child kind of relationship. So for example, here you see tree set is basically a navigable set, and also extends abstract set, which extends set. So similarly, you can see all kind of complex relationships here, and generally you don't need to remember all of those. You only need to remember the few, and those few are basically easily can be spotted. For example, whenever you see a tree set, it means it's basically a type of set. Whenever you see a word called list, that means that it is a type of list. And whenever you see a word called queue, then it means that it is a type of queue. So let's understand these classes. Let's first go to the list interface. So you can see list interface has the relationship with abstract list, and from there it goes down to array list. Abstract list has another child which is called abstract sequential list, which is another abstract class, and which has a concrete class which is called linked list. So let's understand these two collections, or these two types of list right now. So when we talk about array list, let's understand this. We already have covered arrays. So what are array lists? They are very similar to arrays in a way that they are also indexed based collections. So you can store elements and access them based on the index position, starting from 0 going till the length -1 index. And this is an ordered collection. You can access the elements only in a predefined sequence. It can obviously accept duplicates as well. And these all our properties are also applicable to arrays. The differentiating factor here is that array list is a dynamic array. It's not a static array. If you remember, when we talked about arrays, we had to initialize it, or we had to specify a fixed size of it while we initialize it. Once you have initialized the array size, you cannot change the array size. It is static, it is fixed. So if you have created an array of elements 10, and if you're trying to store the 11th element, you are going to get an array of array index bound of exception. But in case of array list, it dynamically updates its size based on the number of elements stored. You can still initialize it with some initial size. Let's say you initialize an array list and you say that you want to initialize it with a size of 10 elements. Absolutely fine. But the moment you try to store the 11th element, array list is going to dynamically update its size from 10 to something else. So it will keep updating its size based on the number of elements which are coming to the collection. That's the whole property of array list. So remember, it's used in the cases when you have an ordered collection to store and you want to access them based on the index, and you want a dynamic update of the size. The second sibling of it, which is linked list, is also a type of list, but it has slightly different properties than array list. In case of array list, it was an index-based collection. You access the element based on the indexes. But in linked list, you access the elements based on the previous and the next element. That's pretty much what it knows. So an item can only be accessed in a particular sequence starting from head to the tail. And when we talk about linked list, the idea is that you have an element which will have a data, and it will also have a pointer, or basically a reference. That reference will be pointing to the next element in the linked list. Similarly, the next element will store the value, the actual data, and it will also store a reference to the next element. So you can see, if you have to go to the 5th element, you cannot directly say linked list of 5 the way you can say this in array list, because array list is an index-based position list, right? So you can access the 0th element or the 5th element or the 10th element directly, just in one line or one go. But in case of linked list, you cannot access the 5th element or the last element of the linked list directly. You have to start from the first element and keep jumping the references till you reach the last element. That's the property of linked list. So these are the two types of list. Now let's talk about the type of set. A type of set which is not mentioned here is hash set, which is a very popular type. So a set generally has two popular types, hash set and tree set. So let's talk about both of those. If I talk about hash set, the property is that it will inherit the existing properties of set, which is that element should be unique. That's good. But along with that, hash set will not remember or honor the order in which the elements are inserted into it. It will, if let's say if you insert 15 or 20 different elements inside hash set, and then if you try to iterate over the hash set, every time the order in which the elements are accessed and printed will be different. Every time the order of accession will be different. Every time the way in which the elements are accessed, their order will be different. You cannot predict that. And that's the property of hash set. Whereas when we talk about tree set, in case of tree set, you can have a sort of fixed order and a tree hierarchy. So a tree hierarchy, if you know about the tree data structure from the data structure and algorithm section, you already would know what a tree looks like. Basically, it has a root and it has child. This is basically, you can call this a tree as well, right? So whenever you have to store the values in a tree fashion where you can navigate through the parent and childs, then you would use the tree set. And remember, since it is a set, it will still inherit the uniqueness property of set. So that's about hash set and tree set. So we covered about list, we covered about sets. Now let's talk about these ones, which are vector, stack, and priority queue. So let's first understand about priority queue. So you would use a priority queue when you need a FIFO arrangement, but at the same time, if there are few elements in the queue which cannot wait to be executed or processed when their turn comes, they want it to be executed on priority. So whenever you have such use case where you want to maintain a FIFO fashion collection, but at the same time, you also want to allow few elements of it to override this FIFO arrangement and get processed ahead of their queue number. So you can use priority queue in those cases. Talking about stack, let's understand stack first. And stack is a LIFO arrangement, last in, first out. So remember in your house when you put plates, the normal dinner plates over one over each other, you are basically creating a stack. So the property is that the plate which is put first on the table will be picked up at the very last. And the plate which is put the last on the stack, let's say you put 5 plates on top of one on top of other, then the fifth plate will be consumed first. Anybody would pick the plate from the very top. They will not pick the bottom plate because it's almost impossible. If you have a big stack, you cannot pull out the bottommost plate. The stack will fall down. So you will always pick out the elements from the top. So it has a LIFO arrangement. So whenever you have to create a last in, first out kind of arrangement in your program for storing collections, you will use stack. Talking about vectors, vectors are very similar to lists. They're exactly similar. There is basically one major difference is that vectors are thread safe and lists are not thread safe. Now list has provided a way to be thread safe. We will cover that later. But for now, you can understand that whenever you have a program in which you want to access a collection in a thread safe manner, where two threads cannot modify the same element at the same time, then you will use vectors. So we covered about the complete collections framework classes, the interfaces, and the abstract classes. And always remember the reason why you will use array list or linked list or a hash set or a tree set or a vector or a priority queue or a stack. That is the most important concept I want you to take away from this session. Let's get started with array lists in Java. So when we talk about array list, we are technically talking about a list. In the previous session, I covered in detail about the various implementation of list interface, which were array list and linked list. And in today's session, we'll be focusing only on the array list. I have opened the API documentation of the array list class. So if we just scroll down, we will see a nice description which is provided by Java. And it broadly covers all the points which I described in the previous session, which were that an array list is basically an array-based implementation of a list. It's an index-based implementation. So you can access the elements based on their index position. You can directly access any element if you know its index. It accepts any kind of duplicates as well. And by default, it is not thread safe. If two threads are trying to access the same collection at the same time, or maybe trying to modify the collection, then you will get inconsistent behavior. So that was about the basic description of array list. It provides a lot of interesting utility methods as well for adding elements, for adding multiple elements, for removing elements, for fetching an element from the array list. And we will cover those methods in detail in the demo. And with that, maybe let's switch to the demo. So for this, I have created a class which is called ArrayListDemo. It has a public static void main method, and it has an array list example written inside it. So at line number 10, you see that there is an initialization happening for the array list. And this is how you basically initialize the array list. To start with, you write the interface name. You can obviously write array list as well here. Instead of list, you can write array list. That is absolutely acceptable. But the reason I have written list here is because it is a better practice, or I would say it is a best practice, to always initialize the concrete implementations with the interface type. I'm making a very generic statement which is applicable to collections and at any other type of classes and objects you might be creating in your program. Always try to declare it with the type of interface and then define the concrete implementation on the right hand side. So the LHS or the left hand side will contain the interface declaration and the right hand side will contain the concrete implementation. The reason for this is that if tomorrow, if you have to change the representation of this array list to, let's say, a linked list, then you don't need to do a lot of work because the linked list is also a child of the list interface. So since list understands and knows about both of the classes, you can interchangeably use this reference to point to any of those implementations. That's why it is considered a best practice to basically write the left-hand side as the interface and the right-hand side as the concrete implementation. That's the first bit of it. Second interesting thing you notice is this. So you see these expressions here, and this basically encloses any kind of generics or class type. What are generics? We will cover this in detail in the upcoming sessions. For now, what you can understand and what you should know that these are denoting a class type of which the objects will be stored inside this particular list. So once I say list of integer, it means that this particular list is only going to hold integer objects. If you try to insert a string object, or if you try to insert a character object, or if you try to insert a float object or any other kind of object, it will create an error because remember in the very first lecture, we said that Java is strongly typed language. It has very strong checks for these kind of data type mismatch. So if that's why it will expect you to specify the object type here, and whatever type you have specified here, that's the kind of objects which are going to be stored inside this list. I have been using these terms called classes and objects interchangeably, but for now, what you can understand that this is a type. How we write classes and how we write objects and how we create objects. Again, I will cover this in detail in the upcoming sessions. So we have specified the list interface, and I'm saying that this particular variable should hold any list of integer type. Then on the right-hand side, I'm specifying what type of list this array list is. And this array list will be an array list class type. And again, I have to specify the class type specifications. And then I'm specifying a size here. This is the size of the array list, the initial size of the array list. You can obviously write it without this as well. This is also a perfectly fine statement in Java. And in this case, the array list is going to be initialized with its default size. If you specify a value, then the array list will be initialized with only that size. It is also considered a best practice to always initialize the array list with some known initial value. Let's say if this array list is going to store only 2 elements and the default size is definitely way bigger than 2 elements, then you're going to waste a lot of memories. So that's why it is a best practice to explicitly specify some sort of an initial size. This is also acceptable because it is automatically inferring the type from the declaration. You don't need to specify it again here. In fact, some of these modern IDEs will also show you a warning if you write it here. So the next thing I'm going to do is basically going to add some elements to this array list. So I've created an array list which should hold only integer values, and it should hold to start with 5 values, but it will not complain if you try to add the 6th value. So for that, I have just written a small loop here. Let me just put curly braces around it for readability. So I'm saying int I equal to 1, I should be less than equal to 5, I plus plus, and I keep doing array list dot add. So this add method is the method which is used to add elements to the array list. So whenever you have to add an element to the array list, remember you need to use the method add and then specify the actual element which is supposed to be added. So I'm adding 1, 2, 3, 4, 5 in this array list one by one using this loop. And then I'm just printing the whole array list. That's what I'm doing here. After that, to showcase another operation of this array list, I'm removing an element. And if we have to remove an element from array list, just simply call array list dot remove and specify the index from which you want to remove the element. Remember, you need to specify the index. And as I said in the beginning, this is an array-based implementation. So this is going to start from 0. So when I say remove the element at index 3, technically it's the 4th element of the array list. After that, once we have removed the element, I'm again displaying the modified array list and then printing all the elements of the array list one by one. And for fetching the element, if you see here, if you observe this particular for loop, I'm using a couple of more interesting methods of the array list. Let's understand those methods as well, and then I will run the program. So here you see that I'm saying int I equal to 0, and then I'm saying I less than array list dot size. So if this array list has a initial capacity of storing 5 elements, and I've just added 5 elements to it, then the array list dot size will be 5, but it says less than. So it will start from 0 and run till I equal to 4, because the moment I becomes 5, 5 is not less than 5, and it will come out of the loop. So basically I'm trying to start this loop where i's value starts from 0 and goes till 4. And here I'm calling another array list method which is used to fetch an element from the array list. So whenever you have to get an element from the array list, just call .get on the array list. So array list .get, and I'm specifying the I value. So array list .get of 0, get of 1, get of 2, get of 3, and get of 4. And that's technically the 5 elements which are stored in this array list. So let's run this program. So, and now let's observe the outputs here. Let me just bring the outputs down. Yeah. So at first I'm just printing the array list. So nothing. I'm just adding the elements and printing the complete array list. So if you want to just print the whole array list, just put that inside system.out.println, and the whole array list will be printed. That's line 17. Then I remove the element at index 3. So if I traverse through this particular list, this is index 0, index 1, index 2, and index 3. So index 3 has an element which has a value 4. And I'm saying array list dot remove the element at index 3. So this particular element should be removed from this particular list when I call the line 20. And then if I print the modified array list at line 24, I can see that 4 is gone now. It's only 1, 2, 3, 5. That's the remaining list. You also need to notice that whenever I call system.out.println with array list, I get this square brackets, which is the representation of an array list. If you don't want that, you might not want that always, right? If you want to print this nicely without the square brackets, then you have to iterate over the array list. And that's what I'm doing here. I'm going from 0 to array list.size, and I'm doing get of 0, get of 1, get of 2, and get of 3. And that's how I get these values without 4. We can also write the same loop using for enhanced loop. So let's say if I write for int I colon array list, and then inside it I can just say system.out.println I. And if I comment this particular loop for a moment and run this program, I see the values one by one because it's ln, so every output comes on a new line, but you can pretty much see the same output. If I remove this and if I write it like this, just adding an extra space, it will look a bit more nice, a bit more formatted like this. So as you can see that we can get the pretty much the same output either using a classic for loop style, which is a bit verbose, or you can use an enhanced for loop, which is a much simpler and shorter and less verbose way of doing exactly the same thing. You don't even need to call the arraylist.getI. But the reason I put this example because I wanted to show you the get functionality as well. Let's get started with linked lists in Java. In the previous session, we talked about array lists, and today we are going to talk about the another type of implementation of the list interface, which is called linked list. If you remember from the previous sessions, we discussed about the properties of the linked list, and all those properties are listed here as well. So basic idea is that whenever you want to have a kind of implementation where the order of the elements is strictly maintained, where the first element can refer to the second element can refer to the third element, and so on. In those kind of cases, you are going to use linked list. Another property of linked list is that you cannot randomly access an element directly as you could do in case of array list. In case of array list, you just write arraylist.get and you provide the index location and you get the element right away. That's not possible in linked list. In linked list, if you have to access the, let's say, the second last element or the fifth element in a 10 size element list, in that case, you have to start from the head, which is the first element, and keep traversing till the fifth element. That's the only way possible to access the fifth element or any random element. So that's the property of linked list. It is also not synchronized. So if multiple threads are trying to access a linked list concurrently, at least one of the threads and one of the threads tries to modify the list, then it must be synchronized externally by some other ways. Otherwise, you'll get unpredictable results. And again, this also provides a bunch of utility methods, and we will cover some of those methods. As you can see, add method for adding an element, add all, add first, contains, get first, get last. We will cover some of these methods in the demonstration, which follows this particular documentation. And with that, let's jump to the implementation. So I have prepared an example here for the linked list, which is called linked list demo. I've just created a class for it, and we have created a public static void main method here. And here you can see at line number 10, I have declared a linked list. So this looks very similar to the way we declared an array list. You see, if you have noticed on the LHS, I have written the concrete class and I've not written the interface. Reason being, I'm using some concrete methods and actual methods which are only available in the linked list class. So I am not looking at the reusability aspect in this particular example. If you are, then you have to add extra code for it. But here I'm just writing linked list. And again, in this particular linked list, I'm saying that I would only store string objects. So that's why inside these braces, I write string, and then I say new linked list string. Again, I have not specified the size, so it will take the default size as per the JVM implementation. Now I have declared my linked list, and it's time to add some elements to the linked list. For that, I have the method add, which is available in this linked list class, which will provide me with the capability to add elements. So at line number 12 and line number 13, I'm adding 2 elements. And if you remember, I told you that it works in a reference-based implementation. So at first, an element A will be added. And when you try to add element B, element A's reference will be updated to point to B. That's what will happen in this linked list. And then at line 14, I'm using another interesting utility method of this linked list class, which says add last. What this method does, that specifically it will add the element at the very end of the linked list. So that was about add last. And if I talk about line 15, I'm using another interesting method of linked list class, which is called add first. So what this will do, that this is going to insert this element D at the very beginning of this linked list, like even before A, D will be inserted. So whatever your linked list looks like, whenever you call add first, that element is going to be inserted at the very head of the linked list or the very beginning of the linked list. Linked list also provides another variant of the add method. So there's one way to just add the string element directly because this is a string linked list. You can also add it based on the position. So you can say add E at the second position inside the linked list. So let's observe this output. Let me comment all the code below line 18 because we will be using some more methods here. So we'll cover that in a while, but let's first understand the output at line 18 if we run this program. So right click, run as Java application, and this is the output we get. So let's understand the output. Or maybe let me do this. Let me put this here one by one so that we can interpret the output. So I'm adding two elements and printing the list, then calling add last and printing the new list, then calling add first, printing the new list, and then calling list.add2, e and printing the list again. So let's observe these outputs one by one. I'll comment this and let's run this now. So if I run this particular program, the program till line 14 is executed because rest of the code is all commented. Let me comment this as well. And if I run it again, yes, this is the output I get. So at line 12 and 13, I've added two elements and I print the list. There are only two elements and they're printed in the fashion A, B. Everything is good here. Now let's uncomment this code. And now I'm calling add last method and I'm adding an element with string C, which should be added at the very last of this particular list. So let's see now what happens. Let me comment this one so that we only see one list at the output. Okay, we see A, B, C. So C has been successfully added to the end of the list. Now let's interpret this particular method, which is called add first. So I'm going to uncomment this and comment the previous sysout. So now there's only one sysout here. So I'm adding two elements, adding C at the last, and now adding D at the very beginning and printing out the list. Let's see what happens. Okay, so the D has been added at the very beginning of the list, even before A. So now it looks like D, A, B, C. So far, so good. Now let's move to this particular code. And now I'm saying add an element called E at the second position inside this list. Remember, second position. So let's run this list now, this program now. So now I see D, A. If you remember, the previous output was D, A, B, C. If I just uncomment this for a while, just to make it more clearer, and if I run this program, the previous list was D, A, B, C, and the new one says D, A, E. E has been inserted at the position 2. So 0, 1, 2. Position 2 has been added with this new string E, and my list is modified. Now it's time to find some interesting operations about the removal. So what happens if I try to remove elements from this list? And then we will observe the output again. So let's say if I say list.remove B, and so I'm saying just drop this particular element. So you can directly specify that particular element's value, and that element will be removed from the list. And let's see what output do I get if I just call list.remove B and I comment the rest of the code. We should see a new output here, which should not have B. So running the program again, yes. So this was the old collection, and this is the new collection from which B is gone because I've called list.remove B. Now you can also remove elements based on the index position. Instead of specifying the element explicitly, you can specify the index position. And what happens if I call list.remove 3? Let's observe the output here as well. So I'm just going to copy paste this out, and we'll see what output do we get if we remove the element at third location. Okay, so this was the previous output after removing B. And if I call list.remove 3, so 0, 1, 2, 3. C is the element which is at third location, and it is gone. When I call list.remove 3, C is gone, and D, A, E is only remaining. Now let's try to understand this particular line which says list.remove first. Expectedly, this is going to remove the element from the very beginning. So whatever element is present at the beginning, it is going to remove the element, and then we are going to print the list, the modified list. So we were here till DAE, and D was the element which was at the beginning. And if I called remove first, D is removed, and now only A, E is available. And now I use another interesting method, which is called list.remove last. And then I print the list, the modified list. So this is the list remaining, and I'm calling remove last. So E should be dropped, and only A should be left in this particular list. Yes, we only see A here. So this is basically what I wanted to show you in this program, that we can perform different kind of operations using different methods like add first, add last, remove first, remove last. Obviously, there are more interesting methods available in this particular class. Do check out the API documentation for it. And there you can see all the different interesting methods which you can use while implementing linked list. Let's get started with HashSet in Java. If you remember, I covered in the collections framework session that HashSet is part of the set interface hierarchy, and sets have a property that they keep the collections element unique. If you try to add duplicate elements to a set, it will not accept that, and it will still maintain the uniqueness property of the collection. HashSet provides some additional features to the set, which is that in this case, the elements would be accessed in a random fashion. They will not be accessed in a fixed sequence, rather they will be accessed in a random fashion. Hence the name HashSet. So if you read about this particular class in the documentation, it will basically cover all the things which I just described. It also accepts null elements if you want to insert null, but why would you try to insert null? That's the first question which you should ask. It again provides similar kind of utility methods to the list interface collection hierarchy we covered, like some utility methods to add the elements, to remove the elements, to check the size of the collection, and to check if an element exists in the collection or not, etc., etc. And we will cover some of these methods in the demo. This is again not synchronized, so this is not a thread safe collection, which you should know. So let's look at a demonstration of HashSet and how do we actually create a HashSet, how do we operate upon a HashSet using different utility methods. So as you can see, I have created a class here which is called HashSet demo. There's a public static void main method, and then at line number 10, you will see that I have created the HashSet. And again, it starts with a concrete class here which says HashSet, and you can obviously write it as set as well, which will also work fine. So we write the set type as string. So this particular set is going to hold only and only string objects and nothing else. And this set is basically a type of HashSet. Again, this is not mandatory, so you can remove that. It will still not complain and the program will run fine. If you want to specify a size, please do that. If you do not want to specify the size, nothing goes wrong and it will be initialized with the default memory footprint. But remember, doing this wastes a bit of memory. So if you're running this program on a machine which is really tight on memory, always put some kind of initialization size based on your knowledge of how many elements are going to be stored in this collection. So after that, at line number 12, we start adding elements to this collection. And for adding the elements, the method which is provided by the HashSet class is add. So you use the add method to add new elements. So at line number 12, line number 13, 14, and 15, I use the method again and again to add some elements. If you observe the line number 14 and the line number 15, these two lines are adding the same element. So I'm trying to add C twice to this particular HashSet. And we will observe the output to see what happens if we try to add duplicate elements in the HashSet. Because if you remember, the sets are supposed to be unique. They should not be storing duplicate elements. That's the property of sets. So that's what I demonstrate by adding duplicate elements to see how it behaves. And let's do that. Let me comment the rest of the code for a while. And let's run just this part of the code where I add C twice and I print the HashSet. And let's see what happens. So I go to run as and I click on Java application and I only see 3 elements. Even though I added 4, I only see 3 and C has been added only once, not twice. Now you might be wondering whether this C is the C added at line 14 or the C added at line 15. So to understand that, we need to understand how HashSet's add method works. So this add method is basically returning a Boolean value. If the element is added successfully, this add is going to return true. And if the element could not be added successfully, this add method is going to return false. So let's do that. Let's store the result of these add methods. Let's call this R1 and let's call this one as R2. Okay, and now we will try to print R1 and R2 and see what happens. So if we write system.out.println and I say R1, and then I just copy this after line 16 and write R2. And now we will observe the output of these to see which, when we did the add at 14 and when we did the add at 16, which add actually resulted in C getting added. Did C get overwritten, or did C did not add twice? What happens? So we see that when we do the add at line 14, we get true. So it means that this add was successful and C was added here. And when I did the add again at line 16, this returned a false. It means the hash set rejected this add operation. So this C was not added. So the actual C was never overwritten. The original C was maintained. And when you try to add a duplicate value with the same value, a duplicate element with the same value, HashSet is going to reject that. So that actually proves that the set will maintain the uniqueness property and it will reject all the duplicates subsequently. That was about the add property. Now let's understand another interesting property of the contains method. Contains method of the set class is used to find if an element exists in the set or not. So you can just use the HashSet variable name dot contains and just type the actual element. And this is going to return true or false based on whether this element is present in the hash set or not present in the hash set. If it is present, then this contains method is going to return true. Otherwise, it is going to return false. So let's run this method and observe the output at line 21. So it says list, we are writing this particular string, which says, does list contain C or not? And it returns true because yes, my hash set does contain C. Now coming to line 23, I use another method of the hash set, which is the remove operation, which you can use to remove an element from the set. And then I'm again doing a sysout and I'm asking to print the set. This should be set and not list. So then I'm checking if what happens to my hash set if I call the remove method, and I'm just printing the modified hash set at line 24. So let's see what happens with the effect of remove operation. Okay, so after removing A, this is what remains in my hash set, and A has been successfully dropped if I call the remove method. And then I try to just iterate over the hash set to show you how does this iteration work. It again works on exactly the same way it has been working for the list implementations, that on the RHS of this column, you write the collection name, so hash set, and on the LHS of this column, you write the representation of the element. So this hash set is going to contain string, and this is just a placeholder. It can be anything. This is just a temporary variable to store the current value at the current step of the hash set iteration. And I'm printing all the items one by one. So if I run this, I'm able to print B and C because that's all which is remaining in this hash set. So this was a very quick demo to show you the functionalities of the hash set. How does hash set maintains uniqueness? How do you remove elements? How do you add elements? How do you check for an element's existence using contains? There's also a method to get the element of the hash set if you want to. So these are all the different properties and methods available in the hash set. And do check out the API documentation of the hash set to learn about more methods. Let's get started with tree sets in Java. And if you remember when we talked about this collection framework, I discussed briefly about tree set, that the main reason you will use tree set is basically when you want to maintain natural ordering of the elements. If you're adding your custom elements, then you need to tell Java how to compare and sort and order the elements. But that's for another day when we'll cover about the detailed comparable and comparator interfaces. For now, what you can understand that whenever you have to maintain the natural order of the elements automatically, then you should use tree set. Along with that, the set property still holds true, that this tree set cannot have duplicate elements. We should also know that tree set is not synchronized, so it is not a thread safe collection. So be aware that whenever you are trying to use tree set in a multi-threaded environment, you need to write more wiring code around it so that tree set works as expected. Okay, that was about a brief theory about the tree set. You can read about it in detail in this tree set documentation class. And with that, let's switch to a demonstration of the treeset class. So I've prepared a class here which is called treesetDemo. As you can see, it has a public static void main method, and at line number 8, I'm initializing the treeset. Again, it's the standard representation of initializing a collection which we have been using throughout the different examples of the collections. So treeset of string. So this particular treeset is going to hold only and only string elements. If you try to add another element, it is going to throw a compilation error. And on the RHS, I'm just saying new treeset. And again, this is not mandatory, so I can remove that and it will still work. You can specify the size. Whenever you know about the scope of the collection, you should always specify the size. For this demonstration, it's a lightweight program, so it's fine. After that, from line number 10 till line number 13, I'm again going to add some elements. And again, if you see, I'm adding elements in random order. I'm adding B, and then I'm adding A, then I am adding C twice just to show you the uniqueness property of the tree set. Does it still hold true or not? We will be able to figure that out from this particular example. And we will also see if I'm adding B before A, will it be printed in a fashion called BAC? Or will it be printed in a fashion called ABC? We should also know that. So let's try to run this program and understand the output. So if we look at the output, we see A before B. But here when we added the elements, we saw B before A. We added B first, and then we added A, and then we added C twice. And as per the uniqueness property of the set, the second addition statement at line number 13 returned false, and set rejected this addition because it could see that C was already present in this particular collection. So C is added only once. But what's interesting is that B is added first, but B is printed after A. So the natural order of the elements in this collection is automatically maintained by treeset. So what under the hood treeset does here, that it looks at the type, which is a predefined type in Java. String is a predefined class in Java. So it will use its own sorting algorithm to sort the strings based on their natural order of sequence. And in the natural order of sequence, A will always come before B and B will always come before C. So it will automatically apply that sorting and will present the result to you. If you're using a custom class here, let's say your own student class or your own customer class or your own account class, in that case, that account class or student class or customer class needs to tell Java how to sort elements. And for that, you need to write comparable and comparator implementations, which we will cover in detail in the future sessions. But for now, you must understand that whatever the type of class you are specifying here should tell Java how to sort the elements. Either Java should know it automatically. If it's a predefined class like string or integer or float or double, then Java would automatically know by default how to sort the elements. But if you're creating a custom class of yours in the tree set and specifying that as the tree set type, then you should also tell Java how to sort the customers, whether you want to sort them based on their first name, whether you want to sort them based on their age, their salary. Java doesn't know that. So you need to tell Java about that if you're trying to use a custom class as the type in tree set. In this particular example, I'm using string here and it will apply the natural ordering. Let's put C here in the very beginning to see what happens. And I can comment this as we have already maintained and verified that C is only printed once and added once. So I'm adding C, B, A, and let's run this program. I still get ABC because again, the natural order is implemented. Contrary to this, when we talked about HashSet, remember I told that HashSet is a random access element collection list. So if you run the HashSet, if you try to print the HashSet again and again and again, you might see a different order. Sometimes if I use a HashSet here, sometimes it will print ABC, sometimes it will print BAC, sometimes it might print CAB, any kind of sequence, any kind of random sequence, it will pick automatically. That's the property of HashSet. But in case of treeset, no matter how many times you run it, you will always get the same order based on the sorting implementation available in the class type. So that's all I wanted to cover about treeset. Please read about its Java documentation in the API docs to understand what all other methods and utilities treeset provides. But it's pretty much similar to what we saw in the HashSet example, like remove or get, etc., and contains, etc. So all similar methods are available in the tree set class as well. And that's all we'll focus on this particular session. And in the next session, we're going to talk about an interesting framework called maps. Let's get started with maps in Java. So first of all, before we understand this particular diagram and the classes in this map framework, let's understand why do we need map. So there would be instances when you would write a Java program or any kind of program, there would be always be instances where you would need to store a key value kind of arrangement. A very simple example can be that you want to maintain a company database and you want to just bring the whole mapping of the employee ID to the employee name into the Java program. How do you do that? You need a key value sort of arrangement where you can store the employee ID as the keys, and each of the employee ID key would correspond to an employee name, which will be called the value. So you need a key and value arrangement in a Java program to store that kind of information and use that kind of information in your program. And that's where map comes into picture. Whenever you have to store a key value arrangement, remember, you would always think about maps. Maps should be the right collection or the right data structure to be used if you want to store any key value arrangement in your program. So that's about map. And here you can see a nice framework representation of map. And this is going to be a theoretical lecture where we will understand how this map framework works, what is the property, and what are the different implementation classes. And then in the future sessions, we will again look at some examples of the most popular map implementation classes which are used in the Java world. So again, the orange oval are interfaces. The blue boxes or the light blue boxes are the abstract classes, and the purple boxes are the concrete classes. So map is an interface which will provide this kind of a blueprint that every class underneath it would be working on a key value arrangement. When we talk about this key value arrangement, so we have these keys and we have the values. So the keys here are supposed to be unique. The values can contain duplicates. Remember, this is a very important concept that in map, the keys will be unique and the values can have duplicate. And because we want to maintain the uniqueness in the keys part, that's why the keys are technically stored as a set, because we know that set cannot contain duplicate. Sets are by design made to be storing only unique elements. So map uses the set class to store its keys, and to store the values, it generally uses a list class. So you can see map is basically reusing the classes from the collections framework, sets for storing the keys and lists for storing the values. That's the basic anatomy and basic idea of how map is working. Now you see some classes here called abstract map and sorted map. And again, similar to the set hierarchy, whenever you see the sorted word, and if you look at the concrete class, which is called tree map, this is going to provide you some sort of an order, sorting order automatically. And then you have the hash map class. And this class is going to be providing a random access. This will not maintain the insertion order. This will not provide you a natural sorting order. This is just to store elements in random order. And the element here, a single element here, is basically consisting of two parts, which is key and value. Always remember that. You also have hash table here. Hash table is basically a synchronized representation. This is a thread safe. Hash map and tree map are non-thread safe. So multiple threads, if you try to work in a multi-threading program with these hash map and tree map, you're going to get very unpredictable results. But if you use hash table, then it is inherently thread safe. So it will only allow one thread to be to access the hash table at a particular time. You will also be thinking then it's always better to use hash table, right? Because you will never get into those weird errors and you don't have to migrate your program to a multi-threaded environment whenever you are trying to use hash tables. Yes, that is true, but hash tables are slower for the same reason, because only one thread can access it at a time, and that's why hash tables are slower. And hash map and tree map are way faster because they allowed multiple access at the same time. So you have to always be mindful of what kind of collection type you're using. There are some external ways as well to make these hash maps and tree maps and hash set and tree set and array list and linked list as synchronized as well. And we will talk about that in a future session. But for now, you can understand that hash map and tree map are non-thread safe and hash table are thread safe. There's another class which is coming out from the hash map class, which is called linked hash map. And linked hash map, as the name shows, it will basically carry two properties. It will carry the property of hash map, where the elements are stored or displayed or accessed in random order. And at the same time, it is also providing the linked property of the linked list, where the sequence is maintained. So you can see you can actually get the insertion order. If you use a linked hash map, the way in which you insert the elements would always be the way in which the elements will be accessed. So you are getting sort of a ordering property, but the order is the insertion order. It's not the natural sort order, it's the insertion order. That's why the name linked hash map, because it brings the linked list part of the link property inside the hash map, where the elements would be presented to you in the order they are inserted when you call the add method. So that's what we covered here. We covered about map interface. We covered about hash map class, which is going to store the values and the access will be random. The value means the element means a key and value. We sometimes also call this as an element. You will see that representation sometimes. Some people also call it as iterable element. It's all the same thing, but it's a key and value arrangement. Tree map also stores the key value arrangement, but it will provide you a sorted representation. And here the sorting will happen on the keys, not on the values. The sorting will be happening. The natural order of sort, which will be maintained by the tree map, is only applicable to the keys here. Similarly, linked hash map, it will insert the elements, but when you try to access it, it will maintain the insertion order. No matter how many times you access it, it will only be presented to you in the order the elements were inserted. And hash table is very similar to hash map, with the difference that hash table is thread safe. Multiple threads cannot manipulate the hash table at a time. It will only let a single thread access itself at a time. So that's the property of hash table. The most popular classes are generally these ones: hash map, tree map, and linked hash map. Very rarely you will also see hash table, but since we have some ways to get these synchronized, so generally you would not see much of the hash table implementation. Let's get started with hash maps in Java. In the previous session, I covered about the theoretical concepts of map and the key value arrangement, and the keys being basically a set and the values basically being a list. And now we are looking at the API documentation of the hash map class. You can see the k, v here. These are the types of the key and the value which the hash map will accept. You can see k is basically the type of keys and v is basically the type of mapped values. Like I explained, it's basically keys are stored in a set fashion and values are stored in a list collection fashion. This is not by default synchronized. So if you want a thread safe collection, then you would have to do something else, which I will cover in the future sessions. This is a very brief overview of what hash map is, but let's look at the example to understand better, and then I will be able to explain it in bit more detail. So now we are looking at an example, which is basically a class which is called hash map demo. I have a main method here, and then at line number 10, I'm initializing the map. And as you can see that on the LHS, we see the concrete class hash map, and I can do this and this will still work provided you have the import here. I had the import here, so it will work fine. And I'm saying that this map is going to contain a key value arrangement where the keys are the string type and the values are of the type integer. And it's ultimately a hash map. Here, I don't need to again provide the generics because I have already provided the generics here. The name of the map is just simply a map. And again, you can specify a size or you can skip the size based on the memory requirements and the program requirements. Now coming to the point where you want to add elements to the map. Now, since this is a key value arrangement, here the name of the method through which you are going to add elements is put. So you call map.put and then you provide the key. comma, you provide the value. That's the syntax for adding an element, or we technically call that element an entry. This key value together is called entry. So if you have to add an entry to the map, you have to write it in this way where key, comma, value is the convention. So I'm adding 3 elements or 3 entries here, which is A, 10, B, 20, and C, 30. A, B, C are basically the keys, and 10, 20, and 30 are the corresponding values of these keys respectively. After that, I'm showcasing another utility method of this particular class, which you can use to find the size of the map. So you can just call map.size and it will print the size of the map. After that, I'm printing the actual map, the whole map. And then I'm using some more methods, but again, let's comment this code and let's understand this code one by one so that there is no confusion. So to start with, I'm going to add some elements, some entries, and I'm going to print the size of the map and the map itself. Let's run this program. So here you can see the size of the map is printed as 3 because I've added 3 entries. And then when I call map inside the system.out.println method, I get the whole map printed here. And this is how the map will look like when it is printed. We can see key equal to value syntax here, where A equal to 10, B equal to 20, and C equal to 30 are the key value representations or the entries here, separated by comma, enclosed by the curly braces. That's how our map looks like. So far, so good. The next thing which I'm going to showcase to you is the contains method. And since the map has this set, which is the keys basically, that's why map provides a method called contains key. Basically, you can check if a particular key is present in the map or not. And if you know the key is present, then it's very easy to get the value from the key. Map will provide a method also where you can supply the key and get the value. So knowing the key is the most important part, and that's why map provides a method called contains key. So you can call this method, specify the key which you want to check for the presence in the map. It is going to check whether A is present in this map's key set or not. If the A is available in this keys, we can see A is available, then this condition is going to hold true. And then, like I said, if you want to fetch the value, then you can call the get method providing the key. You can fetch the value from the key. That's the core idea which you should remember. So I call map.get, specify the key, and this is going to spit out the value which is being pointed by this particular key. In this case, A is pointing to 10. When I say pointing, it's not pointer, remember, it's just a reference. So map.get of A is going to get the actual value which this key is pointing to, which is 10. And then I am printing this integer A, which is the actual value pointed by this particular key. So let's run this program and see if this works. So we get these two outputs from the above, and then this is the output which is coming from the if block. So it checked whether the map is containing a key with the name A. Yes, it was able to find that. And then we asked the Java program to fetch the value corresponding to this particular key. So we just called map.get of A, and it fetched 10 and it printed 10 here. That's why you see 10 here. Okay, so that's how you can basically use the contains key method and the get method. Now, what if you want to iterate over all the keys? What if you have to use all the keys, and you have to make some pattern or make some observation about all the keys in your map? You can do that by iterating over the key set, and for that map provides a method called key set. So you just call map.keyset, and this is going to fetch all the keys in a set representation and will be provided to you. So here when I call map.keyset, this is basically giving me a set which is containing all the keys, and then I'm iterating over the keys one by one. You would be familiar with this syntax by now, which is the enhanced for loop syntax. And inside this, I'm printing the key, which is the current temporary variable holding the current key, and the value pointed by that particular key at that particular step. And I'm again using the same method get, which I showed you here. Same method. So you provide the key and you will get the value. So I'm going to get all the keys, iterate over the keys, and then print the key and the value. Let's see how this looks like. So till this we were good, and here you will see the output which is coming out from this particular for loop. From this particular for loop, line 25 to line 27, where I'm iterating over the key set, printing the key and value one by one. So this is how to show you, if you just have access to the key set, you can still iterate over the whole map. But what if you know everything? You have access to the key set, you have access to the values, and if you just want to iterate over it, then you can use this particular way. And instead of map.keyset, you're going to use map.entrySet. If you remember, map treats each key value arrangement as a single entry. Entry is the keyword here. So map.entrySet is going to give me all the entries in the map, and then each entry is basically of type entry class. This is the representation of each entry, and we know how this representation formed. Entry is the class basically which is coming out of this map collection hierarchy, and then let me just save this, and then string is the key and integer is the value held by each entry inside the map. So that's what we are going to do. We are going to pick up all the entries in the map and going to iterate over the entries one by one by writing this enhanced for loop. And entry is the temporary variable which is going to hold each entry one by one at each step. And then it's very simple. You call entry.getKey, you will get the key, and you call entry.getValue, and you will get the value. So it's much simpler than this one where you had to do map.get to understand. Here it's very implicit. GetKey is going to get you the key, and getValue is going to get you the value. So you just need to call map.entrySet, iterate over the entry set, and get each entry's key and value and print them or do whatever your program requires to be done. That's how you will use it. So let's run this one as well to verify if this works. Okay, so this is the output which is coming from the last loop, this loop basically. You can see key, I did not put any space. That's why you see key A, key B, and key C together. Let me put a space here and put a hyphen so that the output looks better. And let me rerun this. Yeah, this is much better. So you can see the key A, value 10, key B, value 20, and key C, value 30. This is coming from this particular for loop, which I just showed you. So this is all I wanted to cover in this particular session. We went deeper into the hash map representation, and we saw a bunch of methods, contains key, key set, entry set, get, put, etc. And we showed how we can use the hash map for different purposes in the program. In the next session, we'll go deeper into the tree map concept, and we'll also look at a demo of tree map and we'll understand how it works. Let's get started with tree maps in Java. Now, if you remember, in the last lecture, we talked about hash maps in Java, and we also had a look at an example where we saw how a hash map works and how we can use a hash map. We also had a look at different utility methods of the hash map as well. Now, in today's lecture, we are going to focus on tree maps, which is another type of map, as we discussed when we were discussing about the map framework. And the main property of a tree map is that when you enter elements into a map, they will naturally be sorted or naturally be ordered. Now, when I say naturally ordered, what it means that if you put the keys as, let's say, integer, then the tree map will automatically sort all the map entries in an integer sorted fashion, where you'll see the natural number sorting behavior like 1, 2, 3, and so on. Similarly, if you store alphabets or strings, then those will be sorted in a natural sorting alphabetical order starting from A to Z. So these are the data types which the Java is already aware of on how to sort them, like integers, doubles, floats, strings, etc. But there can be a case where you have your custom key. This particular key is your own custom class. If that is the behavior or if that is the scenario, then in that case, you will have to provide an implementation to Java to know how to sort those elements, because Java doesn't know, for example, a student class or an account class. Java doesn't know how to sort that. So if you have that kind of scenario, then in those cases, you will have to provide your own sorting implementation. And we will cover about what kind of sorting implementation you can provide in those kind of scenarios in the upcoming lectures. For now, we will have a look at an example of tree map where you can see that I've created a class which is called tree map demo, and I have initialized a tree map with the keys as integer and the values as string. So this means that each entry of the map will have key as the integer value, and the value of that particular entry will be of string type. So basically an integer to string mapping is what each entry of this tree map is going to store. So nothing different here. You would have already seen this kind of initialization for any kind of map. And after that, at line 11, I use the standard put method of the map, and I started storing the values. So at line 11, I'm saying store 3 and A. So 3 is the key, and string A, remember this is not a character, this is a string because I have specified string here. If you specify a character here and if you try to store a string, this is going to throw an error and you need to fix that. So I store 3 as the key and A as string as the value. Similarly, at line 12, I store 2 as the key and B as the value. And at line C, I store 1 as the key and C as the value. So these integers are the keys and the string are the values. And if I just put them and if I just try to print them, what happens? What kind of order can we expect? Let's try to analyze that. So I right click on this, I go to run as, and I go to run as Java application. It will run the program because I have a static void main method. And now you see that the map is printed in a different fashion than the way it was added. We added the map elements in this sequence that we added 3A first, 2B second, and 1C as the third element. But when we started printing them, we saw 1C printed first, 2B printed second, and 3A printed third. So what this denotes that this tree map, because the key was integer here, it automatically sorted these keys into a natural order sorting, and it provided, when I tried to access the map, it provided the access in that sorted sequence only. No matter how many times you run this particular program, it is always going to return the map in the same format, in the same sequence. The sequence of representation of the elements is not going to change. And you can basically do the similar behavior. For example, if I just change this to string and integer, let's do it like this. And if I again swap the elements here as well, I say A, 3, and I say B, 2, and here I can say C, 1. If I do this, I just switch the keys and values position. Now the string is the key and the integer is the value. And let me just put these two before A so that we can demonstrate the behavior of the tree map properly. So I'm inserting B2 first and C1 second and A3 third. And I just save this file, and now let's run this file and let's see how the output comes. So now you can see that since the key is now string, it has automatically applied the natural sorting ordering of strings, which is starting from A going till Z. And that's why you see A entry as the first entry, B entry as the second entry, and the C entry as the third entry. Again, no matter how many times you run it or you iterate over it, you try to access it, you will always get the sequence in the same fashion. So this is a basic overview of how tree maps work. Now you can, and I would strongly recommend you to go and read about all the other methods which are available in the tree map, which you can use. For example, how can you remove elements? How can you iterate the elements of the tree map, etc. In fact, the iteration is going to be exactly the same way as we have seen in the case of hash maps, because iteration behavior doesn't change. But if you want to see what all different kinds of methods tree map support, it supports a lot of different methods. We can't cover all of them in this short tutorial, but I would strongly recommend you to go and read the Java docs API of the tree map to get familiar with those methods so that you know what kind of functionalities tree map can provide. Let's get started with access modifiers in Java. So when we talk about access modifiers, let's understand what is the underlying philosophy of the reasoning behind this. And the reasoning is very straightforward. It can be even wrapped into a single word, which is called security. The reason is that you will be creating multiple kinds of objects and variables while you write your Java program. And you should always write your Java program or any program in a manner that only the intended classes, packages, modules, or applications should be able to see what they are supposed to see. So as a consumer application, I should only be able to consume the variables which I am expected to consume. I should not get any variable, or I should not even have access to any variable which I am not supposed to access. So the idea is providing the least privilege principle. Give access to different functions, different variables, different programs only by providing them the kind of access which they need to run efficiently, and do not give them complete access. So with that notion in mind, Java created the concept of access modifiers, and it created these three modifiers, which are called public, protected, and private. If you do not provide any modifier, then it goes to no modifier, or some people also call it as default modifier, which is also a type of access modifier. So let's understand theoretically first how it works, and then we will try to have a look at an example. Let's understand the first one. First of all, these modifiers are keywords, and you can use these keywords in front of classes, in front of variables, and also in front of methods. And you might have already noticed this particular keyword called public in front of all the classes I've created, or even when we talked about the public static void main method, we saw this public as a keyword. It is basically an access modifier. And whenever you put public in front of a class or a variable or a method, that particular component becomes available to the whole of the program. It will be available to the whole world, basically. Any subclass or any package or any other class which might have been written in your Java program will be able to access that particular class or variable or method if you put public in front of that. The second modifier level is protected. One of the other thing which you will understand as I explain this is that as you move down into this particular table, the access level will start getting more and more restricted. And by restriction, I mean that less and less components will be able to get access to those modifiers. So if you write protected in front of a class or in front of a method or in front of a variable, then everything within that particular class will still be able to access it. Everything within the package will still be able to access it. I still haven't covered the concept of package, but I briefly touched upon it, showing you how whenever we write a class, we have a package in front of it, and package is technically just an aggregation of the classes. If you have to write multiple classes and wrap all of those classes into a single logical bundle, that would be called a package. Just to show you an example, these all are packages which you see here. You see this square box here, and you see these names. These all are packages, and these packages contain multiple classes. And technically, that's all the packages mean, that you can wrap multiple related classes into a single package. So coming back to the access modifier, whenever you write protected in front of a class or a variable or a method, then that particular component will be accessible to everybody within the same class, everybody within the same package. It will also be accessible to everybody which is a subclass of the class. This is again a new concept which I have not covered, but this basically means a child of this class. Now, what is a child of the class? We will cover that concept in detail when we will talk about inheritance. But for now, you can understand that it is basically an extension of the class. So when the moment you declare something as protected, it can easily be accessible within the same class in which this protected component was declared. It can be accessed in the package. It can also be accessed in the subclasses of the class, but anything outside the package will not be able to access it because you see an N here. Then we have the default access modifier or no modifier. If you do not write anything in front of a class or a method or a variable, it gets the default access modifier privileges. And that privilege means that anybody within the same class will be able to access that default variable or a default component. Anybody within the package will also be able to access it. The subclasses of the class where the default component was declared, those subclasses will not be able to access it. And anybody outside the package will obviously not be able to access it. Then comes the last one, which is the most restricted privilege, which is called private. So if you put private in front of a class or in front of a method or in front of a variable, that component will only be accessible within the class where it was declared. It will not be accessible in the package. It will not be accessible in the subclasses and definitely not be accessible to anybody outside the package. So private is the least privileged or least access permission level you have in Java. Once you write private in front of any component, that only the class's other variables, the same class in which you declare this particular private variable, only that class itself will be able to access it and nobody else will be able to access it. And as you move above, the accesses become more and more lenient. You can see there's just one Y and three N here. The moment you move a bit above to the default modifier, you get two Ys. So everybody in the class and everybody in the package will be able to access that particular component. For the rest of the other world, it is still a no. When you write something as protected, then everything in the class, everything in the package, and everything in the subclasses will also be able to access it. Rest of the world cannot access it. And if you write something as public, then anybody can access it. It's like Y everywhere. So that is how the access levels work. Now let us understand this with the help of example. So I will go here and I've just written a very simple dummy class here, which is a class called test. And I have a method here, which is a display method. So very simple class, nothing fancy here. And if you notice, I have not put any kind of public, private, or protected modifier in front of the class. So this will get the default privilege. If something has default privilege, then the whole world will not be able to access it. So let's go to a different package. Let's go to this package, which is here. And let's try to access this particular test class. So we will try to access this test.java here in the main class. So let's try to do that. Let's say test t equal to new test. I'm just initializing the same class. So what do I get? I get a compile error. Let me try to fix it if I can, and I cannot fix it. If you see, I'm just trying to use this particular test class into a different package, but that package is not able to see the class at all. I'm getting a compilation error, and if I try to click on the error, generally Eclipse provide me suggestions to import this particular class. But Eclipse is not able to find any class with the name of test, which can be imported in this package, which is a different package than the one of the test class. So we cannot access it because it's in the default access. Now let's go back to the test class and let's make it public. So I've just made it public here. And now if I click on this again, I get the suggestion. If you see, this suggestion was not there earlier. Now it says import test. And if I click on this, double click, it gets imported and everything is happy. So you can see the whole access modifier in effect here, the default versus public. You can also try the other kind of access modifiers. Let's try private as well. I think private will also have the same effect because it will still not be accessible from the package or from the subclass or from the whole world. We already saw this particular in effect, but we'll see the private in a different way now. So going back to the test class, I've made the class as public, but the method here is default. I've not exposed this method to be used outside the class. Let's see what happens if I try to call this display method from the main class. So I have successfully initialized the class, and if I say t dot, and if I look at the suggestions here, I do not get the suggestion of the display method. Why? Because it is default. If I go back, make it private, can I now access it? Let's try again. Nope, still we can't access it. Eclipse is not even able to find it inside this package because it is private. Let's go back and make it public. So I've made it just public now. Going back to the main class and again saying t dot, now I get the display suggestion as the first suggested method here. And now I am able to use the display method once I have made it public. So you see, the moment you change the access modifiers, the changes are propagated immediately. And you can see the public versus default versus private in play here. We can even go into further detail by using the protected, but for protected, I have to explain the concept of subclasses. So I will cover this protected versus subclasses concept when I talk about inheritance, and there we will see the usage of protected variables and the protected access modifier. But we saw the usage of public, the default modifier, and the private modifier. Do check out the documentation for these access modifiers. And I would strongly suggest you to play around with this, get more comfortable with this concept of different kind of modifiers. Let's also run an example for understanding the default modifier in a better sense, because we can see that for the package, it says Y, right? So let's go back to Eclipse, and within the same package where we created test class, let's create another class. Let's call it test demo. So I will just click finish. I get a new class. Let me also write the public static void main method here. So I get the public static void main method here, and let's try to access the test class here within the same package. So let me again go back to the default privilege here. So I put the test class access as the default class or default access, and same goes for display. So can other classes in the same package access the test class now? Let's see that. If I go to test demo, and here if I try to get the test class initialize, does it work or does it give me a compilation error? Yes, it works. It works because the test class and the test demo are in the same package, and test class has the default access privilege. So let's try to run one more variation of it to understand the usage of the private method better. Going back to the test class, this display method has the default privilege right now. So going by that logic, if I say t dot, I should be able to get access to the display method. And yes, that is possible. If I run this particular program, I will be able to get whatever is given out by the display method, which is hello world. Now let's try to make this particular method as private. And let's try to access this method from one of the other class in the same package as of the test class. So the class is default, the method is private. And if you see, this class has already turned red. There is a compilation error because now the display method is not accessible to the test demo class. Even if it was in the same package, it's not accessible because the display method's privilege or access modifier has gone to private now. Exactly the same as explained here. Because it has become private, so the package level members cannot access it. There's an N here. So this was another variation to show you how you can use public, protected, and private together to only expose the members, methods, and classes which are supposed to be exposed to the consumer. This is a very critical and very important concept to be used in Java, and it is used from a very simple program to all the highly complex application. This is sort of the bare bone or the laying foundation for any kind of basic security level premise which you need to build in an application. Let's get started with inheritance. So inheritance is basically one of the most important properties of any object-oriented programming language. It's basically a concept, and the concept says that what if you have a scenario where you want multiple classes to share similar behavior and similar properties. Let's understand this with the help of an example. Let's take the example of a bank. When you go to a bank to open an account, there are multiple types of accounts. There can be a savings account. It can be a type of current account. There can also be a different offering for personal account and commercial accounts, such as for businesses. Then you may also have loan accounts, which are having different kind of properties. So all of these types of accounts are still technically accounts, and they will share some similar properties. For example, all of them will have to maintain some sort of an interest rate, for example. All of them will be used to either deposit money or withdraw money. So there would be some kind of similarity across all of these types of account classes. But at the same time, there will also be some sort of differentiality amongst these classes. The way you will calculate the interest rate for a current account will be different from the way you will calculate the interest rate for a savings account. And the same applies for commercial account, personal account, loan account, etc. So you see that we have some common behavior, but at the same time, we also have some different behavior. So whenever you have such scenario, always think about applying the concept of inheritance in your application. There's another simple way to spot whether inheritance can be used at a particular place or not. Inheritance is also called is a relationship. So whenever you read the requirements from a customer, just try to find the words which use this particular phrase is a. For example, car is a vehicle. Savings account is a type of account. Similarly, you will find many other types of similar examples. So whenever you will see that is a relationship between two different kinds of objects or two different kind of entities, that means that there might be an inheritance relationship being applied between them. And that's how you will spot the usage of inheritance. So far we have understood this concept that there would be some sort of relationship between the two classes. What will be this relationship? The relationship will be of parent-child type. There will be a parent class. Some people also call that as base class. And then there will be a child class. So the child class will be inheriting the properties and the behaviors from the base class or from the parent class. I will be using base class and parent class terms interchangeably during this session. But the basic idea and basic premise is like that only, that there will be a child class and there will be a parent class. And the child class is extending from the parents class. Remember the word extend because we are going to use that. And I've just shown you the what you see here is basically the official definition, which is given by Java docs here. We can read the definition as well. And the basic idea, which I told you, lies in the parent and child relationship. And this is how you can conceptualize it, that you will have a base class or a parent class, and then you can have multiple children of it. And then those children can again have their own children, and so on and so forth. So this hierarchy, this whole inheritance hierarchy, can go as deep as you want it to be. And that's the basic idea and basic conceptualization of how you understand and how you visualize inheritance. Now let's move to Eclipse IDE and try to understand this with the help of an example. So for this particular case, I have created a set of classes basically, which we will be using to demonstrate the relationship of inheritance. And I've taken the simple example of a bicycle. So a bicycle is again a very generic definition of any two-wheeler, and bicycles can have multiple types. There can be an all-terrain bike, there can be a mountain bike, there can be a city bike, there can be a bike which is specifically made for ladies, and similarly there can be multiple different types of bikes. But all of these bikes will have some similar properties. For example, all of them will have two wheels. All of them will have a seat. All of them will have brake. All of them will have some sort of a speeding mechanism, whether they can accelerate or deaccelerate. So there will be some commonality. But at the same time, a mountain bike's features might be very different from a city bike feature. A mountain bike mountain bike might have gears, for example, whereas a city bike might not have gears because you don't need that much of a variation in inclination and declination when you drive down the road. So I'm trying to conceptualize the same example here where I've created a class called bicycle, and this is my base class. I define two properties in the bicycle class, which is gear and speed. We will come back to protected in a while, but let's leave that there. So I have two properties, which is gear and speed. I have a constructor where I'm initializing the starting speed and the starting gear, and then I have three methods here, which says set gear, apply brake, and speed up. When I apply brake, the speed is going to get reduced. So that's why you see minus equal to unary operator. And when I'm trying to speed up, the speed is going to increase. That's why I'm using the plus equal to unary operator. So when you use the method speed up, the speed is going to be increased by the value you supply in the method. Similarly, when you apply the brake, the speed is going to get reduced by the amount you supply in the method argument. And that is my base class: bicycle, gear, speed, and three methods. Now let's have a look at the child class. So the way you will define the inheritance relationship in Java is by using this extends keyword. Remember, I told you to remember the extends keyword. So what you will do, that you will write your class name as usual, and then you will use extends keyword, and then you will use the parent class name or the base class name. So here I'm saying class mountain bike extends bicycle. And here I'm providing an additional property. Remember the whole commonality versus differentiality equation. So a mountain bike might have an extra property to adjust the seat height. So that's the extra property which mountain bike is having. And then since this mountain bike is extending the bicycle class, this mountain bike class has the responsibility to initialize the bicycle class as well. And the way it will fulfill that responsibility is by taking all the arguments of bicycle class plus the mountain bike class in its constructor. And that's why you see three different properties here. You see the start height property, which is the property of this particular class, which is the seat height. And then you see the start speed and start gear property, which directly are not available in this class, but this class is inheriting those properties from the base class. Remember the keyword inheritance here. And then once you do that, how do you initialize the base class constructor is by calling the super method. This is again a keyword in Java, and you will use this super keyword to refer to the base class constructor in this way. So what you will do technically is that you will write super and you will supply the arguments which is required by the base class constructor. If I go back, the base class constructor requires two arguments, start speed and start gear. So I write super and then I write start speed and start gear. So whatever I got from here in the constructor of mountain bike, I'm supplying those values as is to super. And Java will automatically take care of invoking this particular constructor the moment it encounters this kind of statement. Another thing to notice is that the super keyword or super statement has to be the first statement inside your constructor. Remember that whenever you are dealing with inheritance, and whenever you have to initialize the super class constructor or the base class constructor, use the super constructor invocation as the very first statement inside your child class constructor. Otherwise, Java will not compile the program. And then you will initialize the local variable. I should call this as this. Remember, we discussed about this in the classes session. Okay, and then it just has a method of set height. So there's no extra method which this mountain bike is providing, but this mountain bike will have access to all the methods which have been provided here and all the properties which have been provided here. This mountain bike can access everything from the bicycle class. And that's the whole idea of inheritance, that the child class can access the properties of the base class by extending the base class. Now let's look at how do we invoke this particular class. So for that, I have a simple class name as inheritance demo, which has a public static void main method. And then I am initializing the mountain bike class. I'm supplying three values as 20, 10, and 1. So the 20 goes to start height. The 10 here goes to start speed. And 1 here goes to gear or the start gear. And that's how I'm setting the values. So when I call this particular constructor here, the mountain bike constructor is going to, mountain bike constructor is going to get called, and which in turn is going to call the base class bicycle class constructor as well, and everything will be set accordingly. And then let's try to access the gear property. Remember, gear is not directly available in the mountain bike class, but I'm still able to do mountain bike.gear because child class can access the parents class properties. Similarly, the same thing goes for speed as well. And seat height is the local property of this particular class, mountain bike, so it will anyways be accessible. So I can access all the properties of the base class and the child class itself seamlessly without any differentiation. Now let's try to call a method. So here I'm calling the method apply break. Remember, apply break was defined in the base class, not in the child class. It's defined here. So I'm calling the apply break method, and I want to reduce the speed, the current speed, by 1. And then I'm printing the current speed, saying that bike speed after applying break is mountain bike.speed. So let's run this particular program and observe the outputs. Okay, so the first statement which gets printed is at line number 7, which says gear is 1 because it's coming from here. Then the seat height is mountain bike.seat height, which is 20, which is the first argument here. And then the bike speed is 10, which is coming as here and getting printed here. And then when I apply the brake, let's go back to the apply brake method. The logic is that whatever is the current speed, reduce it by the value I supply in the method. So if I supply 1, 10 minus 1 becomes 9, and that becomes the current speed. If I supply 5 here, the current speed will be 10 minus 5 equal to 5. Let's assert that particular assumption as well. Yes, we can see that. And similarly, you can access other methods of the base class as well. If I just do control space here, and you can see apply brake is accessible, set gear, set height, speed up, all the methods which are defined in the base class are accessible in the child class as well. This is the power of inheritance. One more thing which I said I will come back to is around the usage of protected access modifier. Remember when we discussed about the access modifiers in the previous session, I said that protected is used when you are dealing with inheritance, that whenever you define something as protected, it will be available to be accessible in the child classes of the base class. So if I define this particular variable as protected, then this particular property will be accessible in the child class mountain bike as well. Let's play around this. Let's make this as private and see what happens. So if I make this private, now when I say private, the scope of this particular variable is within the class only, and nobody outside the class will be able to see it. And you can see the effect of it. I can see an error being coming here in my inheritance demo class because now mountain bike object cannot access the gear property because the gear property is defined in the base class and now it is private. That's why the child class now, mountain bike class, cannot access the property gear. And the moment you make it back to protected, it will be accessible. The error is gone. There's no red line here. So that's how you can use the protected access modifiers. It is always recommended to use them when you write any kind of inheritance logic. And in inheritance logic as well, intentionally, if you want to hide a particular property from the child classes, just make it private. And that's all I want to cover in this particular session, where we dive deep into the concept of inheritance. We had a look at an example using the bicycle and mountain bike kind of construct, and you can apply the same kind of construct on any kind of other kind of business requirement. Remember, the is a relationship. Let's get started with encapsulation. So again, let's understand what is encapsulation in general, and then we will apply that concept to Java. Encapsulation, if you try to break that word, if I just write it here in the form of a comment, it's encapsulation. Just trying to break this word into to make it more visual. So you see a word called capsule here. So if you try to imagine a capsule, why do you create that, and what's the concept of a capsule? Capsule tries to pack a lot of things inside a small tube-like shape. And the concept of encapsulation is sort of inspired from that. Not exactly, not literally, but that's the basic idea of this root word, which is called encapsulation. So encapsulation basically means to restrict accessing the properties of a class to the outside world. If you want to protect the properties of your class, how do you do that? You do that with the help of the concept called encapsulation. So here, this is a sort of a security feature. You can think of it as a security feature that you want to protect the properties of your class, and you will use encapsulation to protect the properties. How you implement encapsulation? Let's have a look at that now. So basic idea is to encapsulate the objects, create sort of a capsule around the object, which can provide that protection layer. And you will define how the outside world is going to access the properties of the class if needed. So I've created a simple class here, and if you remember one of the previous examples when we discussed about classes, I used the same class, which was the student class, and I'm just using the same class for continuity. So I've created a student class here, and I have created 3 different properties of this particular class, which is name of the student, age of the student, and address of the student. You see, intentionally, I have used the keyword private in front of these 3 properties. And that is the first thing which you need to do to implement encapsulation on your object, that you hide all the properties from the outside world. Remember, the moment you make anything as private, only the class, which is the student class itself, only the class itself can see these variables or these properties. Nothing outside the student class will be able to access the name or age or the address directly from the student class. It's not possible. That's the whole idea of making it private, because you don't want the outside world to access these properties. So you make those properties as private. Then you create a constructor. The constructor has to be public so that anybody can initialize the student object, because you want your object to be accessible. Remember, so you want the objects to be accessible, but you want the restriction on the access of the properties of the object. And these are the properties of the object. So you have restricted them by making it private, but that doesn't solve the problem, because there will be some illegitimate consumers of the student object which should not have access to the student properties, but there will also be some legitimate consumers of the student object which should be having access to the properties of the student. For example, the payroll application will need access to these particular properties. The examination application will require access to these particular properties. So how do you do that? You create getters. We call them getters because they start with the keyword get. So you create a getter method for each of the property. You create the method called as get name, and this is the naming convention which Java promotes, that you write get and then you write the name of the property in camel case. So you write get name, and this property is supposed to return the name property of this particular object. And here you say return name. So you're returning the name which is being stored by the current student object whenever somebody calls student object dot get name. And this is the way you have restricted the access of this particular object as well. So remember, you made it private so that nobody can access it. And then you defined your own way of providing access to the name property of this particular class. Now, if anybody wants to access the name value of your student object, there's only one way to do that, which is via calling get name. So you have provided restrictions and you have also provided prescriptive guidance on how you are going to expose the properties of your class. That's the second thing which you need to do to implement correct form of encapsulation on your object. That is to provide the getter methods with the right visibility. You want to make them public so that anybody can call them, but since you are governing which is what is written inside the method, you have full control on what kind of exposure you want to give for this particular property. Similarly, you create a getter for age, calling getAge, which returns the age, and then you call you write getAddress and return the address. Here it is simply returning it, but if you want to do more stuff here, feel free to do that. Like I said, you govern the control of how do you want to return the name. Maybe you don't want to return the complete name and you want to just return the initials. Then you can split the string, trim the string, and return only the initials. So that's the basic idea of getters. Now, after you have created the object, there might be use cases where somebody needs to overwrite the values of the properties like name, age, or address. What if a student's name was incorrectly mentioned when they called the constructor and now they want to overwrite the name or fix the name? So basically they have to replace the existing value of the name with a new name. So in that case, you need to provide what we call as setters, and they start with set. That's why we call them setters. And we follow the same kind of logic that you provide the setters for all the properties of your class. So you had three properties, which were name, age, and address, and you provided the setters for all three of them. And how do you provide that? You again make them as public because you want the outside world to access this setter method to override the values of the name. This method is not going to return anything, so it is going to be void. Then you write the name of the method, which starts with set, and then the property name in camel case. And then you provide the new value, which is the value which should be the new value, and this is the value which should replace the existing value. So whatever new value you want to supply, you supply that as the argument of the setter methods for set name, for set age, or for set address. And then you write this particular line, which says set the current name property of this particular object with the name which is coming in from the argument. So this dot name, remember, this dot name represents the current object's property because this represents the current object. So whatever is the current object property value of the name is, just override that value with the argument coming in. Do the same thing for age in set age method, and do the same thing for set address in the set address method. So this is how you are going to provide the setters and the getters. So setters and getters can also be generated in smart IDEs like Eclipse. So you just right click, you go to source, and here you will see the option of generate getters and setters. If you click on this, it will give you the list of the fields which are available to be having getters and setters. Currently, it says no fields or all fields have getters and setters already. Yes, because they have it. Let me just comment this and show this how this works. So for example, let me comment all the getters and setters. So I'm commenting them. And if I right click, source, generate getters and setters, I get all the fields available for which setters and getters can be generated. So you can select them and leave everything as default, hit generate. And it is automatically going to generate the getter and the setter. You see, all the code of the getter and setter is automatically generated. You do not even need to write it. And this is the power of the smart IDEs. Let me just revert what I did. So you created everything as all the properties as private, and then you define how you want to replace the values by providing the setters, and you define how you want the outside world to access your properties. So you have full control of the class now. You control the visibility, you control how they are going to get initialized, you are controlling how the properties are going to be overwritten or set, and you control how the properties are going to be returned. So you have complete control of the class. So you have created a perfect capsule here, a perfect form of encapsulation in this class. And this is how you can implement encapsulation. Let's get started with abstraction. Let's first understand the definition of abstraction before we relate this to Java. Abstraction generally means hiding something. When you want to hide some details of a particular object from the outside world, you apply the concept of abstraction. For example, when you drive a particular car, you just hit the accelerator and the car speeds up. Now, it's not only one action. When you hit the accelerator, the whole machinery of the car and all the components, different parts of the car work together to speed up. There would be engine, there would be propulsion, there would be fuel, there might be some, if it's an electric car, there would be batteries. There would be whole different kinds of pistons and plugs which will make the car speed up. It's not only a single component. It's a lot of different components under the hood. And that's the concept of abstraction, that we only show the relevant parts to the user and we hide all the internal details from the user. That's the basic idea of abstraction. So a car manufacturer abstracts away all the inner technical details from the driver and just gives the driver a single pedal to speed up the car. For a user, it's a very good experience because he doesn't need to know about all the internals of the car. But the car manufacturer can hide all the details and provide a very simple interface for the driver to interact with, which is just a gas pedal. And that's the basic idea of abstraction. And we try to apply the same kind of concept to Java in the form of abstraction. And Java provides this kind of concept implementation with the help of a keyword which is called abstract. Now, abstract is a keyword which can be used in front of a class or a method. When you use it in front of a class, the whole class becomes abstract. Abstract class is a type of class. So the class itself becomes an abstract class. One of the things to remember is that abstract class cannot be instantiated, but can be subclassed. Remember, we talked about the concept of subclass and the parent class when we talked about inheritance. So if you make a class as abstract class, you cannot call the constructor of the class because you cannot instantiate it, but you can extend the abstract class and create a child class out of it. That's the concept of abstract class. Another concept is abstract method. You can also use the abstract keyword in front of a method. And when you use abstract keyword in front of a method, then that method is only declared without an implementation. You are not going to provide any implementation of the method, and you're just going to declare the method. Something like this. We will see a similar example in the hands-on as well. But that's the basic idea, that you just declare the method. You are not providing an implementation as to what does move to method actually does, because that's the whole concept of abstraction. And it is the responsibility of the child classes which inherit the particular class in which the abstract method would be sitting. So the child class will be having the responsibility to provide a concrete implementation of the declared method. Let's understand this better with the help of an example. So here I have created a class called graphic object, and I have made the class as abstract class. This is the keyword which you need to use in front before the class keyword, and the class becomes an abstract class. Now, when you create an abstract class, it automatically gets some properties. The first property is that this particular class must have at least one abstract method. And this is how you define the abstract methods, where you just provide the declaration, but you do not provide the implementation of the draw method or the resize method. And the way you will create the abstract methods is by using the abstract keyword before the actual method declaration starts. So general method declaration would look like this. And if you use abstract in front of it, this becomes an abstract method declaration. Abstract class can also have concrete methods. So that is the liberty which abstract class gives you, that you can have abstract methods which are just declared, but you can also have normal methods which are where you can also provide the implementation. So you can have normal methods and abstract methods as well in an abstract class. So this is the abstract class. Now, if you want to provide an implementation of the draw and resize method, you have to extend this abstract class. So we extend this abstract class by creating two child classes out of this particular abstract class, which is circle.java, where you can see I create a normal class and I use the extends keyword for inheritance. And I'm saying that circle class is inheriting from the graphic object class, which was my abstract class. And once I use this extends keyword, then I have the responsibility of providing the implementation of the abstract methods. Actually, Java will force me to provide the implementation of these two methods. If I do not provide all the declared methods, so there are two declared methods here. So if the circle class does not provide the implementation for both draw and resize methods, then Java will throw an error and it will ask you to take an action, which can be either define all the methods, meaning provide implementation for all the methods, or make the circle class itself as abstract. Let's see, if I just comment this particular out, I get an error. You see a red line here. And if you click on this particular balloon here, it will say either you can add the unimplemented methods or you can make the circle type as abstract. So these are the two options which you will get to fix this particular error. So an abstract class can be extended by another abstract class if the child abstract class is not implementing all the methods of the parent. If you want to implement all the methods, then just implement them and keep it as a normal class. And that's what I've done here. I've just created a normal class here and provided the implementation. And once you provide the implementation of both of the methods, the error is gone. Similarly, I've also provided another child class because there can be multiple children of a particular parent. So rectangle also extends from the graphic object, and it also provides its own implementation of drawing and resize. Because generally the way you will draw a rectangle and you resize a rectangle will be different than drawing or resizing a circle. Here I'm not doing anything in the methods because this is just to show you the demonstration. I'm just printing a sysout saying drawing a circle and resizing drawing a rectangle and resizing a rectangle, and in the circle class drawing a circle and resizing a circle. So one abstract class as the parent class, which is the graphic object, and two children, circle and rectangle, both providing the implementation of the abstract methods which were declared in the base class. Now let's go to the main class where I've defined the public static void main method. And here you see I have created two different kind of blocks of code here. One block is where I'm saying graphic object, creating a reference of the graphic object named as circle and initializing the circle object. Now you see a difference here. Here is the abstract class and here is the concrete class. So whatever you define on the right hand side, whatever is the type of object will be the type of methods being called. So if you created a circle object and then if you call the draw method and resize method, these methods will be called from the circle class. If you initialized it as new rectangle, then you are creating a rectangle class object, and then the draw and the resize method will be called from the rectangle class. That's the basic construct, and that's how you will initialize a particular class which is using an abstract class. So I call graphic object circle, new circle, and I call circle.draw and circle.resize. Similarly, graphic object rectangle equal to new rectangle and rectangle.draw, rectangle.resize. Let's run this program and observe the output. So when I call this particular block of code, circle object gets initialized, and then circle.draw method prints drawing a circle, and circle.resize method prints resizing a circle. Similarly, when I create the rectangle class object, referencing it with the graphic object class, rectangle.draw prints this particular line, drawing a rectangle, and rectangle.resize prints this particular line, which is resizing a rectangle. And this is how you will use the concept of abstraction. There's another very interesting thing which is going on here. Remember I told you if I do this and I I just put a system out here, base abstract class. So if I do this here, if I still write a constructor, though Java says that it cannot be instantiated, if I still write a constructor of it and I do not do any changes here, and if I run this particular program, let's see what happens. You'll see the base abstract class being called here. Let me just reformat it by putting ln here so that we get a better output. So if I run this particular program, you see base abstract class is getting printed somehow, though we said that abstract classes cannot be instantiated, but still the constructor of this is still getting called somehow. When I create a circle class, the base class constructor gets called, and when I create a rectangle class, again the base class constructor gets called. This is the power of inheritance, because in inheritance, remember how it works. When you initialize a particular child object, referencing it with the parent object, see the reference is of the parent class and the object is of the child class. So whenever you do it like this, first the default constructor, because I'm calling the default constructor here, the default constructor of the circle class will get called, which will go here. Remember, I told you that Java provides the default constructor automatically if you don't provide it. So the default constructor of circle gets called, but Java sees that you are writing this code here, which says circle extends graphic object. So Java is automatically going to call the parent class and going to initialize the parent class as well, because that's how it will be able to see these methods. And so that's why it will automatically call the base class constructor, even if you don't call it explicitly. In fact, you cannot call it explicitly. Java will not allow you to initialize the graphic object class explicitly. It can only and only be called by Java itself indirectly via the concept of inheritance. If you try to do this, let's try to do this for fun and also for better understanding. So if I write graphic object, go equal to new graphic object. You see, I don't even get an option, but let's write it and let's see what happens. So you see that this particular, it gives basically an error because it's not able to find the constructor of the graphic object class. Though even I have defined the default constructor here, but still Java is not able to find it because this class is abstract. So hence proved, abstract classes cannot be instantiated explicitly. They can only be instantiated by the child classes through the internal mechanisms of Java itself. And that's all I want to talk about in this particular session, where we looked in detail about the concept of abstraction. Couple of more things which I did not cover in the previous session. I just want to call them out for clarity. Java does not support multiple inheritance. When I say multiple inheritance, what it means that you will not have a scenario where a child will be extending from two base classes. Java does not support it. It does support it with the help of interfaces, but I will talk about interfaces in the coming sessions. But here, just understand this, that you cannot use multiple inheritance with classes in Java. A child cannot have two parent or two base classes in Java. Java will not allow that. It is also called the diamond problem because the child class does not know whether to follow the route of base 1 class or the base 2 class if it is extending from two different base 1 and base 2 classes. So a class can only extend from one class in Java. We can find a workaround of it by using the concept of interfaces, but that's something which will be coming later. Another thing to understand is that when you create an abstract class, here these variables, you can declare these variables as well, and these variables will be accessible by all the child classes as you access them. Let's get started with interfaces in Java. Now, again, let's understand what do we mean by an interface in general, and then we will see how do we apply the concept of interfaces in Java. So imagine, let's take the same example of vehicle industry because that's something which we see every day around ourselves and we can relate to it. So imagine if all the car manufacturers were creating a different way of driving a car. What if in one car you have a steering, but in other car you do not have a steering, but you have something else, which may be called something else. In one car you have the gas pedal to speed up. In other car you have a button to speed up. Similarly, in one car you may have different kind of doors, and in other car you may have different kind of doors, which are completely different looking. It's not even a single simple handle to open it. So you see the problem here. The problem here is that all the car manufacturers are not working on a single contract. they are not respecting a single interface, which will create a poor user experience because whenever the users have to buy a new car or they have to switch from one manufacturer to other manufacturer, they are completely clueless as to how to drive that particular class because the interface they were using in the previous car is completely different from the interface they are being shown in the other car. And that's the basic need for the concept of interface. Think of it as a contract agreement. You see, it is also mentioned here that if you apply the same kind of concept to programming world, imagine if every programmer was writing their own logic in their own way without following a single contract or a single guideline. Soon it is going to create a problem. And that's the kind of problem interfaces try to solve. So interface is again a keyword in Java, and the basic idea or the basic construct is that the interfaces are going to define the specifications of how a class would act. Let me repeat this in a more generic way. Interfaces are going to define the contract or the specification which is going to govern how an application or code or programming logic will behave. That's the basic idea of interfaces. So interfaces are their own type, and the basic property of interface is that it can only contain constants, method declarations similar to abstract classes, and some default methods or static methods or nested types. What is nested type? We will cover that later. Default methods we'll touch upon a bit here, and the static methods as well. But the basic idea is that when you create an interface in Java, you cannot write anything concrete in terms of the behavior of the interface. When I say behavior, always think of that as method. So you cannot define a concrete method in an interface. You can only declare methods. You can also declare constants. You can create a particular type of concrete method by using the default keyword, but use it in very special circumstances. You can also create static methods as well, which are only going to belong to the interface and nobody else. Now let's look at an example. And also, before we go to the example, let me also phrase this here that if an interface cannot define a concrete implementation of the methods, then naturally the interface is going to be extended by a child class, a concrete class, which is going to provide the implementation of the methods declared in the interface. It does sound like abstract classes, but there is a difference. Let's understand the difference with the help of an example. This is how an interface will look like. I've used the same construct of bicycle and mountain bike just to maintain some continuity and less context switching. But this is how an interface will look like. You will not use the class keyword, but instead of that, you will use the interface keyword. You can only declare methods. You cannot define methods. Remember when we looked at the abstract classes example, we were able to define concrete methods as well. But in interface, that's a strict no-no. You cannot define concrete methods. Let me show you the abstract class in the case of abstraction which we used. This was the abstract class and it did have a concrete method, right? But bicycle.java here, which is because it's an interface, it is not going to allow you to create a concrete method. Another thing is that if you try to declare a variable inside the class, they will have to be constant. You cannot just declare them without any value. For example, I cannot do this. If I do this, it is going to give an error. You see an error here. And it says initialize field X at declaration, something like this, public static final. So interface is going to force you to declare all the variables as public static final with some value if you try to use them inside interface. So that is also something which interface will mandate. So you see interfaces are more strict. They are more strict in terms of what you can do. You can only declare public static final variables and you can only declare methods. You cannot define methods. So abstract class is less restrictive. Interface is more restrictive. And that is the differentiation which you have to keep in mind, whether to use abstract classes or whether to use interfaces. That is also a very common confusing question in the interviews as well. And remember that interfaces are only for contracts or specifications, where in case of abstract class, you can write a concrete behavior as well in terms of a concrete method in the base class. Interfaces, there's no concrete implementation in the base class. Abstract classes, yes, there can be a concrete implementation in the base class. That's the basic difference. Moving on, I have created a child class here, which is again mountain bike, and it has three properties: seat height, gear, and speed, similar to the previous example. It has a constructor, and remember, again, interfaces cannot be initialized directly, so you do not even need to call a super method here because there is nothing to initialize. You initialize a class to create a state. State is denoted by the properties, but interfaces will force you to write a public static final property and initialize its value automatically. So you do not need a constructor for the interface because there is nothing to initialize. Everything has been initialized in terms of the variables, and the methods are anywhere just declared. That's why you don't need to call super here. After that, the moment you write this particular keyword here, implements, and that is how you will basically extend from the interface. You will use the implements bicycle keyword here. Implements is the keyword and bicycle is the name of the interface. If you write this here, then Java is going to force you to provide the implementation of these two methods. If I do this implements bicycle and if I comment out these two methods, which is coming from the base class, it is going to give an error. And if I read out this error, it says either you add the unimplemented methods or you make the mountain bike class as abstract. There are two ways to fix this particular class. Similar to abstract classes, it will force you to write the implementation of the base class declared methods. Another thing which Java will suggest you and will also force you via some IDEs as well is that you use this particular annotation. We use this particular annotation to tell Java that we are overriding this method from the base class. Since apply break and speed up methods were defined here in the base class, and this child class is supposed to provide the implementation of the methods by overriding them. Overriding is again a concept which we will talk about in detail in the coming sessions. But for now, remember that you need to write this annotation here on the methods which have been taken from the base class to provide an implementation. And the implementation is similar to what we have seen before. So whatever value you supply in the apply break, the speed is going to get decremented by that particular value. And in case of speed up, whatever value you supply in the argument, that value is going to be added to the current speed, and the speed is going to go up. Let's look at the main class here, which is called interface demo. It has a public static void main method. And here I'm again initializing the child class. Nothing strange here. And then I'm using the getter method here because I have made everything as private here. And rest of the things are just here as is. I have the getters and setters here for all the properties, and I'm using those here. So I'm using the getters to just get the value of gear, seat height, and speed. And then I'm applying the brake, and then I'm printing the current speed after applying the brakes. Let me just expand this a bit more. And then I'm using the speed up method, trying to increase the current speed of the bike by 10, and then printing the new speed again. So using the apply brake and speed up methods, which are concretely defined in the child class by using this override annotation. And these were the methods which were declared in the interface, in the base interface. And that's all which is happening in this particular class. Let's run this particular program. And these are the values I get. I get the gear as 1, which is coming from here. I get the seat height as 20, which is coming from here. I get the current bike speed as 10. This was the value which it was initialized with. Then I'm applying the brake. And after applying the brake, the speed of the bike gets reduced and it becomes 10 minus 1, which becomes 9. And that's what gets printed here. And then I'm speeding up the bike by 10. So the current value of the speed of the bike is 9. And if I incremented it by 10, it becomes 19. And that's what gets printed here. Let's get started with multiple inheritance in Java using interfaces. If you remember, in the previous sessions, I said that multiple inheritance is not possible in Java. And it is not possible because of the diamond problem. Or simply put, a one child cannot have two parent classes. That's what Java says. And let's understand why this is a problem. So I have created a very simplistic diagram to demonstrate the problem of multiple inheritance. And then we will see how we can solve that. So let's say you have a class C, a normal class. Then you created two parents of class C. So basically class C is extending class A, and you also want the class C to extend class B. First of all, it is not possible in Java, and why it is not possible is because of there can be a superclass which is extending class A and class B as well. So you started with class C, you wanted class C to have two parents, which is A and B, but A and B also had a common parent, which is superclass. So now, as you know that the child classes can see the properties of the base classes as well, then if class C wants to access something from superclass, which route should it take? Should it take this route or should it take this route? That is the problem which we called as the diamond problem. And that is the reason why Java prohibits using multiple inheritance using classes. So that's the problem statement, that we don't have a clear route to reach to the superclass from class C, and we try to solve it using interfaces. So let's jump right into the Eclipse IDE to understand how we can solve it. So here I have prepared an example for this particular problem and the solution of it. So again, I'm using the same bicycle and mountain bike example for the sake of continuity. I have created an interface of bicycle which has two declarations, which is for applying brake and speed up. This is my simple interface. And then I have a mountain bike class, which is implementing the bicycle interface and providing the implementation of apply brake and speed up. This is something which we have already seen in the previous example. So nothing new here. And then you have other getters and setters, and you have a main class where you can initialize the mountain bike and get the gear, get the seat height, get the speed. We have covered all of this. There's nothing new here. But now let's say you have a requirement that you have another interface which is called vehicle, and your mountain bike should extend or implement this interface as well. Is that possible? Let's try that. Remember, mountain bike was already implementing bicycle interface. What if you want to have two parents of this mountain bike using interfaces? Like I said previously, that interfaces does solve the problem of multiple inheritance. So let's see if it does solve that problem. So I can just say vehicle here and see if the code compiles. The code doesn't compile here. And the reason is pretty expected. It's because vehicle has a declared method which is called can drive, and mountain bike now needs to provide the implementation of that particular method. So if you click on this balloon and hit on add unimplemented methods, just double click on that and you will get an empty method definition of that can drive method. And let's put a sys out for simplicity and say mountain bike can be driven. So this is how you can see this code is working fine. And now this particular child class has two parents. It has a bicycle parent and it also has a vehicle parent. So if bicycle and vehicle would have been concrete classes, then this would have caused an error. Let me quickly show you that if I can. So let me go to bicycle and I just change this to class and I put an empty definition for both of the methods. And then let's go to the vehicle class and convert interface and convert that into class as well. And again, provide an empty implementation. So I've just converted the vehicle interface and the bicycle interface into classes. And now if I go back to the mountain bike and if I change this to extends, I get a whole lot of errors. If I go here, it says multiple markers and it doesn't give you the right error, but the right error is happening because you cannot extend from two concrete classes. Now bicycle and vehicle are both classes and mountain bike cannot do that because Java does not support multiple inheritance from classes. But if you go back to the previous state, if I just quickly do Control Z here and Control Z here in case of vehicle as well, converting both of them back to interfaces and putting the implements back here, everything goes fine. So using interfaces, you can implement multiple inheritance, but using classes, you cannot do that. Let's cover one more interesting scenario. What if you have a need to extend from, let's say, one interface and one more class? Is that possible? Because we saw the combination of two classes that was not possible. We are seeing the combination of two interfaces, which is possible. Now, is it possible to extend from a base class and implement an interface? Let's see what happens if we try to do that. And I have another class. This is not an interface, but this is a class called two-wheeler. So technically speaking, mountain bike is a two-wheeler. And at the same time, mountain bike is also a vehicle and mountain bike is also a bicycle. So what if you have a requirement that your mountain bike should also extend from two-wheeler class? Can you do that? Let's see if I can do that. I will just write extends two-wheeler and let's see if that works. It doesn't work here, but let's put it here. If I put it here, does it work now? Yes, it works. There's no compilation error here, which means Java does accept this particular construct. So what happened here? First thing, when I put this extends two-wheeler after implements, Java did not allow, which means that the extends keyword has to come right after the child class. It cannot come after the implements clause. It has to come right after the child class. That's first thing. Second thing is a normal class, a normal child class can extend from one concrete class and can also implement any number of interfaces. You see, I have two interfaces. So now technically this mountain bike has three parents. It has a concrete class two-wheeler as the parent. It has bicycle interface as the parent. And it also has vehicle interface as the parent. So three parents. So this basically justifies the philosophy or justifies the concept that a class can extend from only and only one base class, but can implement any number of interfaces. You can have more interfaces here, as many as you want. So number of interfaces is not a restriction, but number of concrete classes is a restriction. A child class will have only one concrete base class, but can have any number of interfaces being implemented from this particular class. That's the basic property. And then the main in the main method, you can access any of the vehicle or two-wheeler or bicycle interfaces methods and the classes methods as well if you want to. So for example, if I want to just type this, and if I just do dot here, I can access can drive as well. Now can drive was implemented in the vehicle interface or declared in the vehicle interface. Similarly, if I look for the two-wheeler method, can I see the two-wheeler method as well? Let's see if I can. Yes, and this you can see this is the two-wheeler class method which says can rotate two wheels. So I can call this particular method which is coming from the two-wheeler class. I can call the vehicle class declared method which was can drive. So this is also possible, and this is possible because in the initial. So let's run this particular program and understand the output. So I initialize mountain bike class and I print the gear, the seat height, and the bike speed values. You have already seen this. Then I apply the brake and I speed up. So after applying the brake, the speed becomes 10 minus 9, and after speeding up, the new speed becomes 9 plus 10 as 19. Then I call mountain bike dot can rotate two wheels, which is going to invoke the method which is defined in the two-wheeler class, which is printing a simple sysout. So I get the same sysout here. This method is being invoked from the mountain bike object due to the concept of inheritance. Similarly, when I say mountain bike dot can drive, this can drive was declared in the interface vehicle. And then when mountain bike implemented this interface, Java forced it to provide a definition of this particular method. And this is a definition, which is again a sysout. And you can see that sysout being printed here. So this is how you can implement multiple inheritance in Java using the power of interfaces. The interparent and particular exhibits that kind of behavior, then we say that polymorphism is in action. That entity can be a class or an object or even a method. And in today's session, we are going to talk about that type of polymorphism which is exhibited by methods. So we will see how a particular method in Java can take many different forms containing different logics, but still having the same name. And that concept is called method overloading. So whenever you hear the word that you need to overload a particular method, or this is method overloading happening. Technically or conceptually, it's basically polymorphism in action, and polymorphism is being applied on a method here. And that phenomena we call as method overloading. So in today's session, we are going to have a look at how we can implement method overloading in Java. So the basic idea of method overloading is that the name of the method should remain the same. So you see in this particular class, which I have created to demonstrate the method overloading. So this is the class name, and the method name, which I am going to overload, is called multiply. And that is probably the first thing which you need to remember to implement method overloading correctly, that the method name is going to remain the same. The type of the return of the method may change. Here you see it's returning int here in the first instance. In the second instance also it is returning int, but in the third instance it is returning double. So the return type of an overloaded method can change. Another thing which can be varied between same method being defined again and again is that the number of arguments and the type of arguments. The first multiply method takes 2 arguments of integer type. The second multiply method takes 3 arguments of integer type, and the third multiply method takes 2 arguments of double type. So by using method overloading, you can vary the number of arguments and also the type of arguments. So the basic idea is that you define the method using the same name, but you do a variation in the arguments or the return types. And that's how you technically implement method overloading. In this particular case, the multiply is the method being overloaded. And in the first case, it is accepting 2 integer arguments and returning the result of multiplication of those arguments. In the second case, the same method name multiply here, the same visibility public, and the same return type, but this time 3 different types of integer values can be accepted, and this method, multiply method, is going to return the multiplication of 3 integer numbers. In the third case, at line 15, I again use the same multiply name, the method name, but this time the return type becomes double, and this method accepts 2 double arguments and returns the result of the multiplication of these double values. So the method name is same, but the arguments vary, and also the return type may also vary. That's the basic premise of how you implement method overloading. So whenever you want to implement it, keep the method name same, vary the arguments and the return types. And after that, I'm just created a public static void main method here. I have initialized the class here, this particular class itself, method overloading demo. And then I am calling the multiply method on the object. And based on the number of arguments I supply, the corresponding method will get invoked. That is something which Java will take care automatically, that whatever type and the number of arguments you supply in the call, in the invocation, based on the number and the type of the arguments, Java will try to find a matching method in the overloaded methods. If it is able to find a method, it's going to get invoked. If it is not able to find the method, you will get an error. In fact, you will get a compile error itself while you invoke a method for which the definition is not available. For example, if I try to just copy this and make an invalid method invocation, let's provide 4 arguments. And if I do that here itself, I will get the error because Java is not able to find a multiply method in this particular class, which is accepting 4 integer arguments. So you will get the compilation error itself before you can even run the program. But the basic idea is that you use overloading with multiple different types and the number of variables. So I'm calling multiply 3 times. Let's run this particular program and observe the output. So let me just bring this output down. Yep. So first I call demo.multiply and pass 2 integer values, 10 and 20. When this happens, this particular method gets invoked and it returns a result of 10 into 20, which is 200. In the second invocation, I'm calling again the multiply method, but this time with 3 arguments, 3 integer arguments specifically. And this call is going to match this particular method signature, and it is going to execute whatever is written inside this particular method, which is the multiplication of the 3 arguments being supplied. So 10 into 20 into 30, which is 6,000. The third case, let's go back here at line 25. The third case of invocation of the multiply method is accepting two decimal based arguments, 10.5 and 20.5. So Java is going to look at the class and trying to find a method which can accept decimal values. And there it is. This is the method signature which is going to match the invocation. Java is going to do this matching automatically for you. And here, whatever logic you have written inside this particular method will get executed. So 10.5 into 20.5 returns 215.25, and that's the output you get. So this is how you can use method overloading in Java. This is a rather fairly simple example, but you can make it as complex as you want. But a word of caution, do not use it too extensively. In fact, a lot of expert programmers do not recommend using method overloading because it becomes very confusing. Use it only when you do not have any other way out. Use it only where this is the only way to write correct form of methods with the right readability. Otherwise, generally, there would be other ways to avoid method overloading by writing concrete purpose-friendly method names themselves. Maybe you don't need to use the multiply name again and again. You can call it as multiply 2 numbers, multiply 3 numbers, multiply doubles, so that the method name itself is more explicit and understandable rather than juggling around different signatures of the same method. Especially it becomes more confusing if you are creating an interface which is to be consumed by a third-party developers or third-party application. So try to use it with caution. That's what I'm trying to stress here. Let's get started with method overriding in Java. Now, in this session, we'll focus on another interesting concept by which you can have the same signature of the method again and again be used in your code, but in a different way. And this concept is called method overriding. Method overriding basically is used together with the concept of inheritance. You will not be able to use the concept of method overriding without using the concept of inheritance. Remember, when we talked about inheritance, I spoke about the subclass and the parent class concept. Sometimes we also call the parent class as superclass. So the basic idea is that if a superclass defines a method, remember I'm using the word define here. If the superclass uses defines a particular method, and then the subclass again tries to define the method with the exact same signature, this phenomena is called method overriding. Now, when you do method overriding, there are some rules to follow. And I'm showing you a tabular structure here, a table basically, which will show you what is possible and what is not possible when it comes to method overriding. So let's try to understand this table. So if you try to define a method with the same signature as a superclass method, the rules follow as per this table. Let's go with the first one. If you have an instance method defined in the superclass, instance method is the normal method which you define in your classes. So if you have defined an instance method in your superclass, and if you define a method in the subclass with the exact same signature, then that concept is called method overriding, and it will be a successful override. Override also, let me also explain what override means here. Override means that once you try to initialize the subclass object, you will be able to invoke its own overridden method definition. If you call that particular method, the subclass's own instance method is going to get invoked rather than the superclass's instance method. We'll look at that when we look at the example as well. But that's the normal scenario where your superclass defines an instance method and subclass also defines an instance method with the exact same method signature. That concept is called method overriding. What if your superclass defines a static method? Static method is basically a method which belongs to the class but not to the object. Instance method is called instance method. A normal method is called instance method because it belongs to the object. You can call the method on the object, but static methods are called by class. So you say class name dot static method name. But when you call instance methods, you just call object name dot instance method name. So that is the basic difference. The static methods belong to the class. Once you have defined a static method, the same static method will be available to all the objects of the class. But instance methods are unique to each object. So that was a short tour of what static methods mean. So if you define a static method in the superclass, and then if you try to define an instance method with the same signature in the subclass, you will get a compilation error. It will not be allowed. It's not allowed in Java to override a static method from superclass. That's what it says. Next one, if your superclass has a normal instance method and then the subclass tries to use the same signature but creates a static method out of it, then again you will get a compilation error. So the overriding of an instance method to a static method is not allowed. And the last concept is again a very interesting concept and a very popular interview question about method hiding. So if the superclass defines a static method and the subclass also defines the static method with the exact same signature, then the superclass's static method gets hidden. It basically hides the superclass method. So that's the basic idea behind method overriding. So if you see, technically, it's a form of polymorphism because the same method is having multiple definitions. But when we looked at the previous example, the multiple definitions were in the same class. Here, the multiple definitions are in different classes, and those classes are having a parent-child relationship. That was about the theory of it. Let's go to an example of it to understand it better. And I've used again the same construct of bicycle and mountain bike, which we have been using in this series just to maintain continuity. So I have a parent class called bicycle here, which has two properties, gear and speed. It has a constructor, nothing unusual there. And then it has defined three methods: set gear, apply brake, and speed up. Set gear is just setting the new value as the gear value. Apply brake is going to decrement the speed by the value you supply, and speed up is going to increment the speed by the value you supply. Simple. This is exactly what we have seen before. Now, mountain bike tries to extend bicycle. So mountain bike becomes a child class. It defines a variable called seat height, defines a constructor called super here, nothing unusual so far. Also defines a setter for height, setter for the seat height, not exactly following the setter construct, but this is just to set the height. But here things get interesting. Let me just bring this down a bit. Yeah. So here it is overriding all the three methods of the base class. And by overriding, it is providing its own implementation of the same methods. Let's compare them. Here, when it overrides the gear and whatever value you supply, it adds 2 to the plus 2 to that value and then sets that value as the gear value. But in case of base class, it was just setting the new value as the gear value. So for instance, if you supplied 1 here, the gear value becomes 1. But here, if you supplied 1, the gear value becomes 3. Similarly, when you apply brake on the mountain bike class, whatever value you supply will be subtracted from the current speed, and 10 would be subtracted even more. So if the speed is, let's say, 50 and you supply the decrement value as 10, so it will be 50 minus 10 equal to 30. But in case of bicycle, if the speed was 50 and you supply 10, then it would be just 50 minus 10, 40. So there is extra 10 being subtracted from the speed when you apply brake in case of a mountain bike. Similarly, for speed up, it's increment of 10 in addition to what value you supply. So again, if the speed was 10 and you supplied 10 here in the argument, so 10 plus 10 plus 10, 30 will become the new speed in case of mountain bike. But in case of bicycle, if you supply 10 and if the current speed was also 10, then it becomes 10 plus 10 only 20. So that's the difference. So the basic idea, I hope you get the basic idea here, is that you override the methods and your own class provides its own implementation of those methods. That's the basic premise of method overriding. All good so far, and you do not have an obligation to override all of the methods, because here we have the concrete implementation of the methods. So here, in case of mountain bike, you can skip overriding one of the methods if you like to. This is also fine. There will be no compilation error because speed up has a concrete implementation in the bicycle class as well. So it's up to you how much you want to override. So let's move to the main class now. So in the main class, we have created the public static void main method here, and let's look at what is happening inside the class. First, we initialize the bicycle class. So bicycle class reference and bicycle class object. Nothing unusual here. We supply the gear value and the speed value. Then we print the gear and the speed value. We apply brake on the bicycle, and then we observe the new speed of the bicycle after applying the brakes. Let me comment out the rest of the code and let's observe the output for only this part of the code, which we just walked through for this section. So if I run this as a Java application, and if I show you what I'm getting here, so bicycle gear is 1, which is what you supplied in the constructor. Bicycle speed is 10, which is again what you supplied in the constructor. Then you applied brake, and when you apply brake, this logic gets executed, and you supplied 1 here, so current speed was 10, so 10 minus 1 becomes 9, and the new speed becomes 9, which is what you are printing here. So far so good. Let's move on to the next section. Let me comment out the previous section now, and let me uncomment this section. So here I have a bicycle reference, but the object is of mountain bike. Remember this concept. This is called dynamic object binding concept or dynamic binding concept. Again, this might be asked in your interviews. So here I'm initializing the mountain bike with a reference of bicycle. Remember, whatever is written on the right hand side will govern the variables and the methods usage. We'll see how that works out, what I just said. So I'm supplying 3 values here, 50, 50, and 3 in the mountain bike. If I go here in the mountain bike constructor, so the start height, start speed, and gear are the 3 values, which is supplied as 50, 50, and 3. Then I'm accessing the gear and the speed. Now remember, gear and speed are declared in the bicycle class, but they are accessible in the child class due to the inheritance phenomena, which we have already covered. So if I print only this part, I should get the expected values. Mountain bike gear is 3, which is what I have supplied here, and mountain bike speed is 50, which is what I have supplied here. Then I apply the brakes. Now let's move on to this section. I apply the brake, supply the value as 1, and then I want to see what would be the new speed after applying the brakes. So let's see what happens when we run this particular code. So if I run this code, after applying the brakes, the speed becomes 39. Before applying the brakes, the speed was 50. So what happened here is 50 minus 1. Basically, this logic is getting executed here. 50 minus 1 minus 10, which becomes 39. That's why you get the value as 39 as the new speed. Similarly, if you want to call another method as speed up method was also defined here, where I'm saying speed plus the argument supplied plus 10. So the current speed is 39 right now. Then I'm speeding it up by 10. So by this logic, 39 plus 10 plus 10, which will become 59. And then I'm printing the new speed after speeding up. So let's see what happens. So if I go to run as Java application, and if I observe all the outputs, the speed was 50 initially. After applying the brakes, the speed became 39. And after speeding up, the speed became 59. So this was a quick demo to show you the power of method overriding and how you can override the behavior which is defined in the base class. Let's get started with the static keyword in Java. Now let's first understand the need of the static keyword, and then we'll talk about how Java implements the static keyword. Imagine a scenario. Let's take the example of a class which we have been using in our different tutorials in this particular series, which is about the student class. So if you are building a college management system, you have a student class there, and if you have an entry, a property in the student class which is storing the name of the college, then the name of the college is going to be the same for all of the students of that particular college. It's not going to change. Another example, let's say you are building a employee management system for an organization, and you want to maintain the employee numbers. For the first object, the employee number should be 1. For the second object, the employee number should be 2. For the third object, the employee number should be 3, so on and so forth. So when you initialize all the employee objects, the last employee object has the final total employee count. And you can also treat this employee count as, let's say, the employee number as the employee ID. So starting from the first employee to the last employee, the employee number is the employee ID, which is a way to uniquely identify an employee. So we talked about 2 different cases. In the first case, we had a particular value which was same for all of the objects, which was the student and the college relationship. And then in the second example, which I quoted, where all the employees objects have to share a particular property amongst them, because if the second object did not know the previous value of the employee number, it will not be able to get to the new number. It needs to know what was the previous value so that it can do +1. So each of the object needs to know the state of the previous object. Two different cases, two different scenarios, one single solution, which is static keyword. So the static keywords are used for those members which belong to the class. Now apply this definition to the examples which I gave you. If I make a member of the student class, let's say the college is the property of the student class, and if I make that property as static, now that static member becomes the property of the class and not the property of the object. It means it belongs to the class. It also means that all of the objects will get the same copy of this static member variable. And that's one of the first usage. And you can make any property or any member of the class as static by just putting the static keyword in front of it. We also call the static member variables as class variables like I just described. So use it for the cases where the value across the different objects doesn't change. You can make those class variables and those variables as class variables or static variables. Similarly, also try to identify the cases where a particular value has to be shared in terms of knowing the previous state. In those cases as well, you can use a particular member in that particular class and make that static. For example, in this case, we have a bicycle class and we have a static variable which says number of bicycles. So every time you initialize the bicycle object, this number will be shared. And you can see, this is here, it is incrementing the number of bicycles. So every time you create the object, the ID becomes +1 to the previous count of the number of bicycles. Exactly same example as I gave you for the employee number. So every time you create an object, you do a +1 to the previous value. Next object will take the previous value +1 and so on and so forth. So you can use the static keyword in front of a property of the class and make it a class level variable, which will be tied to the class and not tied to the objects. You can also make the methods as static as well. And the same kind of rule will apply on the methods as well, that the methods will belong to the class instead of belonging to the objects. Let's say you have again a common functionality which you want to share amongst objects. Just make that common functionality as a static method, and that would be shared amongst the objects. For example, you want to get the total number of bicycles for the previous example, which I just shared in this particular doc here. So you can just create that method as static, and any object which will call this method will get the latest count of the number of bicycles. You can also make these static variables as constants by putting the final modifier in front of it. So if a variable in a particular class is static and final both, then technically it becomes a constant. So these are some of the interesting use cases and constraints of the static methods and static variables. There is also a thing called static block, which is just a code block which you can write inside your class. And we will have a look at that example as well. So let's shift to the IDE and let's have a look at how we can use this static keyword. So I have used again the same class which I have been using in other examples, which is student.java. And you can see I have this same class. You would have seen these properties earlier as well. And the code below is exactly the same, just setters and getters and constructors. And it has an additional property, which is college. And the college name XYZ is the same for all the students. So I have just hard coded it. But you see, what is happening here is that every time you create a student object, this variable gets initialized. Even though the variable for all the objects has the same value, still it gets initialized again and again and again. So technically it's a waste of memory. You're just wasting memory of a new allocation every time, even though the value is same. What if we create this object once and this member variable once and just use it across objects? You can do that by just writing static in front of it. If you do that, then you see this becomes sort of italic here, and that's Java's convention to show that this particular variable is a static variable. You can also see the static keyword in front of it. And then whatever value you have specified, this will be initialized only when the class is loaded. Remember, I'm not talking about the object initialization. I'm talking about the loading of the class in the JVM. So the first time the class is loaded, this particular variable will be initialized, and that's it. After that, no matter how many student objects you create, the same college reference will be used again and again, and the college variable will not be initialized again. It will be initialized once, and the same college reference will be used again and again. That's the power of static variables. For example, if I want to access this particular college variable, how do I do that? So let's look at a main class where I have initialized this particular student class with an object named as John, and I've specified the name, the age, and the address, and I'm printing those values. How do I access this static variable? If I say John dot, do I get access to the college variable? Yes, I do have access to it, but does it work? Let's see. You see a yellow line here, and we will come to that yellow line in a while. But let's first see if this works. Yes, it works. I can see that the college name is printed here as XYZ, which I have set. Now let's look at the error or the warning. It says the static field student.college should be accessed in a static way, because the way you are accessing it right now is the instance way of accessing a particular member. This is not a static way of accessing a member. So if you want to access, this is going to raise a lot of violations and a lot of questions for you as to why you are not accessing it via the class name. So this is the correct way of accessing it, and you will get the same output. Now, no matter how many objects you create of the student class, you can always access the student.college and you can always get the same value of the college name. That's the first use case. Second thing is about static methods. So you will use the static methods in a case where I described about the counting the employee numbers. And let's say if we have the same kind of scenario where you have to count the number of students, because you can use that particular count as, let's say, the roll number of the student. So if you have that kind of requirement, then you need to create a static method because you need to share the state of the object across objects. Remember that. So what you can do simply is create a static method. So let's say I create a normal method and then I just put static in front of it, saying static void student count. And now I want to count the student. So let's create a simple count variable and let's start it with 0. And then I can increment the count variable again and again in the static method, right? But you see, I get an error here. The error is if you go to the balloon, it says cannot make a static reference to a non-static field count. This is one of the properties of the static methods. The moment you make a method as static, then that particular method can only access the static member variables of the class. The static methods will not be able to access the non-static variables. Count is a non-static variable. Count is a normal instance variable. So a normal instance variable, for that matter, name or age or address, nothing would be accessible here. If I try to access, let's say I try to access name here. So if I just say sysout and I say name, it will also give me the same kind of error. If I go here, it gives me the exact same error because static method cannot access the non-static member variables of the class. So you have to make this count variable as static as well. And then only this compilation error will be fixed. I can remove this one. And now this method is fine. Now I can increment the count every time that object is created. And that is one of the use case of using the static method, that you can share the state across the different objects. And if you want to fetch this particular variable, then you can simply write a getter for this, saying int count, return count. And then you can return the count. You can see that, but a static method cannot access a non-static variable. Remember that a static method can not access a non-static variable, but a non-static method can very well access anything, including the static variable. That's second thing. The third concept is of static block. And static block also has a similar usage, that if you have a block of code, it's not just a variable, it's not just a method, but you have a block of logic which you want to execute only once when the class is loaded into the runtime. If that is your requirement, then you can write a static block. And the way you will write it, generally we write it at the beginning of the class. And the way you will write it is as you write static and you put curly braces and you start writing code here as to whatever. You can say initializer, and you can write whatever code you want to write. The only caveat is that in the static block, you will only be able to access only the static member variables of the class. So you will not be able to access these variables. You can only access these two variables. You can very well move these two variables here if you want to. So if I go here, I can paste this and I can drop the static keyword because everything in the static block is automatically static. So I don't need to explicitly call out static variable. And now this code is fine. You get some warning because it's not used anywhere in the class, but that's fine because this is just a simple demo. But the whole point is that you can write the static block and you can write all the initializer code which you want to write here, which you only want to execute once during the whole execution of your program. Just to show you the reason and the way it works, let's try to see if the static block works. And let me comment all the static code which I wrote here. And let's go back to the static demo and let me remove this one as well. So now I just will run this student.java. I will create an object of student.java and I will see if the static block gets executed or not. So let's run this particular class, which is the main class, and I have a main method. I have a student object initialized and I'm printing the name, age, and address. If I run this, you see the first line of code which gets printed in the output console is the static block code, which is what I wrote here. And let me do one more thing just for fun's sake. Let me create more objects of it. Let me just call them 1, 2, 3, and 4. And let's see how many times the initializer code gets printed. You see that the code still gets printed only once, even when I created 5 different objects of the student class. And that's the property of the static block, that it will be executed only once when the program is loaded into the runtime. And that's all. Exceptions in Java. Let's first understand what are exceptions and why do we actually need this concept. The simple reason for having exceptions existence is that developers make mistake. We do create bugs and errors while we write code. It's natural. It always happens that whenever you write code, you might miss out some condition or the other, which creates a bug in the application, which creates a defect in the application, and then the testing team finds that defect and then we fix that defect. And that's how a normal software development lifecycle works. So to handle those kind of exceptions and errors, every programming language provides their own exception and error framework to support the developer in spotting those errors and fixing those errors and handling those errors instead. And Java also provides its own exception framework. So what you see on the screen right now is basically a snapshot of the exception framework of Java. And you see it has a long hierarchy of different classes here. This is also an inheritance hierarchy, just to give you context. And the whole exception framework hierarchy starts with a class called throwable. So throwable is the class which is the root or the parent class of handling all types of exceptions and errors. And that's where the next differentiation comes, exceptions and errors. Java treats these two things differently. And I will go in detail as to what is an exception and what is an error. But let's first understand the hierarchy further. Under the exception hierarchy, you see some exceptions like IO exceptions, which is an exception which comes when something goes wrong in the file writing or file reading or the file handling operations. Then you have SQL exception, which comes whenever you are talking to the database, writing SQL queries and something goes wrong. You also have class not found exception, which comes when a class is not found in the runtime or at the time when the class is being loaded in the JVM. And then you have also runtime exceptions, which are like arithmetic, number format, and there are lots more of this type of exceptions as well. On the right hand side, you have the error type, and then you have some errors like JVM error, memory error, and framework error. So now coming to the differentiation between exception and error. Exception is a type of problem which can be recovered in a program, from which the program can be recovered, which the developers should handle. So exception is a type where the developer focus is. The developer is responsible to make sure that none of these exceptions occur in the program. And if these exceptions occur in the program, then the developer has the responsibility to handle these exceptions properly. We will look at the examples of how the developer can handle these exceptions. On the right-hand side is the error type, where the developer does not have any control. You cannot do anything if the JVM has an error, or if the underlying memory of the computer or the JVM memory gets an error, or the whole framework or the Java itself, library itself has an error. You can't do anything about that. And those are the kind of problems which go into the category of error. That's why Java has created these two different categories. One is exceptions, which is the responsibility of the developer, and other is error, which are not the responsibility of the developer. And in fact, developer cannot do anything if this happens. So this was a quick tour to you to what kind of the exception framework is present in Java. Do read about this framework in detail in the Java docs as well. But just to extend this understanding further, we'll have a look at some examples of the exceptions and how these exceptions occur. So with that, I'm going to switch to the Eclipse IDE, and I have created a bunch of classes to show different types of exceptions. So let's go through the first class, which is named as Simple Exception Demo. It has a main method. It has a variable of int type. The variable name is data. And what I'm doing here is I'm dividing 100 by 0. So if you see this carefully, you know that this is going to result in an infinite value. You cannot divide any number by 0. And Java also prohibits doing the same because it doesn't make sense to divide anything by 0. So if you run this particular line, if you execute this particular line, this is going to throw a runtime exception. These are the runtime exceptions, remember. So let's try to comment rest of the code and let's quickly try to run this. So I run this program and there you go. I get an exception which says exception in the thread main. Main is the main thread. Which the exception type is Java.Lang.arithmetic exception. And this is the exception type, divide by 0. And it will also give you the line number at which the exception happens. If you click on this, it will directly take you to the exact line at which the exception happened. And this is, if you see now, this helps the developer a lot. This information which is printed here is called exception stack trace. And you can look at the stack trace, go to the last line, and this would be the line from where the exception actually originated. If you click on that particular line, it will take you exactly at the place where the exception might have occurred. And then you can look at the line, fix the code, and rerun the program to see if the exception is gone. That's why I said that developer has to handle this exception. Now, as far as handling these exceptions is concerned, I'm going to cover that in the next session. But in this particular session, we are just going to focus on the types of exceptions and how they occur. This was an example of arithmetic exception where we are trying to divide something by 0. Let's take another example. Let me uncomment this particular line of code and comment back this one. So here I am creating a string A, but the string is null, and null means nothing. It's a void reference. It has nothing in it. And now if I try to do some operation on this particular string, so remember A is null, and whenever you are trying to operate something on a null object, Java is going to throw you an exception because you can't operate on null because null means nothing, empty. It is a dummy thing. So you cannot do anything on this particular null reference. And if I run this program, I get an exception which says null pointer exception, java.lang.null pointer exception, and it will give you the exact reason. Cannot invoke string.char at int string. This is a string type, string.char at int because A is null. So it will give you the exact reason as to why this program failed. And then again, if you click on this particular line, it will take you the exact line where the problem is. And then you can fix the problem. Maybe you need to initialize the string properly to make sure that this error doesn't occur. So these are all the runtime exceptions which the developer has to take care of, which the developer has to fix to make sure that the program runs smoothly. If they don't handle it, the program is going to fail, and the program will actually force them to fix because the program will not run unless they fix those exceptions. Now, these are the examples of runtime exceptions. You can also create these kind of exceptions, which are called checked exceptions. Runtime exceptions are also called unchecked exceptions. You might hear this term as well. Some people use the term runtime exception instead of unchecked exception and use both of them interchangeably. So runtime exceptions are also called unchecked exceptions, and these exceptions are called checked exceptions. Why do we call them checked and unchecked? Is because these exceptions are something which you do not have to explicitly specify in your program. In this program, I did not have to explicitly specify this particular because I don't know if this line of code is going to result into a null pointer exception or not. But these exceptions are something which Java will force you to handle. Let's look at an example of this. So I have created one more class which is named as checked exception demo, and I'm doing some file operations, basically reading a file, writing to a file, etc. I'm using some classes of Java named as file reader and some methods like readLine and close. And if you see, the moment I'm trying to read a file, this line has a red marker. There's a compilation error. If you scroll over it, it says unhandled exception type file not found exception. So Java is forcing you to handle this this particular exception because file not found is a checked exception. So if your expression, your line of code is throwing a checked exception, then Java will force you to do something about it. It will not compile the code until you either handle this exception or you rethrow this exception. Again, how do we handle this is something which we will cover in the next session. But you can always rethrow this exception, but you have to do something about it. You cannot just skip it. So what I can do if I don't want to handle this is I will pass on the responsibility of handling this exception to the callee program. So whoever is going to call this main method has the responsibility now to handle the file not found exception because I've just thrown it. I've just passed it on. I've just passed my responsibility to the callee. And you can do similar thing here as well. If I go here, you see it says unhandled type exception IO exception. And if you remember, IO exception is here. It is a checked exception. So I can do one more throws here, comma V. And now if I just resolve the import, whoever is calling the main method has the responsibility of handling the file not found or IO exception. You can also handle it like I said, or you can just add throws clause to the method signature, and then the caller has the responsibility to fix or handle the exception. So this is how the checked exceptions work. Remember, in the unchecked exception, in the runtime exception, we can see that these two lines do throw exceptions, but there is no forced way by Java to tell us that I have to fix it because Java doesn't care about unchecked exceptions at the compile time. It will only encounter those runtime exceptions at the runtime. That's why they're called runtime exceptions. But checked exceptions are compile time exceptions, and you have to fix them, handle them, or throw them right at the time of compiling the code. So that was about checked exception. Now there's also a possibility that you can create your own exception if you want to. So for that, I've just created a very simple class here called myException. And the way you create your own custom exception is by just extending your class with exception class. You just write this extends exception, and you can write a default constructor or a parameterized constructor, whichever makes sense for you. And this is your exception class ready to use. And you can just invoke this exception explicitly. Remember, whenever you are creating your custom exception, it is by default a checked exception. So your program has to handle it. For example, if I go back to this particular class, and if I do this, let me just comment all of this code now and remove the throws clause as well. So if I go here and I'm saying throw new myException. MyException was my class. So I'm explicitly throwing an exception, which was my custom exception. And I again get the error. If I hover over it, it says unhandled exception type myException. So I have to handle this exception, or I can just throw this exception and let the caller handle it. So this also works. So this basically builds our understanding that broadly there are three different types of exceptions which we work with. There is a runtime exception, which is also called unchecked exception, which happens because of developers' mistakes in the program, like this one. Then there is a checked exception, which developer might not be responsible for creating the exception, but developer has to handle it. And there are some classes in Java which throw those checked exceptions, like file not found exception and IO exception. Whenever you are working with file handling operations, Java will force you to handle those checked exceptions or rethrow those checked exception using the throws clause. Similarly, the third type is when you create your custom exception type, and custom exception types are also checked exceptions by default. And whenever you are explicitly throwing your own custom exceptions, you again have to either handle the exception within your enclosing code, or you can just rethrow the exception and let the caller handle it. So this is a quick tour of different types of exception and including this exception hierarchy. And let's get started with exception handling in Java using try and catch blocks. So in the previous session, we had a look at the scenarios where an exception can occur. How do we see that there's a runtime exception, or there's a checked exception, or there's an unchecked exception, or there is a custom exception? Now, we did not talk about how to handle those exceptions, and now we are going to focus on the handling part. So whenever you have to handle those exceptions, the way Java provides for that is using the try catch block. So try catch block is basically a bunch of syntax which you have to follow to handle different types of exceptions in your programming code. And the syntax of the try catch block is pretty straightforward. You write try and you put curly braces, and then you write whatever code which might throw an exception. You don't know that, but it's always safer to enclose your code in a try catch block so that you know that if an exception occurs in the try block, then you can handle it in the catch block. So it's always considered a better practice to enclose your application code in a try catch block so that you can handle the exceptions. So you put this try block and write all the suspicious or non-suspicious code which may or may not throw an exception inside the try block. Once you have done the try block part, then comes the catch block part. So let me go to the catch block. So this is how the syntax look like. Once you have written the try block, then you write catch and you put braces and you write the exception type which this block of code might throw, or the exception type which you are interested in catching. You might not be interested in catching all the different exceptions, but only a few ones based on your business requirements. So whatever exception type you want to catch, you are going to catch it like this. And if an exception occurs in the try code, let's say you have specified an arithmetic exception here, and if any line of code in the try block throws an arithmetic exception, then this catch block is going to catch that exception. And then inside these curly braces, you can decide what to do with that exception, whether you want to log that exception or whether you want to rethrow that exception, whether you want to embed some error code or get an error code out of it, or convert that exception into a business or custom exception of your own choice. So it's up to you what you want to do with that. But catch block will be able to catch that arithmetic exception. Similarly, you can specify as many exception types to be caught as you want and keep adding more and more catch blocks. Remember that these catch blocks work in a sequential fashion. So if an exception occurs here, it will first go to this particular block to match the exception type. If it didn't match, then only it will move to the second type. If it did match the first type, it is not going to execute the second type. So that is how the try catch block work. You can see an example here that if the code here is throwing an index out of bound exception, then it is going to be caught here. And we are just printing the index out of bound exceptions message. If it is throwing an IO exception, then I can do this. So you can keep adding different checked and unchecked exceptions in the catch block. You can also catch more than one type of exception with one exception handler. So rather than writing these multiple catch blocks individually, you can combine these exceptions together if your logic of processing both of these exceptions is the same. Remember, if the logic of processing these two exceptions is the same, logic means whatever you write inside these curly braces. So if that code is going to be the same for both of these exceptions, then why bother writing two catch blocks? Just write one catch block like this. Use the pipe operator to separate different types of exceptions and write the common code which is going to be applied if your try block is going to throw an IO exception or an SQL exception. So that depends upon you. That's the second piece. The third piece of the try block is the finally block. So we talked about the try block, we talked about the catch block. Now there's a finally block as well. Remember, this is finally and not final. The finally block is used together with the try catch block when you want to perform some cleanup operations. Imagine you are opening up a file handler in the try block, you're doing something with it, and then you want to just close the file handler irrespective of the fact if there was an exception in the try block or not. Because even if there was an exception, the file handler resource is going to remain open and is going to consume memory in your application. You don't want to do that. Similarly, if you opened a database connection inside your try block, irrespective of the fact of what happens in the try block, you always would like to close the database connection. And you can write that closing code in the finally block. That's the purpose of the finally block, that you can write the code inside the finally block, which is supposed to be always executed irrespective of the fact whether an exception occurs or doesn't occur. So now we have built a good understanding of what is the try catch, what is the try block, catch block, and the finally block. Now, if you just put it all together, this is how it is going to look like. That you write the try block, you do something inside the try block, then you write the catch blocks. After that, you write the finally block. You can write the finally block without the catch block as well. Remember that. If you do not have any exception to catch, but you have some resources to close or free up after executing the try block, you can skip the catch block and just write try finally. That is also possible. With that understanding, let's switch to the IDE and let's look at some example. So I have a writer helper class, which is having a method called writeList. I have a try block here, and this try block is basically initializing an array list, adding an item to the array list, and then I'm accessing list.getOne. Remember when I added this particular value, let me make it 10 to make it more understandable. When I added 10 to this particular list, this goes to the index 0 position. And here I'm trying to access index 1 position, which does not have anything. So in such case, it might throw an error because there's nothing at list.getOne. So this is my method where I put the try block code. And then because I don't want to end up in a position where I get an index out of bound exception. Index out of bounds exception comes if you are trying to access an index which is illegal, which does not having any value. So I'm putting a catch block and catching the index out of bound exception and just printing the message of the exception. And then for simplicity, I'm showing a finally block as well. Though I do not have any resource to close here, but this is just to show you how this looks like in the code. This is just to show you that I'm printing a sys out here. This is what my method is. And if I go to the main class, the try catch demo class, I'm creating an object of the writer helper class and calling the writeList method, which we just walked through. Let's run this program and see what happens. Okay, so first I get this statement saying entering try statement. So if I go here, I call this method, the execution goes inside the try block and I get this sysout, which says entering try statement. Then I try to access the second element in the list because the position is 1. This is going to index 0 and I'm trying to access index 1. There is nothing at index 1. So I get an error saying index out of bounds exception, index 1 out of bounds for length 1. Because the total length of the list currently is 1 because there's just one element and that one element is sitting at 0 and not 1. So I get the exception, which is the index out of bound exception, but the index out of bound exception is caught by my catch block and the system.error.println is something which gets executed and I get this particular line from this line number 17. And then irrespective of the fact whether an exception occurred or not, my finally block always gets executed. Let's fix this and see if the finally block gets executed even if there is no exception. So now I'm accessing get 0 and let's see what happens. Yep, I access the element 10, no exception, but the finally block still gets executed. So this is to assert our understanding that the finally block will always be executed irrespective of the fact whether there was an exception or there wasn't. Now you can also nest different try blocks if you want to. Let's look at an example where I have multiple try blocks. So you can write a try within a try within a try if you want, and you can go as deep as you want. But remember, the more indentations, the more hierarchy you create, the program is going to get more and more complex. So always remember to have that kind of trade-off. So I write multiple try blocks, I initialize an array, I print array 10. Obviously array 10 does not exist because this array has just 4 elements. So this is bound to throw an index out of bound exception, and I'm catching that exception immediately in the catch block. This is the exception, printing a sysout and just rethrowing the exception. You can also rethrow the exception by just using the throw keyword. Remember, this throw is different from the throws keyword, which comes in the method signature. This is just to throw any exception from your code. So this is array index out of bound exception for this try block. Then I have another array index out of bound exception for this try block, which starts from here, block 2. and then I have another catch block for the block 1 try block. So you can see it is already getting a bit complicated where I have multiple hierarchies, but you can do that. So this is what is happening in this particular program. Now let's try to run this and see what happens and try to decipher the output. Okay, so at first I get this particular line which says array index out of bounds exception in block 3. What happens here is that this line gets executed. It throws an array index out of bounds exception. At line 13, that array index out of bounds exception is caught, which was generated from this line. And then we go inside the catch block. We execute this sysout. This is what you see here, the same sysout. And then we rethrow the exception. If we rethrow the exception goes to the enclosing try block. The enclosing try block is this one. There was an exception rethrown from this try block, and now it has gone to this try block. And now this try block, block 2, will try to see if it can catch this array index out of bound exception. Yes, we can catch it. So it can. So the block 2 again has a catch block which catches the array index out of bound, and it prints a sysout here which says exception in block 2, which we see here. And it again rethrows the exception. And if it rethrows the exception, so now the block 2 is rethrowing the exception. So this whole code is now rethrowing the exception. If this block 2 is rethrowing the exception, it goes to block 1, just going one hierarchy up. And then it sees if it can handle the exception in the catch block of this block 1. So yes, the block 1 try block also had a catch exception which said array index out of bound E4, and here it just had a sysout. So if I just bring back the output, yes, we do get this particular exception printed here which says array index out of bounds exception in block 1. This is what you see here. And this is where the exception just stops going propagated because I'm not rethrowing the exception from this particular catch block. So that's where the exception ends. The reason you see a hyperlink here is because the text which I have printed here exactly matches with the name of the exception. So Java is pretty smart in that case. If you use the exact same name exception, it will link it to the matching class name in Java, which is pretty cool. I also have a redundant catch block here, which does not have a try block. This is just to show you that you can write a catch block without a try block, but it doesn't make sense. It is of no use. So I can just remove this particular catch block and the program still will compile fine. So this was a quick demo to show you how you can use try, catch, and finally blocks. And when would you use the finally block? And if you want, you can use a nested hierarchy of try blocks, and you can rethrow the exception from within the catch block only to be caught in the outside or the outer or the enclosing block. So this is all I want to cover in this particular session. Let's get started with equals and hash code in Java. This is probably one of the most important and interesting concepts in Java and extremely popular when it comes to Java interview questions. So let's cover this in detail. To understand why we need equals and hash code and what equals and hash code is all about, let's first understand the object class of Java. Remember, I'm calling it an object class and not just an object. Object is a class as well in Java, and it is the super class of any class you create in Java. So anything you do in Java, any class you create, it will automatically be inherited by the object class. Object class is the super class of any class created in Java. And if you look at this documentation, and if you come here, you will see that object class defines this equals method, which indicates whether some other object is equal to this one or not. And it also defines a hash code method, which returns a hash code value for the object. So let's understand both of them one by one. First of all, let's establish that these methods have their concrete implementations available inside the object class. But how do you do that, and how does it come into effect? Remember when we talked about HashSet, and I said that HashSet will maintain uniqueness automatically. How does it maintain uniqueness automatically? It is because of the equals method implementation, which it inherits from the object class. That's how it maintains uniqueness. And if you remember, I also told that you can maintain uniqueness in a hash set if it's a built-in data type like integer or string or float or double, etc. But what if you are trying to create a hash set of student objects? Then Java does not know how to perform equality on two student objects because student is a custom object. Java doesn't know how to run equality. And that's where equals in hash code comes into picture. So the contract is that whenever you are creating your own custom objects and you have a need to perform equality on those objects, you must override the equals method in your own class. You have to override that. If you do not override that, then two student objects will be compared based on the reference and not based on the actual object values. We will see all of that with the help of an example. Another thing which says that whenever you are overriding equals, you should also override hash code method. Reason is because hash code is also used in certain collections, and we will cover that in a while. But let's just focus on equals first. And let me switch back to the Eclipse IDE, where I have a student class. Again, it's a very familiar class which we have covered in other lectures as well. And I have three different properties here: roll number, name, and address. I have a constructor, and I have setters and getters. Now, if I go here and I create three different objects of the student class, you see I have created three different objects. This student object has a roll number 1, name John, and the address is the same one. Second object has a roll number 2 and the name John, and the address is the same as this one. And third one again has a different roll number, but the name and address is the same. It's a hypothetical situation. So let's do one thing. Let's make this roll number as 1 as well. So now these two student objects are exactly identical. So what happens if I compare John with John 2? By looking at naked eyes, these two objects look exactly the same. So John equals John 2 should return true. Let's run this program. But we get false. The reason we get false is because the default implementation of equals is being run on comparing the student objects, because Java still does not know how to equate these two objects. Why you are getting false? Because these two are different references. Java created a new memory location somewhere and put this object, created a reference John to it. Then Java created one more new object in this line. Then Java created one more new object in this line and created a new reference John 2. So these two different references are pointing to two different memory locations of the objects. Though their internal values are same, but their memory locations are different. That's why you get this particular value as false, because these are pointing to two different memory locations. And that brings me to the hash code contract. You need to override the hash code contract as well, along with the equals, to make sure that your equality runs perfectly. Let's go back to the student class and let's fix this problem, because we can see that these are identical objects. You don't want to store the same student twice in your database, right? So you need to fix this. So I go back to the student.java and I have commented this equals method, and let me uncomment this now. So what I do, that I override the equals method, and the equals method contract looks like this, where you supply an object which is a foreign object, and now you need to compare this foreign object with your current object of the student class, which is this. So at first you need to run this particular condition which says, are these two objects, these two references, this reference and the obj reference, pointing to the same object? If they're pointing to the same object, then this will return true, and then we will say that the object is that equality holds true because both are pointing to the same object. So obj equals this. If that doesn't hold true, if this doesn't hold true, then it moves on to line 50 and it runs a condition saying that is obj null, or obj.get class is not equal to this.get class. Get class is a method which will tell you the class type. Here we are checking is the obj class object is of the type student or not. If it's of different type, let's say vehicle or something, then definitely they will not be equal, and we can directly return false. So that's why I'm checking that it should not be null, or the class types should be matching. If either of these conditions are holding true, then I return false and I say that objects are not equal. So I've covered this condition where both of the references were pointing to the same object. I covered this condition where the class types were not matching or the obj itself was null. Then we return false. If we passed all of these sanity checks, then we do the actual comparison. Before doing the actual comparison, I need to do this explicit casting. So I cast the obj object into the student type. If you remember, this is how we did the casting for other data types as well. Once you have converted this obj into the student object, then you need to define your own business logic based on which you are going to define uniqueness. So how are you going to uniquely identify a student in your application will govern this logic. In this particular example, I'm saying that I am going to identify a unique student based on its roll number. So even if two students have exact same matching details, but if their roll numbers are different, then these are two different objects for me. But if two objects are having the same roll number, and even if they have a different name and address, I'm going to say that those two objects are duplicate. So roll number is the condition on which I'm defining uniqueness, equality, and duplicity. So I define this and say if the roll numbers are equal, then the object is equal. Objects are same basically or duplicate. And if the roll numbers are different, then these two are different objects. Good so far. Coming back to the main class. So now I have the same roll number here. Let me change the name just for fun and address as well. So I have a different name and a different address, but the roll number is exactly the same. Remember, we have defined the equality condition based on the roll number. And here we are comparing if John is equal to John 2 or not. So let's run this program. Now I get true. The reason I get true is because this equals method is used to run this equals comparison. So this establishes how we can use the equals contract to maintain uniqueness. Now I also said that whenever you are defining the equals method, you also have to override the hashcode method. And to understand why do we need hashcode as well, let's go back to how hash map works. Remember in the hash map, or let's say even hash set, in the hash set you have to maintain uniqueness. Now Java maintains uniqueness using both equals and hashcode. Hashcode is nothing but a memory bucket in Java's memory where your object is stored. It's basically a memory location. So every object has a hash code, and that hash code is the actual memory footprint where the object is stored. And whenever you are dealing with hash set or hash maps, you will be required to override both of these methods. Let's understand how this works. So if you have a hash set and you are trying to insert an element, then first Java will use your equals method definition to check if an object similar to the object being inserted is already present in the hash set or not. If it finds an object, it will basically flag that this is a duplicate object and it will not insert it. Let's understand how an object is fetched from hash set. Let me open a hash set example just to give you some sort of a visual representation of what I'm talking about. So if I go to my hash set example in the collections package somewhere, and let's open a hash set demo class. Yeah. So when we were doing these insertions, though this was a string object, so the Java already knew how to use the equals and hash code of it. But if it was a student object and you were doing multiple add, and then when you were actually fetching the element or you were doing the contains, then how does it work is basically first it is going to calculate the hash code of the object. let's say you are saying HashSet.get B or HashSet.get John1, then it is going to calculate the hash code of your John1 object. Hash code is a memory footprint, and hash code, the way it is going to calculate the hash code is going to be based on the definition which you have provided. So the definition which you have provided, this hash code will be run to calculate the memory footprint, and then that particular Java will go to that particular memory footprint and see if there is an object present there or not. Now Java has a memory location, right? And there can be multiple objects stored at that particular memory location. This is possible in Java. So if there are multiple objects present in that particular memory location, which was calculated based on your hash code implementation, then Java is going to run the equals method to find the exact matching object. So just to try to visualize this, if I try to visualize this, let's say you have this memory locations, and let's say your hash code came up to memory location 2, and then at 2 memory location you had multiple objects, obj1, obj2, obj3, etc. This is possible. Multiple objects can point to the same memory location. So if this happens, then Java is going to use the equals contract to compare your John1 object with obj1, with obj2, and with obj3. This is where the equals will come into use. So you see that both hash code and equals are being used here to point to the right memory location. And that's why I said that hash set and hash maps are where equals and hash code will come in full force, where you will be required to implement this. And it's a good practice to always override the equals and hash code in your application whenever you are creating classes. The reason is that you don't know when and where these classes will be stored into a hash set collection or a hash map collection. So it's always a good idea to have equals and hash code being implemented. And when you implement hash code, the thumb rule is that you should use the same parameters which have been used in the equals contract in the hash code contract as well. The reason for that is, what if you used here, let's say you used name here and you used roll number here, then two different properties are being used to find memory location and the uniqueness. And remember this logic which I just gave you. Here both hash code and equals are working together to find the right object. So if you make any mistakes in defining the equals and hash code, or if you made any mistake in defining the symmetry between equals and hash code, then you may get unpredictable results. How you define your hash code? Up to you. But make sure to use the same properties which you have used to define the equality. Always keep this consistent to avoid any unexpected results. You can also do this, just say return 1. And what will happen that when you use this particular student class in a hash set, all the objects are going to be stored at a single memory location. And then this particular situation will occur where you will have a single memory location and all of your objects will be present at that memory location. And when you are trying to fetch anything, the hash code will always point to the same memory location, and then equals will make sure to find out the right object you are trying to fetch from the hash set. So this is all about equals and hash code, which I wanted to cover in this particular lecture. Do read about this in detail. There are tons of articles available on this particular concept because this is a very important and popular concept, both from implementation perspective and from interview perspective. Let's get started with comparable in Java. And before we go there, let's understand why do we need comparable. The need for comparable comes from the requirement whenever you have to sort your collections. So to understand that, let's move over to the Java docs to understand how this works. So the basic idea is that you want to sort your collection, and to do that, Java provides you with a method called collections.sort. You just supply your list or your collection inside this sort method, and all the elements or objects inside your collection will be sorted based on the natural sorted ordering. This holds true for built-in data types, but what if your list is of type student objects? Then again, the same constraint applies that Java does not know how to sort student objects. It knows how to sort strings and ints and floats and doubles, because those are built-in data types, but student is a custom type and Java doesn't know how to sort it. And to solve that problem, Java provides an interface called comparable. So comparable is the interface which you need to implement from your class whenever you have a need to sort your objects of your class type. So this is the interface which your class needs to implement. This interface provides a single method which says compare to, and it provides the foreign object, and then you need to compare this foreign object with your current object. So let's go back to the Java class and understand how do we work with this comparable interface. So again, I have used the student class for the sake of continuity, and I have the same properties as roll number, name, and age. But this time I say implements comparable of type student. This is a generics type. We will be covering generics in a bit more detail in this whole series. But the basic idea is that you define that this comparable interface will only work for student types. You define the type in this particular construct, which we also call as generic type. So you do this, and the moment you do this, Java will force you to provide the implementation of the compare to method, which I have provided here. So the way this implementation works is you have a foreign object here, but this time this foreign object, since I have defined this as of type student, so the moment you do this, Java will ask you to override this method, and using Eclipse IDE, if you override this, then you will get this signature automatically. Let me show you this how this works. So if you do this, you will get an error here, and if you click on this balloon, it will say add unimplemented methods. If you double click on this, you will see a compare to implementation here. And this is exactly the skeleton which you see here. By default, it says return 0, but I'll just come back to that in a while. So this is how this method came up here. And once you have this signature available, then you need to provide your implementation on how do you want to sort the objects. Remember, you need to define your logic here. So again, I would like to sort my students based on the roll number, which is the natural sorting order for me for the student objects. So this is your custom sorting logic, which you can call as natural custom logic sorting order for your student objects. So I want to sort them based on roll number, but you see I've done a strange thing here. I've done a minus here. So what I'm doing is that the current object's roll number minus the foreign object's roll number. So if this value comes as a positive number, then this object is going to take priority. This is going to be sitting before the student. If this result returns in a negative value, then this object will come first and this will come second. So the student object will come first and this object, the current object, will come second. And if this returns 0, then it means both of the objects deserve the same priority or the same order priority, and any one of them can come after the other. So the basic idea is that if this results in greater than 0, then the current object is going to take precedence. If this is going to return in a negative value, then the foreign object which you're supplying here is going to take precedence. And if this returns in 0, then any one of them can take precedence. So you need to define your compare to logic in the compare to override implementation. Once you have done that, let's understand this with the help of an example. I've created a comparable demo class which has a public static void main method, and I create an array list and I create 3 different student objects. First student object is named as John, second is Jane, and third is Tom. The first has a roll number of 3. So John has a roll number of 3, Jane has a roll number of 1, and Tom has a roll number of 2. So if my compare to logic runs perfectly, then Jane should be coming first after I sort this collection, after I add these 3 elements into my list. And once I sort this collection, then Jane should come first, Tom should come second, and John should come third, based on my natural ordering custom logic, which I have implemented in the compare to method. And that's what I'm doing here. After I've sorted the list, I'm just printing the list by using the for each construct of the streams API. I'm just printing the name to see which one comes first and which one comes second. So let's run this program. And this is how it looks like. So Jane comes first because she had a roll number 1. Tom came second because he had a roll number 2. And John came third because his roll number was 3. So no matter how many times you run this program, you're going to get the collection in the same sorted sequence. And this is happening because of the compare to implementation which you provided here. Now, if you comment this implementation, let's see what happens. And I remove this implements comparable as well from here. I just create a simple student class and now I try to run this sort. Now you see that you get an error here. And if you hover over this balloon, it says that the method sort in the type collection is not applicable to the argument array list of student. Java does not know how to sort this. So it will force you to provide a sorted implementation. And the moment you provide comparable implementation here, and if you go back to the main class, the error is gone. So this also will force you to provide your comparable implementation. Now you can use this sorting for any kind of collection sorting as well. And whenever you are doing this, always make sure to provide the compare to implementation. And remember that contract which I gave you about greater than 0, less than 0, and equal. Let's get started with walking through a core Java project using all the different OOPS concepts we have learned so far. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9, the current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2, and whatever value it gets, it is going to store a value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the get result based on the expression. And whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. Let's get started with enums or enumerations or enumerated types in Java. So before we go into enums, let's understand why we need it. When you will be building the Java applications, you will face scenarios where you will have to define some variables which will remain constant forever. For example, months of the year. They are not going to change. They are always going to be 12 months in an year. Similarly, let's say name of flowers. They are not going to change. A lotus will be a lotus forever. Similarly, the name of the seasons will always remain same. The season of summer or winter will always be called summer or winter. They will not be changed. The meaning of those variables will never be overwritten or will never be changed. So you can think of them as constants, but they are not the constants which your programs may mutate or your programs may interpret differently. They will be interpreted by multiple applications, multiple components, multiple consumers in exactly the same way. Similarly, if you take the example of time zones, they are fixed. They work with the GMT with respect to the GMT time zone, and they will always remain like that. So whenever you have a situation where you have to define such constructs or such constants, always think of enum types or enumerated types. Enum is basically a language construct, and you can use this language construct to define type safe variables. When we say type safe variables, what we mean is that these variables are not integer or string, they are of enum types. That's the reason Java created a completely new data type, which is called the enum type. They are by default constant, so you cannot change them. That's their property. And the way you define enums is like this. You say public enum. So instead of the keyword class, you use the keyword enum. And then you define the name of the enum type. And then you define the possible values, just simply separating them by a comma. So for example, days of the week is again a constant thing. There will always be 7 days of the week, irrespective of what you do on this planet. So that's why you can declare an enum for the day, and you can define those as the values. You also notice that the values are caps by default, and yes, that is how you define the enums. Let's have a look at a more interesting example of the enums in the IDE now. So if I switch to the IDE, I have created a class called color, not a class, but an enum type called color. And this enum type color is basically holding all the different color types, their values basically, like all the WebGear colors, for example. So I've defined 3 colors here, which are red, green, and blue. So you see, I've defined them as caps. They automatically become bold. You don't have to bold them. But you see an interesting thing, a difference here, that there is another value in the brackets here. This was not there when we looked at this example of day. There is no value inside each of the enum types, but I have defined the value of the enum types, and that is optional. There will be use cases where you want to define some enum constants, where the name of the enum type is a constant, which is a placeholder, but it will have an internal value. which may be more practical for your application. So this is what your consumers see, and this is what is used whenever you call read inside your application. Is just for simplicity. There might be use cases where you use some abbreviations and their full forms. For example, if you want to use here an abbreviation of, let's say, WHO, and inside this you can define the value as World Health Organization. So this is just a toy example I'm giving you, where you will have use cases where you want to define a constant, but you want to define an internal value of it, which is to be read by your application elsewhere. But everybody who wants to consume this enum can just use this particular keyword. And if they want to get the value, they can get the value as well. So this is the use case where you might need to define values of your enum types as well. But whenever you have to do that, if you want to fetch the value of an enum type, you have to write some extra code which is written here. If you are not defining the value of your enum types, your enum can be as simple as this. You don't need to define anything else apart from just defining the constant of the enum types. I'm giving a more complex use case so that it covers both of the things of using just the constants and also using the values. So if you just want to read the constant, you can just say color.red or color.green or color.blue in different classes, and you will be able to refer to the enum types or use the enum types. But if you want to refer to the value of the enum type, then probably you need to call this method called getValue. So whenever you define a value, what you would do is you will define a private member variable inside the enum, which is defined here. You can name it anything if you want. You define a constructor where you set this particular value, and then you define a getter. So whenever some consumer application wants to refer to the value of your enum type, they can call this getValue method to get that. So this is the enum. Now let's see how we can use this enum. For using this enum, I have this main class where I have a public static void main method, and you can simply fetch the enum types by writing the code like this. Just write the enum type holder and then type the enum type. So let me show you how this is done. If you just put a dot here, you will get all the enum type options. So I've defined 3 enum types, red, green, and blue, and I get all the options. So whatever option I want to choose, I can just select here, and I can store this inside an enum variable. So if you want to just refer to the name of the enum, so this C1 is holding color.red or red. So if you want to refer to this, just this red, then you can call the dot name method on the C1 variable. So if you say C1.name, it is going to put or print the red in caps. And if you want to fetch the value inside the red, remember the value is red in small caps. So if you want to refer to the, or if you want to fetch the value of the red, then you call the getValue method, which we have defined here. So that's what we are doing here in this first 2 sysouts, where we are printing the red enum name and then printing the red enum value. Now you can also iterate over all the enum types. And for that, you need to call the .values method on the enum. So you can just say color.values, which is going to iterate over all the enum types. And you are just storing each of the enum type in this color placeholder. Then you can either call getValue to get the actual value of that enum type, or you can call the name to just print the name of the enum as well. Both of the options are available. So let's just put it back to getValue and let's run this code. So if I run this application, I get some output here, which looks like this. First sysout says red enum name is red in caps because we are calling the name method. Second says red enum value, which prints red in small because we are calling the getValue method. And then we are iterating over all the enums. So I had 3 enum variables here, red, green, and blue. And I'm going to iterate over all of them one by one here, printing their value and not the enum constants. So that's why you see the red, green, and blue here in small. But if you just want to print the enum constants themselves and not their values, then you change this to .name, and then all the enum constants will be printed here. So this is how you can create enums and use enums for the constants which are never going to change in your application. Let's get started with annotations in Java. Now, annotations is a bit advanced concept, so let's understand why we need it. There would be some cases in your application where you need to provide some metadata information to the Java compiler. Now, this sounds a bit complicated, but it's much simpler than that, because you might not want to code everything with a lot of lines of code. Rather, you want to give some smart instructions to the Java compiler so that they understand what to do. We have already seen some of the annotations, but the basic idea of annotations is to provide some shorthand metadata information about the program to the Java compiler. Generally, annotations will not have any direct effect on the operation of the code they annotate, but they provide additional logic to the code. That's the idea with annotation. Remember, they are shorthand metadata. The main use is providing information to the compiler, or providing some compile time or deployment time processing, or also providing some instructions for runtime processing. We have already seen some of the annotations. If you remember, when we were dealing with inheritance, we had this override over the methods, right? This override is an annotation. This annotation, if I show you what I'm talking about, if I take you back to one of the inheritance example or the method overriding examples, and if I open the mountain bike class here, mountain bike extends bicycle, you will see this override annotation. This is an annotation. An annotation always starts with @ in Java, and the annotation name is override. Now, this override is just a shorthand to tell the compiler that, hey, I am overriding this method from the base class. That's what this annotation does. If you remove the annotation, in some cases, the Java compiler might not understand what to do, and the Java compiler has to do some extra processing to figure out that this method is actually being overridden. But if you put this @override here, then the Java compiler pre-hand will know that this is coming from the base class. So you save some of the compiler processing time as well by using the annotation. It's a shorthand providing instructions to the compiler. You see exactly what I'm talking about. So this is one of the annotations which we have used, but we will look at some of the other more generic annotations, and we will also see how we can build our own custom annotation in Java. You might have also seen some other annotations, like, for example, you can put @suppress warning annotation, which is a very popular annotation to suppress any kind of yellow warnings in your code. Generally, we do not recommend doing that, but if you have a use case, then you can use @suppress annotation as well. There are some other annotations as well, like @author. If you want to put your name as the author of a particular piece of code, then you can add this metadata so that whenever somebody looks at even the documentation of your code, your name will be shown there as the author. So that's the idea with annotations. So let's see how you can build your own custom annotation. Whenever you have to do that, there are multiple ways to doing that. And the first type of annotation we are going to have a look at is called marker annotation. A marker annotation is just an empty annotation without having any metadata logic at all. You can see I have defined an annotation here. I will talk about what all this means, but inside the block, there is no code here. And this is how you define a marker annotation. Marker annotation is just to provide very high level instructions to the compiler. And the way you will write your custom annotation is you will put an access modifier keyword like public. Then you will write @interface. This is the keyword which you have to use whenever you're trying to create your custom annotation. Marker or no marker doesn't matter. Whenever you define your annotation, you have to use @interface. Once you do that, then you provide a name for your annotation, which can be anything, but still not complete. You need to also provide more instructions to the compiler or the runtime processor to tell them when to execute this annotation and what the annotation type is going to be applied upon. So at first you specify when this annotation is going to be active or executed or evaluated. So here you can say @retention, which is another annotation. So you say @retention, and then you say retention policy dot whatever you want to write as. You can write it as runtime, or you can write it as source. If you write it as source, then it is going to be applied at compile time. And if you select it as runtime, then the annotation is going to be processed at runtime. So this is the first thing which you need to provide. The second thing which you need to provide is where this annotation is going to be applied. Whether you want this annotation to be applied to a class or to a method or to a member variable or to any other type. And that's what you define in the @target annotation. You specify the target audience for this particular annotation. And here inside the element type, you will get multiple options. You can apply this annotation to a constructor, to a field, local variable, method, module, package, record component, type, etc. So here I'm going to use type, which means it can be applied to a class or a generic element type, which generally means class type, and that's all. You can define your marker annotation like this. But generally these marker annotations does not have any logic, so you will not get much value out of it until you have very special cases. But if you have a case where you want to also run some business logic or provide some metadata logic to the compiler while defining the annotation, then you can define your annotation like this. So I've created one more annotation here, which is called my custom annotation. Again, the target audience for this is method. So this annotation can only and only be applied to methods. If you try to apply this annotation to a class, you will get an error. The retention policy is runtime. It means it is going to be processed at runtime. And I've declared a method here, which is called int value. So this is how you will declare your annotation. Now let's see how do you use this annotation. So I have a class called as my class here. And if you look at this structure of the my class, we create the class and then I create a method, which is named as say hello. And I am applying this annotation on this particular method. Remember, the target audience of this particular annotation was method, so it only be applied on method. If I try to put this on the class type here, then I get an error here. It says the annotation my custom annotation is disallowed at this location because the type specified is of type method. So the compiler will not allow you to use this at an illegal place. So you write any method and you apply your annotation, but you provide a value to the method. The int value method is going to consume this value. And inside the method, you can write any other logic. So let's see how this pans out. I create a public static void main method and I create an object of my class. So my class h equal to new my class. And after that, I'm saying h.getClass.get method. I'm basically calling the method by using reflection API. You can also call the method directly if you want, but this is how you need to call it if you want to use the annotation property value, if you want to fetch the value of the annotation. So this is just an example of me showing you how you fetch the annotation. So we created an object and then we say get class, which is going to return my class type, and then get method is going to return the method type, which has the name say hello. So this is a way to fetch a method name or a method type from a class using Java's reflection API, which is an advanced API. You might not need to use it, but for the sake of demo, I'm using this. So we fetch the class and we fetch the method. It is going to search the class for a method named say hello. If it finds the method, it is going to return the method in this variable. And then you can call method val, which was this variable, dot get annotation. Give me any annotation which is applied on this particular method. And you supply the annotation class type as well. Once you do that, you get a my custom annotation reference type. And then if you call the value method on this, you will get this value as 10. So this is a way where you can apply an annotation and you can actually see the effect of the annotation. You might not always want to do this because, like I said, these are metadata instructions to the compiler. But if you have a need to actually see what your annotation is doing, you can use the getClass.get method to first fetch the method, store it into a method type, and then call get annotation, supplying the exact annotation class type, and then you can call the exact method which is defined in your annotation. Here I've defined it as value, so I'm just calling the value method. So if I run this particular example, I get the value as 10. So I'm able to see or fetch the exact value which my annotation metadata is holding at the runtime. And this is the power of annotation. They're a very powerful concept and they're a very advanced concept. There would be very rare scenarios in your application where you need to create your custom annotations. Generally, you will be better off with your predefined annotations which are provided in Java, like @override, @author, suppress warning, etc. Let's get started with serialization in Java. Now, before we go further, let's understand why we need the concept of serialization. When you will be building the enterprise grade applications in different organizations, you will often have a use case or a need to send an object from one application to other application which is deployed on some other machine. So if you have a network of computers or if you have a lot of different complex setup where you have a producer application and you have a consumer application. Producer application produces the object, and then this object gets traveled over the network lines, over the network wires, and reaches at the consumer application. And how does the consumer application receive the object and how does the producer application sense the object? because when the data travels over the network lines, it will be all bytes. So how do you convert a Java object into bytes, send it over network, and then the consumer application has to again convert that bytes back to an object representation and then store that or use that inside its application. So you need to do this whole conversion, right? So the process of converting an object to a byte so that it can be sent over a network is called serialization. And the process of converting back the byte from the network to a Java object is called deserialization. So generally, you may have a use case where you serialize an object, create a binary representation of it, send it over the network. And that's where the Java serialization concept kicks in. Whenever you're using the serializable interface, so you need to extend your objects from this serializable interface so that those objects themselves becomes serializable. You need to tell Java that this object is able to serialize itself and deserialize itself. And the way you will tell Java is by letting that object implementing the serializable interface. Let's have a look at an example of this serialization and deserialization to understand this concept better. So here again, I've used the same student class where it has the name, age, and address. So you can see I have created a student class, but the student class implements serializable. This is something which you have to add to your class. Second thing, the moment you do that, all the modern day IDEs like Eclipse or IntelliJ will ask you to add a serial version universal ID to this particular class. This is added so that Java can uniquely identify your object once it is serialized and deserialized. And it will also keep a versioning track of it, right? Because if somebody hops over the network line and change the representation of your object, and the consumer application will get a completely different object copy now. So this is Java's way to make sure that the same version which the producer application is producing is received by the consumer application. So it's also sort of a security feature. It basically, whenever you do an update onto the object, it is going to increment this serial version UID by 1. So when you create the object first time and you serialize it for the very first time, the value is going to be set as default 1. And as you mutate the object again and again, before deserializing it, the count will just keep on increasing. So that's how you keep a track of the state of the object which is being serialized by adding this long serial version UID. You can also specify your own value if you want to. By default, Java initializes a value of 1, and this is a long type variable. So that is the only new thing which is happening the moment you do implement serializable. After that, I have the same fields here. I have the constructor and the setters and the getters. And I also have a toString method just to print the object nicely, where I print the name, the age, and the address. So let's look at a main class and where we use the student object, we serialize this object, and then we deserialize this object. So what is happening here is I create a class, I create the main method, and I create a student object. This is something which we have already seen. Then I want to store the state of this object. When you serialize this object has to be either sent to a network. But since I'm running this demo on the same machine, what I will do that I will serialize this object onto my local file system. It's the same thing, right? You can put it somewhere and then fetch it from there. So either you can send it over the network or you can put it on a file system. So I create the object and then I need to store this into a file. So far, I have not covered the file handling operations. So we will not go deeper into the file handling classes here, but I will just explain you the reasoning for it. And when we'll do the file handling session, there I will go in detail about the file handling classes. So I specify a file name where the serialized representation of my student object is going to be stored. And this is the location where I'm supposed to store this. Then I create two different classes, which is for writing to the file and then creating an object for it. So that's what I'm doing here. We can ignore this particular part where I'm just supplying the file name, and we can focus on this part, this line, where I'm saying write the object, the student object, to this particular file. That's what I'm doing here in this 3 lines of code, that I'm writing the student object to the file. So when Java has to write this object to the file, it is automatically going to serialize it. That's the only way Java can write an object to the file. So you serialize the object, and then you print that message that the object has been serialized. Again, you can ignore this part as well. Like I said, we will not focus on this. But what we technically did is we just wrote the object to a file by serializing it. Then I try to deserialize it. So I load this same file into the Java JVM, and then I read the object. And the way I read the object is by using this object input stream class. I supply the file that read this particular file, and then I call the read object method, which is going to return an object, a general object. When you call the read object method does not know that it is a student type object. So you need to explicitly cast this to the student type so that you can store this as a student object. If you do not cast this, you will get an error because, like I said, read object does not know anything about the student class. So what does this mean is that when you serialize an object, the class type information is lost. You cannot store the class type information when you serialize an object, because the moment you call this write object method from the object output stream class, so you created this object output stream class, you supply the file output location, and you call the write object. The moment you call the write object, it's just any Java object for this Java program. The signature of the student class is lost. It does not know that it's a student class anymore once it is being serialized. Similarly, when you deserialize it, the serialization API has no idea about what student class is and what student object is. So you need to tell the read object method explicitly that, hey, you are reading an object of the student type. And that's how this line works. Once you explicitly provide the casting operation. Once you have casted it, we try to print the same deserialized object to see if all the state which we stored in the object is still persisted there or not when we deserialize it. So our major focus in this particular class is this object output stream classes and the write object method. These are the two most important statements which you need to take care of. The file output stream is basically a file location. What is an output stream? We will talk about that later, but whenever you need to serialize, you need to use this particular class called object output stream. So that's all I'm doing here. I'm serializing the object with these values, and then I will deserialize and I will again print the object to see if these values are still there or not. So let's run this application. So when I run this application, let's start from here. First, this sysout gets called, which says object has been serialized. So you see object has been serialized. And what I serialized was this student object, which had the value of name as John, age as 25, and the address as 23 East California. And that's what gets printed here. Then this whole block gets completed. This whole try block gets completed. It's a standard try catch block. You see, I have also added the IO exception. You need to do that because these file operations will force you to catch or throw the IO exception, which is a checked exception. That's why it will force you to do that. Then we move to the deserialization block, where we create an object of the object input stream class, and then we call the read object. We cast it to the student type, and then we print the object. So when I print this object, this line gets printed, object has been deserialized, and then I can see that the exact same state is still there. The name which I set in the object is still there after being deserialized. The age and the address is exactly intact. So this is how you can serialize an object, send it anywhere you want, and then the consumer application need to read the object and cast it back to the student type, and they will be able to see the exact same state which you saved in the object just before serializing it. What if you have a use case where you have a property in a student class or in your object, but you do not want that to be serialized? That's also a use case where you may have 50 different properties inside the student class, and one of the properties is something which you do not want to serialize because you do not want the consumer application to see that value. If you ever had that scenario, use the transient variable. So transient is again a keyword, and the moment you put this keyword in front of a member variable, that variable becomes transient. The use case of transient variable is that if you do not want this X to be serialized and deserialized, then you put the transient keyword in front of it. The normal member variables will automatically get serialized and deserialized when the object is serialized and deserialized. But if you have a use case where you do not want a particular member variable to be serialized or deserialized, put transient in front of it, and then have the getters and setters for this X variable. And let's use this and see if this actually gets serialized or not. So I created the student object and let me call student.setX, and let's put a value to X. Let's say 10. So I have set the value of X is 10 and X is a transient variable. And then I am serializing the whole object here, and then I'm deserializing the object. And let's see if I'm able to fetch the value of X after deserializing the student object. So I'm calling the system.out.println, and the deserialized value of X is object.getX. Let's see if I'm able to see the value of X or not. So let's run this application again. So this is exactly the same as before. This is also exactly the same as before, but I see the value of X is 0. Remember, I set the value as 10 before serializing it, but I don't see the value 10 anymore when I deserialize the object because it was transient. If you remove transient from it, then you will be able to transfer or travel this value of 10 between serialization and deserialization. So if I just remove this here, don't change anything at all, and I just rerun the application, this time when I deserialize the object, the value of X as 10 is still present there even after deserialization. So this is how you can use the transient variables if you want to not have that object serialized or deserialized when you're doing the serialization. Let's get started with concurrency and threads. The reason I want to talk about concurrency, because once we understand about the concurrency, it will become much more simpler to talk about threads. And the idea behind concurrency is very simple and plain. And that idea is that as a developer, when you write a program, you would expect the machine or the computer to run multiple tasks in parallel. For example, right now, I'm recording this video on a particular laptop, which is recording my voice, which is also recording the screen, which is also running the Eclipse IDE and also running a Chrome browser. It also have opened multiple background applications. So there are a lot of tasks running in parallel at the same time. And that's the idea about concurrency. Now, how do we work with concurrency in Java is with the help of processes and threads. So these are the two basic units of execution when we talk about concurrent programming in Java. And when we talk about processes, you can think of a process as basically an execution environment, or I should call it as a standalone execution environment. Think of a logical box which is completely cut out from everything and it has its own environment. For example, again, the recording software is running in its own execution environment. And when we talk about process generally has an everything or a private set of all the runtime resources it needs and the memory space it needs. Now, there's another concept or another construct which is very important is threads. So threads are also sometimes called lightweight processes. And basically, when we talk about threads, a thread also has an execution environment, but creating a new thread requires a lot less resources than creating a new process. And you can also think of threads as a mini version of a process because a process can have multiple threads. Remember that statement that a process can have multiple threads. Threads always exist within a process. And whenever you start a process, there will be at least one thread attached to it. And each thread is basically a task. For example, the voice recording can be a process, and inside that, the mic recording expression or the mic recording task can be run by a particular thread. Let's take another example that when you play games, let's say you're playing a racing game. So when you play the racing game, there are multiple things happening at once. You see the current speed of your car or bike on the screen. You also see your leaderboard position, what ranking you have in the race currently. You also see some other kind of features like player's health or the car's health or the fuel consumption available and lots of other stuff. The graphics, the motorcycle, the other competitors' bikes and their speeds and their distance to you as well. So if you see, all of these are running on different threads. There's a different thread to show your current speed. There's a different thread to show the current leaderboard position. There's a different thread to show the fuel indicator, etc. Everything is running in a different thread. So all of these threads need to run at the same time in your program for a complete immersive user experience. And that's what we mean when we say multi-threading, that we want multiple threads to run at the same time to create a better experience in the application. So that's basically the theoretical part of it. Please do read more about how threads work and how processes work. And there's a lot more documentation available in the Java docs as well when we talk about threads. But I will keep the theoretical part to this particular point. And now we will move to an Eclipse example to see how we can create threads. So with that, let's move to the Eclipse IDE. And here I have a demo prepared basically. So what I have here is a threading demo class, which has a public static void main method, and it has a simple for loop. And inside the for loop, I see this strange code here where I am initializing two threads and starting them. So that's all I'm doing here. But let's see how this thread1 and thread2 class have been written and why do I see two different ways of initializing them. Let's go deeper into this now. So let's see how thread1 can be created. So first of all, you can create a thread by just creating a simple class, but make sure that you extend it with the pre-built thread class. This thread class is coming from Java. So from the JDK basically. So the moment you extend your normal class from the thread class, then you will have to override the run method. So if I show you the thread class here, this is the thread class implementation available inside the JDK. And this is the class which is getting called when you are extending it from the thread class. And this thread class will ask you to override a run method. Here the override annotation is missing. So let me just add this for better understanding. So you need to override the run method. And this is something which you need to do so that you can specify what happens when you run the thread. So this run method will be called whenever the thread is running. At this particular point, I would also like to tell you that there are different states in the thread. So there is a thread which says thread is ready. Then there is a state which says thread is running. There is also a state where the thread is waiting for an IO input from the user from the console or the command line. There can also be a state which says dead, where the thread has completed its task and it's not working. There can also be a state which is called sleep state, where the thread is paused. So there are different states of the thread. And in this example, we are going to focus primarily on three states, which is the ready state and the running state and the completed state. So when you call the run method, the thread state is going to change to running. And whatever code you write inside this particular run method will be the logic which this particular thread is supposed to execute. Here, I'm just putting a dummy logic where I'm just printing a sysout. But definitely, if you try to create your threads, this will contain your actual business logic. For example, that fuel indicator code or for the leaderboard position code will go inside this run method. And then I'm catching an exception if there's an exception, but obviously there will not be an exception coming in because I have nothing here literally. So that's what we are doing when we are creating this thread1 class. And let's come back to the threading demo now. So to initialize a thread, or initialize might not be the right word, to run a thread, the first thing which you need to do is to initialize the class containing the run method. So I would avoid calling this class as thread because technically this is just a class. So you basically create an object of the thread just like you create the object of any other class. There's nothing new here, right? So we just say new thread1 and then we call t1.start. Now, if you observe carefully, there is no start method here. We just had a run method, but this code is still compiling fine. And I'm calling the start method here because the start method is the internal method of the thread class, which in turn is going to call the run method. So you are never going to invoke the run method directly. You just need to start the thread, which is going to change the state of the thread from ready to running. So the start method has the responsibility of changing the state to running. And the way the start method is going to do that is by calling the run method internally inside the JDK itself. From developer perspective, you just need to call the start method and that's it. The thread will start running and whatever is present in the run method will get executed. So that's the way to start the thread. Second thing, I have one more thread created here, which is the thread2 class. So in this case, when I create a thread2 class, I'm not extending it from the thread class. Rather, I'm implementing the runnable interface here. So this is a different interface available, which is a functional interface, which means it will have just one method, which is the run method. But the interesting thing is that here, when I created thread1, I said extends thread. But here, when I'm creating the second thread, I'm not using extends thread, but I'm using implements runnable. Let's understand why do we do that first of all. The reason Java provides two different ways of creating threads is because there might be a use case that you need to extend your thread to class from some of your custom Java class. Remember, Java does not support multiple inheritance. So at a time, you can only extend this class from one class. So what if there was no runnable interface and you need to extend this thread to from student class, let's say. So you need to do class thread to extends student, for example. The student is not present here, but let's assume it is. So you do this, and then you also have to extend it from thread. Now, Java doesn't support multiple inheritance and this will not work. So what would you do if you have to also create it as a thread, but also extend it from some of your parent class? You will not be able to do that. And that's the reason Java provides the implements runnable, because then you can extend it from any of your superclass of your interest, and at the same time, also implement it with runnable interface so that you can treat this class as a thread. So that's the reason Java provides two different ways of creating threads. Remember that it's a very important concept. And once you implement runnable, again, it will ask you to override the run method. So I will just put override annotation here. So once you override the run method, again, you can write whatever logic you want this particular thread to execute inside the run block. Coming back to the main class. So when you are extending from thread, the initialization is very simple, where you create the object and you call the start method on the object. But if you are creating a thread by implementing the runnable interface, the initialization of the thread is a bit different. And it's different in this particular part. On the left hand side, you still say thread T2. Remember, you are saying thread and not thread 2. This is the Java thread class. This is the JDK thread class, not your own thread class. So you say thread T2, then you say new thread, and inside the new thread, you provide your own class type. Thread 2 was your own class type. So you specified your own custom thread class here inside the new thread constructor. This thread class is the JDK class. If you click on this, you will see this is from the JDK class. So that's the difference. Extending thread, simple initialization, implementing runnable interface, do the initialization like this. And after that, you call similarly the start method, which is in turn going to call the run method. So that was how you create threads differently. And now let's run this program to understand how the output looks like when we run these threads in loops. Remember, I'm initializing 10 instances of each of these threads. So in total, there would be 20 output lines. So if I go to run as Java application, I see this output here. So let's observe this output for once. So thread 1, thread 2 is running in sequence in the first time, but then you see thread 1 is running twice, and then thread 2 is running twice. Then again you see a good sequence, but again thread 2 has run twice here. Again thread 1 has run twice. If I go further down, thread 1 runs once, then again thread 2 runs twice. Thread 1 runs once, thread 2 runs once. So there is no particular order here, though based on the code which we have written, we should expect thread 1 is running from here and then thread 2 is running output from here in a sequential fashion. But we don't see the sequential fashion here. And this is the power of concurrency. This is because threads never run in sequence, they run in parallel. And which thread will execute first, you can't really predict that. So so be very careful whenever you are writing multi-threading code, because you cannot predict the sequence of execution, because threads are going to run whenever they find the idle CPU. So the key is the idle CPU. Whenever a thread finds an idle CPU, it is going to occupy that CPU and going to run its own execution. And the moment its execution finishes, the other thread will jump in and take a piece of the CPU. So whichever thread gets the idle piece of the CPU is going to execute. And that is the reason you see this randomized output. The next time you're going to run, you will see a different random order. So this time you see thread 1 ran 4 times. You did not see this in the previous execution. If you run it again, you will see again a different output. This time the thread 1 ran thrice. So every time you will run this, you will see a different sequence. There is no guarantee of order because the threads are running in parallel and they're running whenever they get the idle CPU. That's the bottom line. So this is how we are going to create threads. And remember, you cannot guarantee the sequence of the execution. So write your code accordingly and use the threads for independently running parallel threads which do not depend upon each other. Let's get started with thread synchronization in Java. So in the previous example, we saw that when we execute threads, then we can't guarantee the sequence. But it's actually technically not a problem in the example which we had a look at before, but it can become a bigger problem when two threads are trying to access the same object. Remember, object has properties and state. So what if the first thread modified the object state and the second thread is reading the state of the object? The second thread is expecting the original state, but while it was trying to read it, the other thread modified its state. So you can see this can become a big problem. For example, if you are working with a banking system and if there are two persons accessing the same account at the same time, one is depositing the money and one is withdrawing the money from the account, and if the total balance is 1,000, and if both of them deposit 500 and withdraw 500 at the same time, then who sees what? And if these are handled by two different threads, then we can't guarantee if somebody sees a 1,500 as the total sum or somebody sees a 500 as the total sum, or there can be a scenario where somebody sees 0 as the total sum. So the application can turn into really weird scenarios if two threads are trying to change the state of a particular object at the same time. And Java provides a solution of it with the concept of intrinsic locks and synchronizations. So the idea is that when a thread tries to work on a particular object, it basically takes a lock on that particular object. We also call this as an intrinsic lock or monitor lock. So it takes a lock on the object, and it means that that particular object becomes completely inaccessible to other threads in the system at that particular time. So the moment you put synchronization or you put lock on a particular object, only the thread which has taken the lock will be able to access the object, and other threads will be forbidden from accessing the object. So that's the idea behind intrinsic locks and synchronization. So that was about the brief theory of it. Now let's have a look at a practical example. So I have prepared another example for it. So here I have again created two threads, but these two threads, it's pretty much the same threads which we covered in the previous session, named as thread 1 and thread 2. One is extending thread class and other is implementing runnable. But that's same, but the interesting part is this. Both of them have a reference to a class called mathutils. If you see, thread 1 also has the reference and thread 2 also has the reference. And what the mathutils is doing here is basically you supply a number and it prints the multiples of it till 5. So for example, if you supply 2, you will get the output 2, 4, 6, 8, 10. If you supply 3, you will get the multiple of 3 up to 3 times 5. So 3, 6, 9, 12, 15. If you supply 4, you will get the outputs in the multiples of 4 till 20. So whatever number you will supply, you will get the next 5 multiples of that particular number. That's what this class is doing. And another interesting thing which I've done here is this thread.sleep, which means that when you run this loop where you are printing the multiples till 5 of that number, every time you do the first multiplication, then you sleep for 400 milliseconds. And when I say sleep, it basically means the current thread is going to pause its execution for 400 milliseconds, and it is going to leave the CPU idle. And if there is another thread running currently in the system, that thread will get the share of the CPU for that 400 milliseconds. And once the 400 milliseconds is finished, the thread is going to wake up and it is again going to hunt for the idle CPU to pick up and start doing its execution. So that thread.sleep happens for 400 milliseconds at every step of this iteration in this for loop. So thread 1 is going to use this particular method of this particular class, and it is going to ask the class to print the multiples of 2, and thread 2 is also going to access the reference of the class and access the get multiples method, but this thread asks to print the multiple of 3. So thread 1 asks for printing the multiples of 2 up to 2 times 5, and thread 2 wants to print the output to multiples of 3 up to 3 times 5. So that's the basic scenario. Two threads accessing the same object, supplying different values and expecting the output. So if I run this demo as is without any change, here I'm just initializing the mathutils class, initializing two threads, and then calling the start only once. So if I run this particular program, I see this strange output that even when I said t1.start first, so t1 was holding the multiple of 2, remember, but I still get 3 first, then 2, then 4, 6. So multiples of 2 gets executed here, but then the other thread takes the CPU and it starts running its own multiples outputs. And you see 9 printing first, and then 6 gets printed, then 12, then 8, then 15, and then 10 at very last. So the output looks very random. It would have been nicer if I could have seen 2, 4, 6, 8, 10 once, and then 3, 6, 9, 12, 15 once. If I see them in different sections, in different sequences, that would have been so nice, because then I know which thread is running when and when that particular thread is working on the object. So I'm just trying to replicate the same scenario where two threads are accessing the same object at the same time, but they are executing the object randomly. They're changing the state of the object randomly here. So how do we fix this? To fix this, we can so we have this get multiples method, which is the bone of contention here. This is the method which is being randomly accessed. So what I can do here, that I can put synchronized keyword in front of the method. So once you put the synchronized keyword in front of the method which is being accessed by multiple threads at the same time, this whole method gets synchronized now. What this means, that one thread will be execute this method at once. There will never be a scenario where two threads are simultaneously executing this get multiples method, or even getting a hold of this get multiples method at the same time. There would be only one thread at a time executing this method. So if I put the synchronized here, and if I rerun this example, you see I get a more streamlined output. If you notice, everything is running like clockwork, where first the thread 1 gets executed. So I get 2, 4, 6, 8, 10, really well printed. And then the second thread starts, which says 3, 6, 9, 12, 15. The reason I get this output is because when I did t1.start, it immediately went to execute the get multiples method, but it saw synchronized there. So it took a lock on the method, and even when the t2.start might have got executed maybe milliseconds after that or nanoseconds after that, it still could not get hold of the get multiples method, because thread 1 occupied this particular method. It took a lock on this particular method due to the synchronized keyword. So that's the power of synchronized keyword, that you can take a lock on a particular method if you put it in front of the method. Now there can be scenarios that you do not want to lock the whole method. You still want two different threads to access the method, but there can be very few lines of code inside the method which is thread sensitive code. Now, how do you spot thread sensitive code? There is no magic bullet, there's no silver bullet for it, and it comes with experience. So you need to have that experience to know which is the thread sensitive code which can create problems if two threads run that code at the same time. So the moment you have spotted that code, and if you don't want to lock the whole method, you can lock the exact lines of code by putting the synchronized block. So if I remove this and I enable this particular part, so what I'm doing, that I know that this is the code which is exactly causing the problem, which is creating this random output. So what I can do, that I can put the synchronized keyword right before the block of the code starts, which is thread sensitive. And the way you do that is you write synchronized and you supply this, which means whoever has the whoever has the object of the math utils, that whole object gets logged for this particular block of code. So whoever has the math utils object takes the lock on the object for this particular block of code. If there was some other code which was written in the get multiples method before the synchronized block or after the synchronized block, that block can be accessed by multiple threads at the same time. But this code will only be accessible to one thread at a time. There will never be a concurrent access to the synchronized block. That's the power of synchronized block, and it will work the exact same way. So to show you, if I run this particular program, I still get the output in the same streamlined way, where first the multiples of 2 get printed and then the multiples of 3 get printed. So that's how you can actually use synchronized methods or synchronized block to make sure that one thread is accessing a sensitive object at a time, and there will never be a scenario that two threads are mutating the same object at the same time. Again, like I said, be very, very cautious of when you use synchronized blocks and when you use threads, because threads have unpredictable execution sequence basically, and synchronized blocks also have problems. If you have thousands and thousands of threads running in your application, and if you put synchronized on a particular method, your application may face severe performance issues because all of the threads will be executing that method in a sequence. Imagine you put this onto a huge application or a huge e-commerce application or a news website. it is going to create serious performance issues. So be very cautious of how and when you use synchronized method. And the key to that is to have that developer DNA to spot the code which is causing this problem, which might be thread sensitive. And maybe you might need to change the code itself. You might not need to go into the multi-threading scenario, and you might be able to fix it without using the threading or synchronized concept. It completely depends. But always have a good trade-off when to use the synchronized methods and synchronized blocks. Let's get started with auto boxing and unboxing in Java. So if you remember, in the very first sessions, I talked about the primitive data types, and then later on, we talked about the objects. For example, we had the int data type, but there later we also saw an integer data type, which can also pretty much do the exact same work which int data type was doing. And we saw the similar kind of experience for the float data type and the float class, double data type and the double class, char data type and the character class, and so on and so forth. So Java provides an easy way to convert a int data type variable into an integer data type variable, and also back from integer data type variable to an int primitive data type variable. Now you might be wondering why we need that. There would be scenarios, for example, if you had an int array as a primitive int array, and if you want to store that into a collection, now collection can only be of type of objects. It cannot be a type of primitive data type. So you might need to convert this int primitive data type array into an integer object collection. So you need to do this conversion of int data type to integer data type. And there would be cases where you might need to do vice versa. So that's the basic idea about auto boxing and unboxing. So when we talk about the definition, you can see auto boxing is the automatic conversion that the Java compiler makes between the primitive and their corresponding object wrapper classes. So whenever you are converting a primitive data type to an object class, this is called auto boxing. And when you do the reverse, it is called auto unboxing or simply unboxing. So let's understand this with the help of an example now. So I'm just going to open an example about auto boxing and unboxing so that we can have a look at it. And here it is. I've created a class which is called auto boxing demo. It has a public static void main method, and inside the method, I'm first simply declaring an int data type variable I with the value 10. Then if I need to auto box this, if I need to convert this primitive value into an integer object wrapper class or an integer class type, then I need to write the code like this, which says integer dot value of, and then you can supply the primitive data type value, and the output of it will be of type integer class. So you get an integer object, and then you can print the object to check if it is successfully doing the auto boxing or not. Similarly, doing the other way around, once I have converted this into an integer object, let's convert this back to a primitive data type. So from integer object, I'm converting this back into the primitive data type. And you see here, it's a simple assignment. I just have to assign the object to the primitive data type, and that's it. I can do the same for a character object and a char data type. So first I create a character object, char obj, and then if I have to unbox it, I can simply assign this char obj to a char primitive data type ch, and that would be it. So you can do the similar drill for any other primitive to object wrapper conversion. Let's say you want to convert a float data type to a float class, or you want to convert a double data type to a double class, then whichever primitive data type has an object wrapper class, you can do the auto boxing and auto unboxing like this. Remember, whenever you have to do auto box, it means you're going from primitive to object. And for that, you need to call the value of method. For example, if you are converting a double primitive to a double object class, double object type basically, then you are going to call double dot value of. And similarly, the same kind of behavior will be seen for other object wrapper classes as well. So for auto boxing, you call the value of, and for auto unboxing, you literally just assign this to a primitive, and the object wrapper class value will automatically be assigned to the primitive data type. So let's run this now and observe the output. So I had the int I equal to 10. Then I wanted to convert this primitive into the object wrapper. And the way I can do that is by calling the value of method and supplying the primitive data type's value. So that's why I'm doing it. That's what I'm doing here. And this I obj should get the 10 value now, which I can see if I print the sys out, and if I just print the integer object altogether, I get the value 10. So this concludes that I've successfully am able to auto box the primitive into an integer object. Now looking at auto unbox, like I said, you simply can assign the object wrapper to the primitive data type variable, and that should work as is. And that's why at line 15, we get this output which says value of I1 is 10. Similarly, when we try to auto box the character object, so I have created a character object here, and then I want to unbox this back into a simple char data type ch. So when I print ch, I get the same value, and when I print the char obj, I again get the same value. Remember, the reason I've put this as auto box is because this by default is being stored into a char data type. I can also write it like this. For example, I can say char x equal to a, and then I can refer here as character dot value of x. This will pretty much have the same impact or the same effect which I had just now. It is going to print the exact same output. If I rerun this program, I'm going to get the exact same output. So this basically concludes our understanding that you can use the auto boxing and auto unboxing pretty easily whenever you have a scenario where you want to convert the primitive data types to the object wrapper classes, or you want to convert the object wrapper classes back to the primitive data types. Let's get started with using JDBC in Java to connect to the databases. In this example, I'm using the open source community edition PostgreSQL, but you can use any database vendor provider if you want to. If you want to use Oracle or MySQL, feel free to do that. But in this demo, I'm going to use Postgres. So you can download the Postgres Windows installer. Since I'm using a Windows machine here, you can download the installer from the official postgresql.org website. And you can also download the JDBC driver for PostgreSQL going to this particular official website, which is jdbc.postgresql.org. Similarly, you will be able to find the JDBC driver for all other database vendor providers as well. Once you download this, this is going to download a jar for you, and you can store the jar anywhere. Like I've put this jar into this particular location. You can see this latest JDBC driver jar for PostgreSQL. So for every database vendor, there would be a different JDBC jar which you need to download. So that's that. You install the PostgreSQL, you set up its database, and when you install the PostgreSQL, you also get a nice SQL client to talk to the database, because database has a server and database has a client, right? So to deal with that, you install the server, and all these database vendors like Postgres, Oracle, Microsoft SQL, etc., they also provide a nice thin client with it. Postgres also provides a client. When you install the Postgres server, it will also ask you, or it will actually automatically install the SQL client for it as well, which is called pgadmin. So this is how the pgadmin client looks like. The current edition of it is pgadmin 4. So you will get that installed automatically. And once your Postgres server has been successfully installed, if you just go to search and type pgadmin, you will get this option. Once you click on this option, a new browser window will be opened, and you will see this client here. You will not see this particular window. Let me close this one, but you will see something like this. You will see a server here. So you can go inside it. You will see a PostgreSQL edition here. And if you go inside it, you will see a database here. If you open the database, you will see the Postgres database by default created. So you can just right click on this and create a database here. You can name it as whatever you want. You can leave everything as is for now and hit save. Another thing which you need to do when you do the installation is it will ask you to set a database user and password. So choose whatever database username and password you are comfortable with, and you will be using that username and password in your program as well. So create your database here and just leave the database at this particular point. And now we will try to connect to this particular database. In the example which I prepared, I'm going to connect to this test database. So let's go to the JDBC demo and see what is happening there. So for this purpose, I've created a class called JDBC demo. It has a public static void main method, and there's a lot going on here. So let's take it step by step, and I will keep shuffling between the database SQL client and this particular class to build a nice narrative. So if you think carefully, what you need to have if you want to connect to a database. The obvious answer is the address of the database. Where is that database? You need to know the location of the database to connect to it. So that is called the connection URL. Every database vendor will provide its own connection URL, and you can find that connection URL from the official documentation. There are tons of examples available for it as well, but always refer to the official documentation for that particular database provider. The general syntax is JDBC colon your database vendor's name colon / the host name. This can be any IP address or your local host. Generally, we also put a port here, something like this. 5432 is the port on which the PostgreSQL server runs. But again, you can put the port here on which your database server is running. Every database vendor has their own default port. The PostgreSQL server has the default port as 5432. So you provide the host name, you provide the port, and then you provide the database name. You provide the database name to connect to. So if you remember, I told you that I have written the program to connect to this particular database called test. So whatever that be, you provide that name here. And this is going to form the connection URL. I can remove this for now, but this is how the connection string is going to look like. And it is going to, it follows the same format for any database vendor, that you say JDBC colon, you write the database vendor name, and then you say colon /, you provide the host port, and then you provide the database name. So that is your connection URL. After that, to connect your Java program to a database, you need to use the java.sql.connection class. This is very critical class and very important, and probably the single most important class which you need to have in your program if you want to connect to a database. So you say connection con equal to null. I'm just creating a null reference to it. And before we go any further, let me also tell you why we need this JDBC and what is actually this JDBC. So Java is a programming language. It does not come with its own database, but there are multiple other vendors like PostgreSQL, MySQL, Microsoft SQL, Oracle, etc. So Java wanted to provide a uniform way to connect to all of these databases. Because imagine all of these databases building their own API contract. It would have been a nightmare for the developers to connect to different databases or shift from one database to other database. And that's the reason Java created this nice interface called JDBC. And it said, whoever wants to connect to Java should follow this JDBC specification and provide their implementation, similar to the interface and concrete class thing. It's not exactly that, but you can think of it in that manner, that JDBC provides an interface with the method declarations. And then Oracle, PostgreSQL, MySQL, all these database vendors are supposed to implement that interface and provide their own implementation. But JDBC APIs will always remain the same. Whoever wants to connect to Java has to create a driver, and that driver contains that implementation. And that's the reason we downloaded that JDBC driver. And I will come to how do we include that, but that's the background of JDBC. And that's why you need JDBC to build that uniform contract, and your vendor will provide their own jar, which will have the implementation of the JDBC interface. And in this program, what I'm trying to do is basically, I'm trying to insert a record into a table. So what is a table and how do you create that? So let's go back here. So in this test database, you will see a schema. By default, you will see a public schema, and you can create a new schema if you want to, or you can just use the public schema. So inside the public schema, you will go under and you will see an entry for tables. So you just right click and you say create table. You can also write in complete SQL statement, but I'm just showing you how to do that in pgadmin. And you can give the table name, you can give the column information, and that's how you create the table. So I have created a table here, which is called student. And the student table has 3 columns: roll number, name, and age. If I show you the exact query or the whole create TDL for it, it looks like this. So I created the student table in the public schema, which has a roll number field, a roll number column, which is of type numeric. It has a name column, which is a varchar or a character varying, and it has a age column, which is again a numeric. So roll number, name, and age. These are the 3 different columns which I created inside the student table. So I have a student table with these 3 columns. So that's that. Now let's go back to the program. So I have the student table and now I want to insert some records in the student table. So let me just change the values here so that we can see a different entry. So I have just hard coded some values. Generally, you will be getting these values from somewhere in the program. But for simplicity, let's say you have got those values. Once you have got those values, the next thing you need to do is to build the SQL statement, the exact SQL statement which which is going to be run on the PostgreSQL server. So you write that statement. In this case, I'm showing you a creation example. So it is going to be an insert query. So I say insert into table name, which is student, and then I provide all the column names. It is always a better practice to provide the column names in these brackets. Even if you're inserting the values to all the columns, still provide the column names. So I say insert into table column values, and then you provide the actual values as the roll number variable, which I created here, the name variable, and the age variable values. So I just supply the values here. Remember, when you are inserting the values, roll number and age are integer, so you don't need to put any single commas, single inverted commas for it. But name is a string variable, so I've put this single inverted commas. It's a simple string concatenation, nothing fancy here. So I'm just writing a plain SQL statement here and storing that into a string. Once I've done that, the next piece which I need to do is to get a connection to the database. And the way you are going to get a connection is by this uniform method. No matter which database provider you are using, you are always going to use the driver manager.get connection method to get a connection to the database. And how do you get the connection? You supply the connection URL, you supply the username to connect to the database, and you supply the password. In this case, I've just set the username and password as Postgres and Postgres. So Postgres is the username and Postgres is the password. Pretty lame, I accept, but this is just for demonstration purpose, so it's fine. But generally, you will be getting these values from some application property file. So these are the three parameters which you need to supply to this get connection method, and then you will get a live connection to the database. This is the line which is going to make it all happen to connect to your database server. So if this line gets executed successfully, you have a live connection. Once you have a live connection, the next thing which you're going to do is to create a statement object on the connection. Statement it can be anything. It can be an insert statement or a select statement or an update statement or a delete statement. Everything is a statement there, right? So that's why you need to create a statement object. So you create a statement object and then you execute the SQL. This insert SQL which you prepared, you're going to execute the SQL here saying st.execute update. Execute update is the method which is used for any insertion or deletion operations. So that's the method you're going to use and supplying the SQL query which you built with the actual values of roll number, name, and age. The execute update method returns the number of rows affected once this statement got run on the database server or the SQL query got run on the database server. It might impact one rows if it's an insertion. It might impact multiple rows if it was an update query, right? So it is going to return the number of rows affected, and that is what we are going to use to check if my insertion successfully went or my insertion failed. So if this execute update is going to return 1, which means that my row got inserted successfully in the database. So I'm just printing a sys out here. And if this particular M returns 0, which means none of the rows were affected by my SQL query, which means my insertion operation failed. So I'm just printing a sys out here. And then I'm just putting this in a catch block here to print any error and finally closing the connection. This is again very, very important. Database connection is one of the costliest connections you will be creating when you will be writing your Java applications. Always and always make sure to close these database connections. Otherwise, your application is going to face serious database bottlenecks. So we close the connection. So that's all we are doing here. We prepare the URL. We just create a placeholder for connection object. We prepare our SQL query with all the relevant values. We get a connection to the database. We get a create statement. We get a statement object from the create statement method, and then we execute the statement. And then we can validate the statement execution if there is a way to validate it. Once you've done all of that, you close the connection. So let's run this program and see if we can see this new record inside the student table. And before we do that, let's also validate what is present in the student table as of now. So if I go here and I say view all rows. This is just going to run a select star on the student table. So currently student table has one record with roll number 1, name as John, and age as 20. And now I'm trying to insert another row with roll number 2, name as Jane, and age as 22. So if I right click and run as Java application, I get this entry which says inserted successfully, which is coming from here. Inserted successfully, and it also prints the exact SQL so that you can see what SQL actually got executed on the database server. This is the same string SQL which I built. So this is the SQL which got run on the server, which said insert into student values, and the roll number was 2, and the name was Jane with single inverted commas because this was a string, and then age was 22. This was the exact SQL which got executed. So my SQL has been executed, my connection has been closed. If I go back to the pgadmin client and if I try to rerun this query, now I get 2 records. So if you remember, this record was already there, but now I get this second entry, which is the new entry which just got inserted because I ran the program, and you see the roll number 2, the name as Jane, and the age as 22. So this was a very simple example to show you how you can do the JDBC connection. But one of the things which I still haven't covered is the usage of the JDBC driver, the jar which I talked about. So the way you are going to add the jar is you go to the project, you right click on the project, you go to the build path, go to the configure build path, and there you will see different tabs: source, projects, libraries. So go to the libraries tab and select the class path here, and you can choose the add external jars option. Click on this, load your SQL JDBC jar for your particular database vendor. For my case, it was PostgreSQL. Let me just quickly remove this jar and show you right from how it's done. So this is how it will look like for you. You select the class path, you click on add external jars, you go to the location where you have downloaded your JDBC driver jar for your particular database, select that, click open, it will come here, hit apply and close. That's how the jar is going to be there. If you don't provide the jar, your program is going to fail miserably. It is not going to work. So make sure that you have the jar, and then only it is going to be able to create a successful connection and be able to successfully execute the query. Remember, JDBC provides the specifications, and then the particular database vendor like PostgreSQL provides their JDBC driver, which has the implementation for that JDBC API. And that the Java has this uniform JDBC API, and every database vendor is expected to honor and implement that API only, so that Java developers can work on the JDBC contract and everything should work as is. Let's get started with generics in Java. So before we go about generics, let's understand why do we need generics and what was the requirement that led to the creation of generics. So as we know that when we work in any object-oriented programming language, we created classes, we create objects, we create variables, and everything has a type. Everything has a type, and that type is static. The type cannot be changed. That's why we call Java as a strong type checking language at compile time. It checks the types of the variables of the classes at the compile time, and if the classes are mismatching or their types are mismatching, then you basically get a compilation error. But what we see as we moved along, we saw that we were creating the similar kind of functionality again and again in different classes. For example, if there is a login functionality which should allow a person to log in and we should also allow an application to log in, then these are the two different use cases, but the functionality still remains the same. So how would the login functionality allow both of the types of entities, be it user or application, to get into the application or log in into the consumer application? How do you do that? And that's what led to the creation of generics, that you can reuse the same code with different types of inputs. Remember, the stress here is on the types, and that's what it is mentioned here, that we will like to reuse the same code with different inputs. We will just keep changing the type parameters and we'll keep using the same code again and again. It has some benefits over the non-generic code, like I mentioned earlier, that when we work with the non-generic code, we have the statically assigned types to the variables and objects. And if we use generics, then we don't have to do that. And at the same time, you don't even have to explicitly cast them. I already touched upon this concept of generics in different bits and pieces in different sessions throughout this tutorial series, where we saw that whenever I was creating a list, I was supplying this type into these brackets, right? And I told that this is the generic type. But now we'll go deeper into this concept and we'll see how we can create our own generic types if Java does not provide it. So with that, let's move to an example and see how we can implement our own generic types to create generic code where we can supply the types dynamically. So I've prepared an example for this. I've actually prepared two examples for this and we'll go through both of them one by one. So here what I'm doing that I'm creating any class. You can think of it as any class holding any functionality which is applicable to multiple entity types. Think of it as the same login class which I just talked about. So if your class has a functionality which should be reused by many different types, then one of the way to not repeat the code or repeat the class or repeat the functionality again and again is to make that class use a generic signature. And how you do that? You write the class name and then you put these brackets and you just type T. You can write any variable A, B, C or whatever you feel like, but T is sort of the default standard the Java developers have been using since generics was launched. So you put this T here. Now, whoever calls this class or whoever initializes this class will have to supply the type of the class on which this particular functionality is going to get executed. Now, remember the collection examples I took in the past series. What if this was a list class? Because we have used the exact same syntax, right? We use list, we put brackets, and then we wrote string, and we said, okay, now this list is a list of strings. If we said list of integer, then we just write integer in these brackets, and that list became a list of integers. So you see the same list was being reused for different data types. And the exact same concept is applied here for your custom classes and your own custom functionality. So I write T here, then I can do whatever with this T I want. So I just put a reference of it inside the class. I create a constructor. Constructor is also assigning the T type. I do a get object, and that's all. It's a very simple toy example, but just to get the point across, you can write as complex logic as you want inside the class, depending upon your use case. But this is just a straightforward example that you can use generics in the classes as well. Once you do that, then how do you initialize this class? So let's have a look at that as well. So I've just created a public static void main method inside the same class. Obviously, you can create this method outside this class as well. There's no stopping that logic. But for the sake of simplicity, I've just put the main class here. So it's a simple public static void main method. There I am initializing the single generic holder class, the same class. And here the T type is of integer. This T type can be of anything else as well. For example, your own student class can also be supplied here. And then this single generic holder will become of student type. In this case, I'm just using a pre-built Java class. So this single generic holder becomes of integer type. I give a reference, I create an object, and I provide a value to the object. Because you see the constructor is this. Whatever T you supply, so if the T is the integer, this T becomes integer, and this obj is going to hold the value 10 because that's the constructor being called here. And after that, you can do whatever you want in terms of the logic here. I just have a get object method. So I'm just calling that method and printing the object. That's all. Similarly, you can also initialize the same class with the string type. So you see, I'm reusing the same class and the same functionality again and again for different class types. So this time I'm using the string type instead of integer, and I'm supplying a string parameter this time. And this constructor still will work because this is generic. When you created with integer, this constructor, this T, became of integer type, and when you initialized it with the string type, this constructor started accepting the string objects. So I just supply a string called simplicode, and then I call get object. So let's run this method. So when we run the main method, from the first invocation at line 16 and 17, when you call the get object, the value of the object gets printed, which is 10 for the integer, and then at line 20, the value of the string gets printed, which is simplicode. So that's how you can use generics inside a class or for a class. Now, there might be use cases where you have to create a class which can accept multiple types of generic types. Let's take an example. If you remember when we talked about hash map, we had the exact same situation. So you had the key and you had the value. Now, key can be of any type, any data type. It can be string, integer, whatever. and then value can also be of any data type. It can also be your custom data types. For example, the key becomes a roll numbers and the value becomes student object. So map is a situation where you have two generic types. So I'm just trying to replicate that similar kind of behavior, that if you have to create a class with 2, 3, as many generic types as you want, you can still do that by just providing a comma here. You can go on doing as many generics as you want. In this example, I'm using 2 generics. And then it again goes to the same drill that I've created references for both T and U. I have initialized both T and U in the constructor. And then I have a display method, which is going to call the display the obj1 and obj2's values, or they're two string methods basically, because when you try to call the object inside the system.out.println method, the by default the two string method of the object will automatically get called. So that's all I have in this particular class. So it's a simple class accepting two different types of generics and then calling the display method. And here is the public static void main method for the same. Here I am initializing the dual generic class, and here the T is string and U is integer. So these T and U are assigned these class types. And then I create the class. I again write the same types and I provide the value. So for the string one, I provide simply code. For the integer one, I provide 10. This constructor gets called. obj1 gets the value simply code and obj2 gets the value 10. And then I call display method. There I am printing obj1 and obj2. So let's run this method. Okay, I'm getting simply code in 10 because when I call the display method at line 13, obj1 gets printed. obj1 is holding simply code value, and at line 14, obj2 gets printed, or the toString method of the obj2 gets printed, which is holding the value 10. So this was a quick tour to tell you how can you use generics. You can obviously use generics in the variable types as well. You can use generics in the method argument types as well, wherever you want. The simple idea is that one, you would like to reuse the functionality again and again. And second, you would not like to have a strong, strict type checking. And like I said, try to relate these generic concepts with the collection framework we listen, because collection framework is completely built upon the concept of generics. Whenever we initialize a list or a map or a hash set or a linked list or array list or anything, we always supply the type. And the type is coming from these. If you look at the implementation of array list class, you will see that. Let me see if I can open that for you to show you how that looks like. If I go to an example of collections, and if I try to just open the class, you will be able to see that. Yep. So if I click on this list class, you see list of E type. So here E is the type which you are going to supply. So in this particular case, when you say list of integer, this integer gets typed into E. So this whole list class, whatever operations you're doing inside the list class will be applied for the integer type. So similarly, you can look at other collection classes and you will always see these generics everywhere in the collection classes. Let's get started with Java.Lang package. So Java.Lang package is one of the most core and fundamental packages in Java, which is provided out of the box to the developer. You never explicitly import this package in your Java program because you don't need to. Java provides this automatically the moment you create a file with .java extension, and you are running that particular program inside or on a JDK. You get the Java.Lang package automatically. For example, when we were running the string handling demo, I was using the string class, but I never imported this string class. You can see there is no import for string because string class is also part of the Java.Lang package. It's automatically imported for you. You never need to explicitly import the package or any classes of that package. So this is going to be more of a theoretical lecture where we will just have a look at or a quick overview of all the Java.Lang package classes and other utilities. You don't need to remember all the classes and utilities, but this is just to give you a sense of what all it contains. So in terms of the interfaces, it has the appendable interface, auto-closable, char sequence, clonable, comparable. If you remember, we also used comparable when we were writing the comparable implementation to compare different objects in a collection. So this also comes automatically as part of the Java.Lang package. Iterable, runnable, again, we use this in the threading example. So this also comes automatically to you. You never need to import the runnable class from the Java.Lang package. When we move to the classes, all the data type classes which you can think of in terms of Boolean, byte, character, class, class loader, compiler, enums even, float, integer, long, math. So all the classes which we were using, the data type classes which we were using in different examples are also part of the Java.Lang package. Okay, so this is a long list. It also has the thread class. So whenever you are creating thread, you again never imported thread class, but it still just worked fine because there was this was also coming as part of the Java.Lang package. There are also a bunch of enumerations which it provides in terms of Unicode, thread state, etc. It also provides exception classes like arithmetic exception or the different runtime exceptions which we dealt with, like array index out of bound, array store, class cast, class not supported, the root exception class. So a lot of exception classes also come as part of the Java.Lang package. It also provides some error classes. If you remember when we talked about the exception framework, you have the error types and you have the exception types. So it also provides some error classes. If you want to use that, you never need to import any of these classes and you will automatically get them from the Java.Lang package. Similarly, it also provides some annotations as well, like functional interfaces, or you remember we use this annotation a lot, the @override annotation, but we never imported the override class or the override annotation because it's part of the Java.Lang package. So this basically tells us that there are a lot of different classes, utilities, enums, errors, exceptions, data types, which are provided out of the box from the Java.Lang package, which makes our life so much easier whenever we want to work with Java, because we don't need to import the very basic classes which we use very frequently. And another very important package is the Java.Util package. We have been using the Java.Util package in all of the collections, examples, and tutorials we walked through in this whole tutorial series. So let me just open the Java.Util package for you. So if I go here to Java.Util, and I will be able to see the Java.Util packages, different classes, etc. Yes, so here it is, the Java.Util package. And remember, Java.Util package is not imported automatically. You have to explicitly import the Java.Util package to use the classes of it. So that's the difference between Java.Lang package and Java.Util package, that you cannot you can use the classes coming from the Java.Lang package without explicitly importing those classes or importing the Java.Lang package. But Java.Util package is something which you have to explicitly import in your Java program to make it work or even make it compile. So what Java.Util provides? First of all, the collections framework. The whole collections framework comes from the Java.Util package. So for example, all the interfaces which we use while we work with the collections framework classes, interfaces like collection, list, set, map, you can see the map interface, you can see the list interface with the generics. So all the interfaces which we use from in the collections framework are present in the Java.Util package. Similarly, when we talk about the classes, all the concrete classes implementation of the collections framework in terms of array list, linked list, hash map, hash set, tree set, tree map, you will see all of those classes here. Here we are covering all the, this is showing all the classes summary. So you see some abstract classes, and you will also see some concrete classes as you move further down in this particular list. So you see hash map, you see hash set, hash table, linked hash map, linked hash set, linked list. We used all of these classes while we were going through the collections framework tutorials. So it provides all of these and a lot of other classes like the scanner class, which we covered in the Java project for taking the inputs from the command line from the user, stack class again from the collection, some time classes. And it also provides a bunch of enumerations like the locale, basically setting the language categories for a particular program. It also provides some exceptions which we used while we were working with the collections framework. So most of these exceptions are or some of these exceptions are related to the collection classes. For example, the concurrent modification exception gets thrown whenever the whole execution detects concurrent modification of an object when such modification is not allowed. You will see other different types of exceptions like illegal format, etc. in this particular exception section of this particular package. Then it also provides just one error class as well. So this is what the Java.Util package contains. And just to refresh your memory, whenever we ran any collection demo, we always imported the Java.Util classes. You can see this is all coming from Java.Util. So this is something which you have to import, without which your program will not even compile. So that's also one of the difference between the Java.Lang package and the Java.Util package. And that's pretty much all I want to cover in this particular session. So we basically did a quick tour of the Java.Lang package and the Java.Util package. And like I said, it's impossible to cover all of that, or all of the classes and enums and interfaces and errors and exceptions with all the examples. So I would suggest you to just keep this in mind about the Java.Lang package and Java.Util package. I told you the basic concept that Java.Lang contains all the types, the class and the variable types or the data types we dealt with, and Java.Util majorly contains all the collection classes. That's the basic thing which you need to remember whenever you work with Java. And your Java.Lang package never needs to be imported, but Java.Util package needs to be imported always whenever you use the util classes. Let's get started with concurrency utilities in Java. Now, concurrency is a huge topic, and it's not possible to cover this into a 10 or 15 minutes tutorials. So treat this particular session as an introductory session where I will talk about some of the most relevant classes which you need to know when you talk about concurrency. We have been talking about this whole concept of concurrency programming throughout the thread tutorials as well. And the basic idea is that you would like to do multiple things at the same time. That's the basic idea. Now, in that context, Java does provide a lot of utilities and packages, especially the Java.Util.concurrent package is one of the most popular package which you need to use whenever you are dealing with concurrency programming paradigms in Java. So with that, let's have a look at what does this Java.Util.concurrent package contains. So broadly, it contains a lot of utility classes which can be very useful for you when you are writing the concurrent programming code. Apart from that, it will also provide some basic ideas around the locking functionality and the atomic packages as well. When we talk about locks, again, we discussed about locks when we talked about the whole thread synchronization concept as well. And it basically marries very well with the whole concept of locks and atomic packages as well. Atomic is again a different topic which is used for thread safe types basically. But whenever you will hear about concurrency utilities, be it in your discussions or be it in your interviews, you will be seeing a discussion happening around executors. You will hear these terms like executors, executor service, future, completable future, callable, all of these. You will hear the name of all of these classes quite frequently. So these classes were first introduced in Java 8 and have been there since then to support the concurrency programming paradigm. So I will talk about these three classes broadly in today's session, and we'll have a look at a demonstration of these three classes as well. Let's first talk about executor. Technically, it's an interface. It's not a class, though I said that it's a class, but it's basically an interface. An executor is basically a very simple interface which will help you define the subsystems which you would like to create with the help of threads, maybe including thread pools, or if you want to do a disk reading and writing operation in an asynchronous way, or you want to create some sequence of task frameworks as well. So executor will provide you a very lightweight framework to do all of that, especially around thread pooling and asynchronous IO is where it shines most, because in your computer you have limited resources and you would like to dedicate a certain pool of threads for a particular task or for a particular executor object. So with that, the second class which we would like to know about is executor service. An executor service will provide a more asynchronous task execution framework, and this is probably the class which you will be using whenever you're dealing with asynchronous programming in Java. Asynchronous programming basically means that you submitted a particular task, but you did not wait for it to be completed. You did not hang your process or your thread for that particular task to be completed. It's very simple. It's very easy to relate this to a real life. For example, if you are, there are times when you do two things at the same time. For example, let's take a very, very simple example. If you're just boiling milk on your gas stove, so you put the milk on the gas stove and then you move out for a couple of minutes to do something else. For example, maybe checking your mobile for new emails or doing some other work, maybe just doing some laundry. So you submitted the milk boiling task, then you moved away from that task because you know that this particular task is going to take some time and you utilize your time somewhere else. That's what we mean by asynchronous programming, and executor service will provide you with constructs to create a similar behavior in your Java program as well. So remember about executor and executor service. We will look at the implementations later where we can talk about that. Another interesting class which I would like to talk about is future, if we have it here. Yeah, so future is another class which we will be looking at, and future is basically to fetch the result of the submitted task. Again, taking the same naive example of the milk boiling example. So it would be great, right, if there is some mechanism or some alarm which just sets off the moment the milk is boiling and it's about to be spilled out. It would be great to know that in advance via some alarm or something. So future provides that kind of a carrier or that kind of a holder where you submitted a particular task, you moved your threads to something else, you did something else, and then you can check with the future object, and future object will tell the status of that submitted task, whether it is completed or whether it's still in progress. Once it is complete, then you can fetch the result of that submitted task based on with the future object. So that's the concept of future. So remember, executor service and future, they will work quite hand in hand, because executor service will be used to submit the task and future will be able to fetch the result of that particular task asynchronously. So that was about a quick theory. You can read more about it in the documentation. You can see in executor service, future class, what does this basically in these class do. But to have a look at or get a greater sense of this, let's have a look at our demonstration of it to understand these classes better. So let's move to the Eclipse IDE to look at an example. Let me close all the classes and just open a relevant one. So yeah, so let's first deal with the executor interface itself. So if I just minimize this one, here I've created a main class and I've created a public static void main method, and you see two static methods here, executor invoke and executor service invoke. I'm basically showing you how you can use executor and executor service. So if you're just using executor, then how you would do that is basically you are going to create a reference of the executor, and then the executor needs basically an executor object, because it's an executor reference, so you need to supply an executor object. So either you can supply an inner class right here, or you can call you can create a executor type of class, which I've created here, which is called caller class. So I've created a class called caller which implements the executor type, and the moment you write implements executor, it will force you to override the execute method, and inside the execute method you are going to run your own thread. So this is how the current thread or the executor's own thread will be running. So once you have done the initialization, then you can call the execute method on the executor class. Remember, you got this object, so you can call the execute method on the executor object here, and inside this you can provide this particular Lambda function implementation, which is going to ask you what exactly you want to do when I run this particular thread. So when I run this thread, when Java runs this particular thread, what do you want Java to do? That's something which you will provide here. So this is how you can use, it's a very simple example. Like I said, if I build a more complex example, it will take a lot of time and a lot of other concepts to cover. So treat this as an introductory session, and you can basically try to run a very simple example of this, writing whatever complex logic you want to write while the thread is running, and put that into this execute. Similarly, if you want to use executor service for doing the asynchronous operations, then it will follow the same way, but there are some differences along the way as well. So this is the method which is showing the executor service implementation, or the way of using executor service. So again, I create a reference of executor service, and then here you see I'm saying executors dot new fixed thread pool with a size of 10. So that's the power of executor service. It is going to create a pool of threads dedicated to itself to do the tasks whichever are written inside here. So whatever you write here, these thread pool will be utilized to execute that particular task. You can assign the size of the thread pool based on how many threads you need. There are multiple static utility methods, like there is one new fixed thread pool which I've used. But if you just do Control Enter, you will see cached thread pool, single thread execution, a new work stealing pool. So like I mentioned, there are a lot of classes, interesting classes here, which you can use. for simplicity, I've just used a fixed thread pool here. Once you get the executor service object, then here you called execute, but here you will be calling the submit method. And then the drill goes exactly the same way that you write the Lambda function implementation inside here, basically the functional interface implementation, and you provide your own implementation code which you would like to run whenever you call the run method, whenever this executor service calls the run method on that particular thread. You can actually go to the submit method and you will see it accepts a runnable. It basically accepts a thread object. So whatever you write inside this particular code will be the public void run implementation of that particular thread class. If you don't remember how runnable works, please go back to my threading tutorial and watch that, where I explained the runnable interface and the run method in detail. So that's what we are doing here. So this is for executor and this is for executor service. So let's run this program. And yes, I mean, nothing, because I'm not doing anything much apart from just doing sysouts here. And that's what you see here, the executor example and the executor service example. So this was about executor and executor service. Now let's deal with another interesting class of called future, which I said that I will also talk about. So for that, I've created a separate demo because it deserves a separate demo. It's a very interesting class. So let me just make it full screen. Yeah, so I've created a class called future demo, which has a public static void main method. And again, I'm doing this executor service initialization, but this time I'm using a new single thread executor. Now, what does this do? This will basically create an executor which will use a single worker thread operating from an unbounded queue. Remember, even if this single thread terminates due to, let's say, a failure during the execution, before the graceful shutdown, a new one will automatically be spawned and will take its place if the execution is still pending. So that's the power of single worker thread from an unbounded queue. That's what I've used here. Based on your use case, you can use other ones as well, like I mentioned earlier. Then I have the executor service object with me, and similar to the previous example, I'm going to call the submit method. And inside the submit method, I need to provide the runnable class runnable interfaces implementation. And that implementation will basically be of the public void run method. And this is what I want to do in my run method, where I'm sleeping the thread for 10 seconds. Thread.sleep method takes millisecond values as the parameter. So this is 10,000, which means 10 seconds. So I'm sleeping this thread or pausing this thread for 10 seconds and then returning a string called completed. This is what I am doing in the executor service.submit implementation. The result of it is going to be a future object. Remember, the result of the submit task is going to be a future object. So I store that future reference here, and then at line 20, I'm using the same future object to ask Java to check if this task is done. And the way you do that is just by calling is done. So till the time, there's a negation condition, till the time the task is still in progress, because this means future is not done because I've put a negation, then just print this out where you say the task is still in progress, it's still not complete, and you pause this particular thread. Remember, this was a different thread. If you pause this particular thread for 500 millisecond, or basically half a second, and you again check this condition. If it's still not done, you print this, again pause for half a second, again check this, till the time future.isDone becomes true. When future.isDone becomes true, that means that this particular task is completed. Now you see, I mean, generally when we execute the programs, the execution happens sequentially, that after line 17, the control will automatically flow to line 20. And before the control can reach line 20, everything above line 17 has to be completed. That's basically synchronous programming for you. But when you talk about asynchronous programming, using the power of executor service and future objects, you can do something here which will go into a separate thread. And then you can continue your execution here. So this can be in a different method altogether, where you submit something, and this is basically checking the status of this task. Understand this very well. This is very important concept, that it's not though it's a sequential execution, after line 17, line 20 is getting executed, but line 20 is not waiting for everything above line 17 to be finished. It will continue. That's the power of asynchronous programming. So here we are checking this, and once the future.isDone says true, then we say task completed. And then you probably would like to fetch the result of this particular task, right? And for that, future provides a method called future.get. This is going to pick the future object state, and whatever you are returning from here will be returned here, and then I'm printing the result. So if everything went fine, this result should say completed because that's what I'm returning from this future object. And always remember to shut down your executor service to release the thread pool which you created here. I've also put a catch block here because I'm using the thread.sleep method, which will ask you to handle an interrupted exception. And then there is an executor service exception, which is execution, and a timeout exception as well. There are other interesting methods as well on the future class, future object, sorry, which is like future.cancel, where you can cancel explicitly a future task, which is currently in progress. You can check the status of it by calling isDone, which I've used here. You can also call isCancel to check if the user or some other process explicitly canceled the execution of the submission of the executor service task. So hope this is you are able to understand the flow of it, that these block and these block program will execute them, but they will run in different threads. So let's see what happens. Now I'm going to run this particular program. And if I bring this here, you see the task still in progress keeps getting called. So we submitted the task here, and now this block is getting executed. This block kept getting executed. So this task did not finish, right? The thread.sleep was this whole thread was sleeping for 10 seconds, but line 20 did not wait for 10 seconds. It continued execution and it kept checking the future object 10 times at least, or till the whole 10-second sleep was taken away. And once this thread woke up, it returned completed. Feature.isDone became true, and it came out and it said task completed. So that's what we get here. And at the end, in the result, you get completed, which is what you returned from here. So this is the power of asynchronous programming. Please, like I mentioned, please do read more about these classes and how they work and what is the paradigm of asynchronous programming. It does make debugging a bit hard at times, but it's a very interesting concept to be used in concurrent applications. Let's get started with regular expressions, or regex, in Java. You may hear people calling it as regex or regex. Doesn't matter. You can call it anything as you want till the time you have the concept understood in the right way. I'll just call it as regex. So when we talk about regex, let's understand why do we need them and how Java actually provides support for that. So the basic idea behind regular expressions is to find a pattern in a text corpus. If you have a lot of strings available, if you have any kind of text, any kind of string, and if you would like to find a particular pattern saying, okay, does this whole text paragraph contains any character, or contains any number, or contains any special characters, or contains characters after numbers or numbers after characters. So if you would like to find those kind of patterns in your text corpus, then that concept is called regular expression finding. And Java provides the support for that particular regular expression finding through a package called Java.Util.regex package. So this is the package which you would need to use when you want to do any kind of regular expression finding in the text. Now, you may be thinking that why do I need to use this? I already have the string handling methods, right? You can do substring, you can find a particular character in the string, etc. But that is limited because it only provides string methods, ways to manipulate and find and replace strings. But regex is generic. You can literally find any kind of character in your string. It can be a special character. It can be a square bracket. It can be a multiply sign. It can be a divide sign. It can be, like I said, integer, capital letters, small case letters. So any kind of pattern you would like to find, Java.Util.regex can be used to find that kind of pattern. Now, this package is very interesting and it provides lots of classes. And again, this is a very big topic and very complex topic. So we will just scratch the surface of it. And like I always say, whenever you would like to read more about it, go back and read the documentation. Currently, the documentation I've opened is for Java version 8, but when you are reading it, you can go for the latest Java edition documentation. So with that, let's talk about some of the interesting classes which we will be dealing with and we must know when we talk about regex in Java. So I already explained what are regular expressions. Let's go to the interesting classes. The first class which we need to know about is the pattern class. So pattern class, or an object of the pattern class, will basically be representing a compiled regular expression. So you write your regular expression in a certain way. Regular expression has its own language, I would say, to write the pattern. For example, if you would like to write a pattern saying that check if this particular text paragraph has the characters first, then the integers, then the characters, then this particular special character. So that is your pattern. You write that pattern, then you need to compile that pattern. To compile that pattern, you can use the pattern class. This class generally does not provide any kind of public constructors to you, so you cannot initialize the pattern object explicitly. But to create a pattern, you need to basically call the static method named as compile. So compile is the method which you need to use to compile your regular expression, which will then return the pattern object. Once you have compiled written your pattern and you compiled your pattern, the next class which you need to know about is the matcher class. Matcher class will provide that particular engine framework which will understand and interpret the pattern, and then will try to find that pattern on the text paragraph which you are supplying, and it will result in true or false. If it finds that pattern, it will say true. If it's not finding the pattern, it will say false. So that's the basic idea. So you need to know about the pattern class, and you need to know about the matcher class. So the matcher class also does not provide any kind of public constructors, and you obtain a matcher object by calling the matcher method on the pattern object. So once you created a pattern object, just call the matcher on that particular object, and that will get you a matcher object, and then you can use that object to find the patterns in that particular text corpus. There is also a dedicated exception which is called pattern syntax exception, which will be thrown whenever you have written the regular expression syntax incorrectly. Like I said, it has its own language, so you need to write the expression in a way regular expressions are supposed to be written and supposed to be understood. I will touch upon that in a while, but that's the basic idea about the three classes. Now, when you would like to find a pattern, it can be a string pattern, it can be some characters, it can be some predefined characters, some quantifiers. You can also create subgroups within the regular expression. So like I said, there's a tons of functionality which is available in this particular concept, and we will just cover some of the relevant ones, or just run through some of these concepts, and then I will switch to a demonstration. For example, if we talk about the string literals, then you can do the string matching. For example, if you want to find this particular word or this pattern, this is just a text pattern, right? So if you would like to find this particular text pattern in the text string, then you can write this particular text pattern as a string pattern inside the pattern object. So that's about the string literals. Now let's move to some interesting ones like meta characters. And the meta characters are very interesting because they have a special meaning. For example, if you write your regular expression like this, where you say cat and then you say dot, then when you are applying this particular regular expression to find the match into a string, it is only going to find the match for CAT. It is not going to find the match for CAT dot, because dot is a meta character in regular expression. It has a special meaning. It does not mean dot, but it has a special meaning. And that special meaning basically means that even though the dot is not present, it will basically mean that after cat, it can be any character. So the meta character dot means any character, which is why you see this match succeeds, because it will search for this pattern, which it matches. And after that, it can be any character, it doesn't care. So even if it's S or D or whatever, it will say true because CAT was found a match. So dot means any character after the pattern you have specified. Similarly, there are a lot of other characters, special characters or meta characters, like the ones which have been listed here: question mark, star, plus, dot, and all of these have their own dedicated special meaning. They are not your normal arithmetic operators or other operators. They have their special meaning when you are dealing with meta characters. So do read about them in detail, and I will be using a bit of meta characters in the example as well. Then the character classes are also very interesting. Similar to the example which I told you before, if you want to find a particular string or a particular integer into a text corpus, then you can use the character class patterns. For example, you just put a square brackets and you write ABC. This means that it will try to find exactly ABC in the string. If you put a cap in front of ABC, then it will try to match any character or find any character except A, B, or C. So it's a negation. Similarly, if you specify small a to z and capital A to z, it means any character can be there between small case a to z and capital case a to z inclusive. Similarly, you can provide specific ranges like A through D, or M through P. So only the characters which will match the union of this condition will be returning true, and rest of the if this particular pattern is violated, then you will get false. So similarly, you can build a lot of complex combinations and permutations with these special meta characters and character classes. Do read about these in detail if you are curious to know about it, and there is tons of materials available on this on internet which you can read about to learn more about. Similarly, there are predefined character classes as well. Dot is something which I already explained, which means any character. Then you can use /d to find a digit in a particular string or in a particular text corpus. /D is for non-digit, or you can use the classic negation condition as well. /s is for a white space character. /S is for a non-white space character. Word, non-word. So there are a lot of different examples. So I think by now you would have built a decent understanding of what I'm trying to tell you is that you can specify these patterns, compile them, and then use the matcher. So let's move to a very simple demonstration. It's not a complex example, but very simple example just to get the point across. So I'm creating a regex string here, and this is the pattern I've specified. I'm saying any character, star means any number of characters, so it can be anything here. Then the string, the pattern expects an alphabetical string or alphabetical section. After that, the alphabetical section should be followed by a numerical section. And after the numerical section, again, it can be any character. So this is my pattern. I create a simple string with this regex pattern. And like I mentioned in the documentation, you call pattern.compile to compile the regular expression. So I compile the regular expression, I get the pattern object. And after, again, as per the documentation, it said that you can call the matcher method on the pattern object to get a matcher object. So I say pattern.matcher, and I provide my string on which I want to test it. So I've just put a random string where there are some integers, then there is some alphabets, and then again there are some integers. Once you have got the matcher object, just call matcher.find. This will return a boolean where you can test whether the matcher found a hit in the text corpus or not. If it found a match, the match found will be true, and if it didn't find the match, you will get a false value in this result. So with that understanding, let's run this program. So I get the output match found. Why did I get that? Because I said that start with anything. So it started with anything. I don't care what it is. It's an integer or any special character. I don't care. After that, there should be some alphabets. So there are some alphabets, and right after alphabets, there should be some numbers. So again, there are some numbers. And after that, there can be any character, 0 or more characters. So there is nothing here. That's why you see a match found. Let's do an interesting test here. Let me do this. I put A to Z again here. So now I'm saying start with anything, have alphabets, have numbers, and again after numbers, you should have some alphabet, which is not the case here because you start with something, you have alphabets, you have numbers, and after numbers, the string ends. There is nothing after that. So let's see what happens now. You get a match not found because this particular pattern, when got compiled and got applied on this particular string, did not find the string following the regex pattern which you have specified. So this is a very simple example to show you how you can build patterns. You can use groups concepts as well to group the patterns. It can get very, very complex and very, very nasty. So use them very wisely, very carefully. And do read about the documentation and other examples which I talked about to get more understanding and more comfortable with regex. Let's get started with Spring Framework. So Spring Framework is the most popular web application framework available out there today. And all of the big companies from Netflix to whatnot use Spring Framework to build the modern day Java applications. So before we go any further, let's understand why do we need a framework. So let's understand this with the help of a diagram. So let me just open a blank paint page and let me show you what I mean by a framework and why do we need this. So we built simple applications so far, but if you have to build an enterprise grade web application, you will have a front end probably where you will have what you see in the browser. So you will have the HTML, the JavaScript, or any other Java Enterprise Edition classes like JSP Servlet, etc. Then you will have a backend where your Java classes are present, which contains the business logic. So the business logic. And then you have a database where you store the basically the whole data. So you have these three different layers. We also call this a 3-tier architecture. So you cannot build all of this by just using the core Java classes which we talked about. You need to do more integrations. You need to use more different programming languages and concepts to build a complete enterprise grade application. And if you try to build all of this by yourself, then it's going to take a lot of time and a lot of effort. That's why we have frameworks which basically provide the structure to create these three layers. So that's why we have these frameworks. And in the frameworks, Spring is the most popular framework. It provides the structure to write all these three layers. One of the reasons I did not talk about the Java Enterprise Edition technologies like servlets and GSPs because nobody works on them today. Even if you learn about servlet, it's good to know the conceptual overview of servlets, but nobody today builds applications on GSPs and servlets. That's the reason I did not talk about it, because today we have sophisticated front-end frameworks like AngularJS or React.js or Ember.js and whatnot, and it is iterating at a very faster speed. So there is literally practically no need for a Java developer today to learn about GSP, because I can bet you on that. You can take it in written from me. Nobody is going to build the GSP based applications in 2021. Everybody is going to use some sort of front-end framework to build that. And then you have a backend. In the backend, you have the exact core Java classes like I just explained. So you will be using the Java beans, and you will be basically using the pure Java concepts of collections and etc. to write the backend logic using the Java classes. And then you will need a JDBC connection to write through a database as well. So you would need a database as well. And Spring provides connectors and specifications to support all of these three layers. That's the reason. So generally, when you talk about a web application, let's talk about web application because Java primarily is used in web applications. So in a web application, you basically see a browser window where you load a particular page. But what happens behind the scene? This browser has some HTML and some JS maybe, and this code is basically calling some endpoint. This endpoint is present in the backend layer. So this endpoint is present in the backend layer. That endpoint transfers the control to the business layer where you have your core business logic written. And then the business layer transfers the control to the data layer, or some people also call it DAO layer. This DAO layer then talks to the database. That's how a web application works. And that's the architecture you will mostly be following whenever you are building any enterprise grade application in any organization. So Spring provides support for all of these parts. This obviously is written by Angular and React and other frameworks, but this whole section is basically presented or supported by Spring. So with that, let's understand a bit more about Spring Framework. So if you go to the Spring official website, it talks about some of the value propositions. Spring is used heavily. Like I said, it's used everywhere. It's very flexible framework. There are a couple of concepts which Spring provides, which is around inversion of control and dependency injection. And I will talk about these concepts in a while when we'll talk more about the Spring's components. It makes it's quite productive and quite fast as well. So it's very fast to build application on Spring. It has a whole dedicated security module as well. So it's quite secure by design. And the Spring community is huge. So you can find a lot of support on internet. Let's learn a bit more about the Spring's core components or core technologies. So if you talk about the Spring's core components, these are the Spring's core components. So you have a testing module, you have a core module. First of all, inside the in the core components, you have a core module which has IOC containers, resources, events. I'll talk a bit about that. It has its own testing component, so it provides very good support for testing applications. It has a data access component. The data access component is used to provide connections, utilities to the database, because like I mentioned, your application will be talking to the database, and Spring provides a complete dedicated component to be used whenever you are talking to the database. It also provides a web servlet component to provide support for Spring MVC, which I will be covering in the next session, WebSockets and Stomp and messaging frameworks, etc. It also supports reactive or asynchronous programming if you want to do that. It provides a lot of integration capabilities in the integration modules if you want to do JMS or JMX or email or task scheduling, etc. And it also provides language support to support internationalization of the applications. So it has a lot of different components, but we will focus on this core component, which is of the interest here. So let's talk about that. The first thing which you need to know about Spring is its support for inversion of control, and it provides that support by creating an inversion of control container. What do we mean by inversion of control? The basic idea is, let me take any random example and I will be able to communicate the idea behind this. So let's go to any simple example which I have already covered. Let's go to method calling, for example. So we had a student class. We created a student class, simple student class, 3 properties, constructor and public getters and setters. And then I created a main class and I initialized the student object. So the responsibility of creating the student object lies with the student class itself. Student class have to be explicitly initialized to be having an object of the student. So this creates a problem because when you're dealing with enterprise grade frameworks, you might need to create a lot of objects on the fly whenever the endpoint is talking to the business layer. If I take the reference of this architecture, if the endpoint is talking to the business layer classes are talking to the data access layer classes. So when the business layer classes needs to talk to the data access layer classes, the data access layer classes needs to have an object because the communication happens between objects only. So who creates those objects? If every time the data access object has been called, and if we pass that responsibility to the DAO class to create the object, or every time the endpoint talks to the business class, we ask the business layer to create the objects, it becomes a lot of painful process because every time you will be doing this new student everywhere, you need a student object, which is very painful process. So what Spring says, it says, okay, invert the control of creating the object. So let's not give the responsibility of creating the object to the class. Let's give that responsibility to the framework. So the framework will be responsible for creating the objects of a class, and it's not the class who will be responsible for creating its own objects. So generally, outside the framework, a class is responsible for creating its object, but with Spring inverts this responsibility. That's why we call it inversion of control. The control is inverted, it's reversed, and now it's the framework's responsibility to create the objects. You will also hear about a concept called dependency injection a lot in context of IOC, and dependency injection is an implementation of the IOC concept. So using Spring's dependency injection mechanism, you can inject the object of any class into any class. Once you do that, Spring dependency is going to use the inversion of control concept and create the object. That's about IOC and DI, or dependency injection. Then the other modules like resources will provide a way to refer different files and properties if you want to. Then you have a validation module as well, which will provide different validation constructs, because once you receive the data, you might need to run a lot of validation, right? And writing the validation by yourself can be very painful. So it provides a validation framework as well by providing the validator interface. You can use this particular framework to write the validation rules, checking the name not empty, etc. Similarly, it also supports an expression language if you want to use that. So the expression language support is wide, very wide in fact. You can create an expression parser and you can do the expression language evaluation using the Spring expression language. Similarly, it also provides support for aspect-oriented programming. Now, again, all these concepts of validation and Spring expression language and resource support, you probably would need hours of reading to learn about these concepts, and I'm just running through them just to tell you about these concepts. And do read about why do you need resources, why do you want to do validation, why do you need an expression language, what is aspect oriented programming. Read about all of those concepts because they are not related to Java. They are generic concepts which will be applicable to any programming language. So any enterprise application you build in any programming language, you would need to do the validation, you would need to do the resource reference management, you would need to have an expression language, you would need to have aspect oriented programming support. So this is just to tell you that Java does provide an AOP or aspect oriented programming support as well, and it has a lot of APIs available for that. Along with that, it also provides very good logging capabilities because you definitely need to log all the actions which the framework or your objects are taking. So this was a very quick lightning overview about Spring. I understand it's not possible to cover all the concept of a framework as sophisticated and as smart as Spring in a 10 to 15 minutes lecture. So treat this as an introduction session. And like I said, read more about all of these components. I just explain the core because this is sort of the main building block of Spring framework. And then you have other supporting components as well. So do check out the documentation. There are tons of examples available. In fact, in the Spring's official website itself, if you go to the Spring Guide section, if you go to the Learn and you go to the Guide section, there are awesome getting started and topical guides and tutorials available. So for example, how to build a RESTful web service, how to schedule tasks, how to consume a RESTful web service, how to build a simple Java project with Maven, how to upload files with Spring, how to do messaging with Redis, which is basically a caching framework, how to do messaging using Spring to RabbitMQ. RabbitMQ is a messaging framework. So there are tons of examples available here. Very good documentation and very robust documentation. Do check out the examples to learn more about this.
Let's get started with MVC and the implementation of MVC using Spring. So before we go any further, let's first understand what do we mean by an MVC application. So in the previous lectures, I discussed about the 3-tier application where you had a presentation layer, you had a business layer, and then you had a database layer, which is talking to the database. And that's how we built a 3-tier application, which can also evolve into an N-tier application. But when the web development started, the most popular concept which came out was MVC. M stands for model, V stands for view, and C stands for controller. So the idea was that these 3 components together can render a web application. And how they render the web application is basically that the controller is going to receive the request, which is coming from the web browser. Then the controller will have the knowledge of where the business logic for that particular request will be residing. So the controller is going to invoke the model, the corresponding model which is required to execute the business logic of the request. And the controller will also have the knowledge of what response page to be sent back to the user. So we are talking about the response page here, not response. Remember that, because it's a web application. So the model view controller architecture basically was designed to keep in mind that you have a web application where a request is coming from, and you need to process some business logic, and then you need to return back with a page response, which is going to be displayed on the web browser of the client machine. So that's why we had these 3 components as model, view, and controller. Controller taking up the request, then finding the right model for it, which can execute the business logic, and then also finding the right view for it, which can render the business logic processed by the model. So that's a quick overview about model view controller or MVC architecture. Do read about it in detail to understand how this works. But like I mentioned, that MVC, the most popular MVC implementation is provided by Spring. Spring is the most popular MVC framework, and the way Spring implements it is something which I have drawn already here. So let's understand how this works. So first, the request comes from the web browser, and Spring has a very first welcome servlet, which is called dispatcher servlet. Any request which is coming to the Spring enabled web application will first hit dispatcher servlet. And once the request comes to the dispatcher servlet has all the knowledge of all the controllers, of all the view resolvers, which I will talk about in a while, and of all the views as well. It also has knowledge about handler mappings, which again I will just discuss now. So the basic premise is that dispatcher servlet is the component which has knowledge about literally everything happening in your application, and that's why dispatcher servlet is the first servlet or the first component which receives your web request. So once the request comes here, first of all it looks at the path and finds out the right handler for it, the right controller for it. And the way it does that by using the handler mapping component or handler mapping logic, which is provided out of the box by Spring Framework. So the handler mapping logic will tell the dispatcher servlet which particular controller is going to process the request which is coming, because every request will have a different controller return. So whatever the type of request is, whatever the path of the request is, based on that, the dispatcher servlet is going to find a particular controller. Once the controller is found, like I mentioned earlier, the controller will have knowledge about the right model to invoke for that particular request. Model is nothing but basically a Java class holding the business logic for this particular request. So it will invoke that Java class and get all the business logic processed, and then it is going to return a model and view object. View is here
simply pointing to the UI response which you are going to send back to the user. It can be a JSP page, it can be an HTML page, it can be any other view technology. So anything which is used to render a web application on a web page is view, and controller is going to send both the model and view information back to the dispatcher servlet. The dispatcher servlet will take the view part of it and go to another component which is again provided by Spring, which is called view resolver. The view resolver will have the knowledge to see which particular actual JSP or template to invoke for the view value coming from the controller. So based on the value which is returned by the controller, a view resolver is going to return the right page mapping. And once the dispatcher servlet knows the page mapping, it is just going to invoke that page by calling the view component. So dispatcher servlet, handler mapping, controller, view resolver, and view, these 5 components together help render a web MVC application in the Spring framework. So that was about the theory of how Spring works. Now let's move on to an example to understand how this works in action. So here I have already built a Spring MVC application, and if you're wondering how to build that, there's an easy way to do that using Spring Initializer, and that's also the recommended way. Actually, if you go to the documentation of Spring, you will see that it recommends creating a new project from scratch using the Spring Initializer utility, which is provided by Spring out of the box. So just go to a web browser and type start.spring.io. You will get this page where you can specify what type of project you want to create. So it is going to create the basic skeleton for any Spring application automatically for you. It's probably, like I said, it's probably the fastest way to get started with Spring. So we will choose a Maven project. Maven is again a dependency management tool which is used to download any kind of jars for your application. So we are going to use a Maven project, and we want to create a skeleton for a Java application. We are going to use the latest released version of Spring or Spring Boot, which is 2.4.2. It says Spring Boot here, but don't get confused with it. We are going to use just the MVC classes and not the Spring Boot specific logic yet. Then you provide your group artifact ID and the name for your jar. You provide a description. You can provide a welcome package name, whatever suits you. And then how you would like to run your application. Whether you would like to package your application as a jar file, which is a Java archive, or you would like to run it as a web archive, which is a var file. So you can choose either packaging mode, and it is going to add appropriate dependencies inside the project to support the packaging of jar or the packaging of var. Then you can also choose a Java version. So you can see there are 3 Java versions listed here, which are 8, 11, and 15. So whichever Java version you are working on, you can choose that particular version. And once you have set everything, just hit generate. Once you do that, it is going to create a project here, and then you can import this project just as a normal project inside the Eclipse IDE. And that's exactly what I've done for this initial project, which is showing a very basic hello world sort of example for how Spring MVC will work. So this whole structure will automatically be created for you. And like I said, it was a Maven project, and in every Maven project, you will have a pom.xml. If I double click on this, it is going to open this XML, and it will list down all the dependencies which my project needs to have. Let's understand the dependencies as well. So this project is currently using the properties of 1.8, but that's fine. You can obviously definitely change this value. I just kept it as 1.8 for now because I'm not using any new functionality yet. In the dependencies section, you will see all the dependencies or all the jars which are required by the Spring application to run successfully. The first dependency we see here is about DaiMyLeaf, and DaiMyLeaf basically is a view technology similar to JSP or similar to servlets technically, where you can use this DaiMyLeaf templates, which are basically just HTMLs with some dynamic values, and you can use these DaiMyLeaf templates to render web pages for your Spring MVC application. If you want to use some other view technology, you need to include the dependency of that view technology here instead of DaiMyLeaf. So that's about that. Then you need to include the Spring Boot Starter Web. The Spring Boot Starter Web is going to enable your application to become a web application. Then this is basically a good to have dependency which you can have in your project, which will help you deploy the project at runtime automatically without restarting the server, because the web application will be running on a
server, on a web server basically, or an application server technically, because it needs to run somewhere so that so that clients can access it. That's how a web client architecture works, or the server client architecture works. So this dependency will allow you to deploy changes dynamically at runtime without restarting the server. Then this dependency is for tests, if you're writing any unit tests. And then you have a plugin which will allow to run this particular project with a single command, which we will see in a while. So that's about the dependency tour. Now let's look at what is in the src main Java. In the src main Java, I just have two classes. One is the main class, which will have a public static void main method, and this is the entry point of the Spring application. And then I have a controller class. I already talked about what controller is, but I will come back to that in a while. Let's understand the rest of the files as well. The next one is src main resources, where you will have your view technology data available. Like I mentioned, it is using DyMyLeaf templates currently, and basically, like I said, they are technically HTMLs with some dynamic data. So I've created a templates folder under src main resources, which will automatically be generated by Spring Initializer, and then under templates, I've placed an HTML file. It's a pure HTML file, with the only difference is this value. So this is what the dynamic value means, which is supported by DyMyLeaf templates. Otherwise, this is pure HTML. It's just a paragraph with a header, and this is the dynamic value which I'm populating. It also has application.properties, which has nothing, but you can use this particular file to supply environment specific properties for the development environment or the testing environment or the real production environment. If you have any unit tests, those will go here under src test Java, and this is the system library already provided, supported by Eclipse itself. And I already talked about the pom.xml. You also see a couple of more files created by Spring Boot. If you want to use that, you can use that to run the program from the command line as a utility. Otherwise, you can just use mvn spring boot command, which I will show you in a while. There's also a Gradle folder which you can ignore. Probably we don't need this because we are just using Maven and we are not using Gradle. Gradle is another dependency management tool very similar to Maven. So you can ignore this folder right now. So that's the structure. And now let's come back to the controllers. Remember, I told you that controllers are the ones which receive the request. So from the dispatcher servlet, which I talked about here, after the dispatcher servlet, the request comes to the controller. So once you hit a particular URL, then you need to create a controller for that URL mapping. Remember that you need to create a controller for almost every URL mapping you are having in your application. There should be some mapping to some controller somewhere. So I've created a greeting controller, and the way you specify or you make a simple class as a controller is by putting the @controller annotation. This is the annotation which is supported by Spring, and you can put this annotation on top of any class, and that class will be treated as controller by Spring. And the moment you put this class will also be registered with the dispatcher servlet. And like I mentioned, the controller's main purpose is to receive the requests, the web requests which are coming from the client. And the way you can receive the requests to a controller by providing the exact URL mapping. So if somebody runs this web application and says /greeting, then this particular method should get invoked. And how you define that is with the getMapping annotation. Use the getMapping annotation to provide the URL path. Whenever somebody invokes this URL path, this method would be getting called. And when this method is getting called, at that same time, this URL can also accept some query parameters. We call that as request parameters in the Spring language. So you can use the request parameters as an annotation to provide a placeholder for the variable for which the value will be supplied in the URL. So /greeting, if you call this URL something like this, then it will work because you have a variable called name which is being parsed as a query string because you have used the request param annotation. So we'll see an example of that once we run this application and how we can supply the query string. But you use the request param annotation to supply the query string parameters to the URL. You can mention if the parameter is mandatory or non-mandatory. If the required equal to true was there, then this parameter would be mandatory. You can also supply a default value if the client is not providing this query parameter at all. Would you like to set any default value? If yes, you can supply that default value here. And then you just give a placeholder name like I said. Then the second argument which your your methods which are intercepting the request should have is the model argument. And remember, I told you that the controller will have or should have the knowledge about the model, and from here that knowledge comes. This particular method will expect you to provide a model argument as well. So if somebody calls this application and provides the URLs with /greeting, this particular method will get invoked, and then the code inside this method will be getting executed. So it's a very simple code right now, but this is where your whole logic will go. Remember that. But here I'm just saying model.add attribute name with the value which is coming from the query string parameter. That's all I'm doing here. And remember, I told you that the model will hold the business logic. So here, this is the business logic where whatever query string parameter which is coming from the request param, I'm capturing that and I'm adding that value with the variable name in the attributes of the model. So my model is set, and after that I need to return the view so that this particular file name will be intercepted by the view resolver here. If you remember, we talked about the view resolver. So when we return greetings as a string, that string goes here, and then dispatcher servlet looks out, asks the view resolver to find a particular HTML matching with this particular text. So view resolver is going to look at under src main resources /templates to see if there is a file with the name greeting available or not. Since we have that file available, the Spring is going to render this particular file supplying the model attribute value name. Now remember, the greeting.html had the exact same variable name. So this variable name should exactly match with this variable name here. If you make a mistake here, this is not going to work because the model is holding the business logic, and I'm printing that business logic inside the view using the die-my-leaf template syntax, which is $curly braces. So whenever you have to print any variable or a model attribute or any runtime value inside a die-my-leaf template, then you need to use the $curly braces syntax to do that. So that was about a quick overview of how this application is written right now, and that's all the code is here. Now it's time to run this application. So one of the simplest way to run this application would be to provide a Spring run configuration here for the Spring application, or you can choose another way, which is to first have a look at the Spring Web Content application, which is the entry point. So once your application boots up, this is the first line of code which is going to get executed. And to make sure that this code works, make sure that you have the @Spring Boot application annotation on top of the entry point class. So this is sort of the mandate which Spring will force you to put in front of the or on top of the entry point class to treat this class as the first entry point when you run the project. So to run the project, what we will do, that we will just go to the command line and we will say mvn spring boot run. So let's do that, and let me open the terminal for that. So I have opened a git bash prompt here. You can also open the classic Windows terminal, but this is something which Git installs by default if you install Git on your system. It's pretty much exactly the same. It's just more Unix-like, but it's also just a simple terminal shell utility to access your file system. So I have gone to the project which we were working with in the Eclipse IDE, and this is the path of the project. So once you reach to the path, what you would like to run is just say mvn spring-boot : run. That's it, and you hit enter. Once you write mvn spring-boot : run, you will see a lot of code, lot of logs here where it is going to run compile all the Java classes, run any tests if there are any, and then it is going to start the web content application, you can see. And once the application is started, you will get this message that everything is run. One of the interesting thing which you can see here is that it is also spinning up an application server automatically for you, and that application server here which is being used by Spring is Apache Tomcat. Technically, Apache Tomcat is a servlet container and it's not a full-fledged application server, but just to get the point across, you can use Apache Tomcat as an application server which is being used here out of the box by Spring. If you don't want to use Apache Tomcat and you want to use something else, you can do that as well. So now everything is ready and we can now execute the application to observe the output. So for that, let me open a fresh browser window so that we don't get any cached response. And now I can just type localhost 8080. And if I hit enter, I get a white label error page because there is no home page for Tomcat defined, but there is a home page for my application defined. In fact, let's try to access the URL which we wrote in the greeting controller. The URL was /greeting. So let's copy this and let's put this here. So localhost 8080 /greeting. And if I hit enter, I get the message hello world. Let me just zoom this in a bit so that you can see. So you will see this hello world message here by putting this URL. Why do we see hello world? Let's go back to the controller. So when you call this URL, this greeting controller got invoked. Since we did not provide any query string parameter, the default value, which was world, was picked up, and this world value was stored in the name variable, and the name variable was added as an attribute to the model. And then we were using the greeting.html and we were printing the name variable. Since the name variable was holding the value world, so the message came as hello world with an exclamation, and that's the output which we see here. Now let's try to supply the query string parameter. The way you do that is provide a question mark, provide the key of the query string parameter and the value you want to put here. So let's put simply code as a value and hit enter. So now the message got changed and now it says hello simply code. So what happened here is that whatever query string parameter we supplied, that got passed here as part of the request param, and the value of simply code got stored in this name key and in turn in this name variable, and then I added the same value into another name attribute and added that attribute to the model. So now this name here is storing the value simply code, and then all the things work exactly as the same as I just described. It goes to greeting.html and it prints whatever is stored in the name attribute coming from the model. Let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please, you can read about the RESTful concept. As a concept, what does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc., etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar with one change, that in the previous example when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a thy_myLift template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application dot run, and you supply application dot class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation or on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object, or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot:run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot, and this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use the string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment. So that's all I want to cover for this particular session. And in the next session, we are going to have a look at an advanced Java project using some of the concepts which we might have learned during this whole journey. And that would be the last session of this particular tutorial series.
Let's get started with a demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply a web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and that REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then you, in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, you in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you are writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run, and this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class, and if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application, and then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from JavaX persistence entity, and this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from JavaX persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or controlled by table. You can also see the explanation of each of these here, but I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you'll see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD, because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class, and make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen, that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto-word annotation and will automatically supply an object whenever it is required. Then I have two methods here, since we are talking about HTTP endpoints. So I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation. And then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well, and then I will come back to how it got converted from JSON to Java. but this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID, and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080 with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost /student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. and then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object, because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the get student method, which is having a student/ID URL, and it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student object's property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP get method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application in with as much maturity and as much complexity as you want. And that's all I want to cover in this particular lecture. Thank you, and we'll meet again in another session.
Thanks to our training experts. It was really a wonderful session. I hope this session was informative and interesting. If you have any queries regarding the topics covered in this particular tutorial, then please feel free to ask in the comment section below. Our support team will be happy to help you out with all your queries. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.
We will be discussing Java interview questions. We all know that Java is one of the most sought programming languages in the current IT industry. There are multiple multi-million-dollar companies which are using Java till today. So this video is completely dedicated to help out the Java developers and the beginners in Java programming language to crack the most frequently asked Java interview questions. So without further ado, let's begin with our interview questions. At first, we will start with the beginner level interview questions. So in the beginner level interview questions, the first question we have is, what is JIT? So the answer for this question is, JIT is an abbreviation for Java In-Time Compiler. It increases efficiency of the interpreter by compiling the bytecode in the runtime. JIT or Just-in-Time Compiler compiles code to machine level directly for higher speeds of code execution. So basically, just-in-time compilation is a feature added to the interpreter of Java. So this involves conversion of the code directly to machine level during the compilation stage. This improvises the speed of execution of a Java program. Now after the first question, the second question in the docket is, what is a class loader? Now let's discuss the answer for this particular question. So basically, class loader is the first file to load when you execute any Java program. So the Java class loader is the integrated part of Java virtual machine. So the functionality of class loader is to load the class to the Java virtual machine while it is demanded to execute a class. Java has Bootstrap extension and application type of class loaders. So the third question in the docket is, what are the memory allocations available in Java? So the answer for this particular question is, Java provides multiple types of memory allocations. But the 5 major types of memory allocations which are most frequently used are class memory, heap memory, stack memory, program counter memory, native method stack memory. So the next question in the list is, will the program run if I write static public void main? So basically we write public static void main, but in case, imagine if I write the program as static public void main, will the program execute properly? So the answer for this question is yes, because Java does not follow any specific rule for the order of specifiers you place in your program. So when you execute the program with such pattern in your specifiers, then the program will compile successfully. Also, it will run successfully. So the next question we have is, what is the default value stored in local variables? So in C programming language, when you declare a local variable or a global variable or any type of variable, then the first value which is stored inside that variable will be a garbage value, unless you initialize the variable with a personalized value. For example, if you declare a variable I equal to 0, then you are storing a value in that variable I, that is 0. If you just declare it as int I, then the value stored inside that I variable will be a garbage value. So similarly, when you declare some kind of local variable in Java, then what will be the default value stored inside it? So the answer for this question is neither the local variables or the global variables or any primitives or any object references do not have any kind of default value stored in them. So followed by the fifth question, we have the sixth question. So what would be the output of the following code segment is the sixth question. So this might happen sometimes. So basically what happens is your interviewer will throw a question at you which has a code segment. So all you need to do is decode that code in your mind and provide the output. So this would be the code that we will be dealing with. So you can see our question has two printf statements. The first one has 100 plus 100 plus a string which is Simplilearn. And in the second printf statement, we have a string that is e-learning company plus 100 plus 100. So what will be the output of these two printf statements? So the answer for this question is really simple. So we'll be having 200 Simplilearn as the first output and e-learning company 100 as the second output. Why? Let's check out the code segment once again. So when you see the code segment once again, so the first printf statement has 100 plus Simplilearn. So JVM here understands 100 as an integer value and the plus symbol as an addition operator here. So followed by the addition operator, we have another integer value. So what JVM does is it adds the two numbers 100 plus 100. So followed by that we have another plus symbol here. So followed by the plus symbol we have a string value. So here the JVM considers the plus symbol as a concatenating operator but not as an addition operator. So that's why the first two numbers got added and the result was 200 and the next two values were concatenated. So it became as 200 Simplilearn. Similarly, in the second printf statement, the JVM encountered with a string value. So it considered the plus symbol as a concatenating operator. Similarly, it happened with the second plus symbol as well. So that's the reason we had e-learning 100 as the second output. Now followed by the sixth question, we have the seventh question. What is an association? So the answer for this question is an association can be defined as a relationship that has no ownership over the other. So to understand this definition, we can consider a simple example. Consider a person associated with multiple banks. So consider person X who has got accounts in bank A, bank B and bank C. And similarly, a bank is associated with person X. That is, a bank A, bank B and bank C are associated with the person X. But no one has ownership over the other. A person X who is an account holder with all the three banks, that is A, B and C, does not possess any kind of ownership over the three banks. Similarly, banks A, B and C who has the customer, which is the person X, but the banks do not possess any kind of ownership over the customer. So the relationship between the person X and the banks A, B, C can be considered as an association. Now followed by the seventh question, we have the next question, that is the eighth question. Define copy constructor in Java. So the answer for this question is as follows. A copy constructor in Java is a constructor that initializes an object through another object of the same class. A copy constructor in Java is really helpful because when you want to copy a complex object that has several fields, or when we want to make a deep copy of an existing object, then the copy constructor is the one which will help you out in this situation. So followed by the eighth question, we have the ninth question. What is a marker interface? So the answer for this question is an empty interface in Java is referred as a marker interface. Serializable and clonable are some of the popular examples of marker interface. So basically a marker interface is just another interface, but normally in interface we provide some signatures. So these signatures belong to particular methods. So in normal interface we just have method signatures but not the complete implementation, or at least we'll be having some variables. But in a marker interface we do not have any kind of data manipulating method signatures, any data members, nothing. They have special functionality unlike a normal interface. So followed by the ninth question, we have the 10th question. What is object cloning? I guess the word object cloning is completely self-explanatory. Yet the answer for this question is, it is an ability to recreate an object completely similar to the existing object. This process is known as object cloning in Java. Java provides a built-in function or method, that is the clone method, to clone an existing object, offering the same functionality that of the original object. So followed by the 10th question, we have our 11th question. Why is Java not completely object-oriented? So this question might be a little confusing, but it's true. Java is not completely object-oriented. But what's the reason? Yes, I'll explain you why Java is not completely object-oriented. So the answer for this question is Java is not considered as 100% object-oriented programming language because of the data types it uses. It still makes use of 8 or more primitive data types, which are int, float, double, and few others. So this is the only reason why Java is not considered as completely 100% object-oriented programming language. So the next question is, define wrapper classes in Java. So the answer for this question is, in Java, when you declare primitive data types, that is the int, float, double, etc., then the wrapper classes are responsible for converting them into objects or reference types. Just as we discussed before, Java is not 100% object-oriented programming language just because of the primitive data types it uses. So when you include such primitive data types, then wrapper classes are the ones which convert them into objects or reference types for the ease of compilation and execution of programs without any issues. So followed by this question, we have the next question. Define singleton classes in Java. So the answer for this question is, in Java, when you make the constructor of a class as private, then the particular class can generate only one single object. This is the reason why such type of classes are called as singleton classes. So followed by that, we have our next question that says define package in Java. So if you use some of the popular IDEs, that is the integrated development enterprises such as IntelliJ or Eclipse, then you might be familiar with projects, packages, source files, and then the class file. So basically you create a project first, and inside the project you will be having your source folder, and then you will be creating your own package using the source folder, and inside the package you will create a class file, and inside the class file is where you write your Java program. So here the question is, define package in Java. So the answer for this question is as follows. Package is a collective bundle of classes and interfaces along with necessary libraries and jar files. The use of packages helps in code reusability. So basically when you create a specific package, inside that package you will store all the class files that you will be using in your Java program. So not only class files, in case if you use any kind of connectors or any kind of jar files or any kind of dependencies for your Java program, you will include all those inside the package so that the requirements and the class files are bundled together, and this helps out in code reusability, making sure that the program files or the jar files or any dependencies are not juggling between one package to the other or one file to the other. So using a package is basically a good practice. So followed by this, we have our next question. Can you implement pointers in Java program? So if you remember C programming language, we had pointers there. So we use pointers to directly access the memory. So similarly, can you use pointers in a Java program? This is a little tricky question for beginners, but basically it's really simple. Now the answer for this question is no, because Java Virtual Machine personally takes care of memory management implicitly. So Java's major motto was to keep programming simple. So accessing memory directly through pointers is not a recommended action. So the answer is a big no, you cannot implement pointers in Java program. So followed by that, we have our next question. Differentiate between instance and local variables. So the answer for this question is really simple. Instance variables are declared inside a class and the scope is limited to only a specific object inside which an instance variable is created. So followed by the instance variable, we have the local variable. So the local variable can be anywhere inside a method or a specific block of code. Also, the scope is limited to the block of code where the variable, that is the local variable, is declared. Now followed by the 16th question, we have our next question. Explain Java string pool. So the answer for this question is a collection of strings in Java's heap memory is referred as Java's string pool. So for example, you wanted to create a new string. Consider your name. So your name might be some XYZ. So if you wanted to create XYZ string, then you provide that particular code to your JVM. So what does JVM do? It will not directly create that particular string. First, it will search for the XYZ string in your string pool. If that is already existing in your string pool, then it will provide a reference to that particular string. In case if XYZ is not there, then the JVM will create a new string, that is the XYZ string. So followed by this, we have our next question, that is, what is an exception? So the answer for this question is, an exception in Java is considered as an unexpected event that can disrupt the normal flow of the program. So for example, just consider that you are going to write a program for division operator. So after you finish your program, your evaluator might want to test your code to the extreme levels. So instead of providing a proper number, imagine that your evaluator is providing a wrong input, such as special symbols, sometimes 0 or any other sort of input. So if this kind of input is provided to your program, then your program might crash. So you can avoid this kind of crash by using exception handling. So basically you can use try and catch blocks. So you can embed your code inside the try block and say to your program that if any kind of wrong input such as special symbol or 0 is provided by the evaluator, then send a message saying wrong input or divide by 0 exception. So this kind of approach will provide an output, but this kind of approach will avoid your program from crashing. So this is how exceptions are handled in real time. So followed by this, we have our next question. What is final keyword in Java? So the answer for this question is, the term final is a predefined word in Java that is used while declaring values to variables. When a value is declared using the final keyword, then that particular value of that particular variable will remain constant throughout the execution of program. So sometimes if you include a normal variable and provide an operation on that particular variable, then the value of that particular variable will change after the execution of program. But when you declare the same variable using final keyword, then no number of operations or any kind of manipulations applied onto that variable will not change the value of that particular variable. So that's the speciality of final keyword in Java. So followed by that, we'll dive into the next question, that is, what happens when the main method is not declared as static? So the answer for this question is, when the main method is not declared as static, then the program may be compiled perfectly, but ends up with a serious ambiguity and throws a runtime error that says no such method error. So when you basically declare a main method, don't forget to specify the static keyword. So with this, we finished the beginners segment of questions. Followed by the beginners segment, we have the next segment, that is the intermediate level segment. So the first question in the intermediate level is, what is JDK and mention the variants of JDK? So the answer for this question is, so JDK is basically an abbreviation for Java Development Kit. This is a combined package of JRE, that is the Java Runtime Environment, and developer tools used for designing Java applications and applets. Oracle has the following variants for Java Development Kit. So the first one is the JDK Standard Edition, which is normally used by beginners and intermediate developers. Next, after the JDK Standard Edition, we have the Java Development Kit for Enterprise. So this particular Enterprise Edition is used by professional Java developers for developing Java-based applications and frameworks. Now the last one is the Java Development Kit Micro Edition. Now followed by 21st question, we will dive into the next question that says brief access specifiers and types of access specifiers in Java. So the answer for this question is as follows. Basically, access specifiers are predefined keywords used to help a Java virtual machine to understand the scope of a particular data member or data manipulating method within a class or outside the class. So in Java, we have 4 types of access specifiers. The first one is public access specifier. So when you declare a data member or a data manipulating method as public, then that particular data member or method can be accessible by any class or object throughout the package. Followed by that, we have the private access specifier. So unlike the public access specifier, when you provide the private access specifier, then the accessibility of that particular private data member or the data manipulating method will be provided to specific classes and specific objects only. And finally, we have the protected access specifier. So the protected access specifier is a bit more secure than the private access specifier. So the access for this particular protected data member or protected data manipulating method could be a little more difficult to access unless you are going to implement everything which is present in that particular package. So basically, if you are trying to access the protected data member or protected data manipulating method of a different package, then you need to first import the package into your existing package. So that's how the protected access specifier works practically. So finally, after the major 3 access specifiers, we have the default access specifier. So default access specifier will be provided by the Java virtual machine. So in case if you declare a variable or a data manipulating method without using any specific access specifiers that are public, private and protected, then JVM implicitly considers the default access specifier. So there is no much of a difference between the public access specifier and the default access specifier. Both have the same functionality and accessibility. So followed by this question, we enter into the next question, that is, can a constructor return a value? So the answer for this question is as follows. Yes, a constructor can return a value. It basically returns the current instance of a class implicitly. You cannot make a constructor return a value explicitly, but automatically it returns the instance of a class. So the next question is, explain this keyword in Java. So in Java, we do have a keyword which is called as this. So what does the keyword this mean in Java is the question. So the answer for this question is, the term this is a special keyword designated as a reference variable. So the term this keyword is used to refer to the current class properties like data manipulating method, instance, data member and constructors. So followed by the 24th question, we have our next question that says, explain super keyword in Java. So the answer for this question is as follows. The term super is a special keyword designated as a reference variable. So similar to this keyword, even super keyword acts as a reference variable. But the difference is super keyword is used to refer to the immediate parent class object. So followed by the 25th question, we have our next question, that is, explain method overloading in Java. So basically method overloading and method overriding etc. are the concepts of polymorphism. So now let's have a correct answer here. So the process of creating multiple method signatures using one method name is called as method overloading. So for example, consider that you wanted to include an addition operation in your program that performs addition operation. So the first method will be having the name add, and inside the method parameters, you'll be having 2 integer types of parameters. Similarly, you wanted to perform another addition operation with the same name, add. So here you will provide the method name completely same to the first method, but inside the parameters there is a difference. You are adding 3 parameters here. So when you pass the values to the add method, then which method to be overloaded? That's the confusion, right? So should I overload, or should I execute the first add method or the second add method? So this completely depends on the number of parameters you pass. If you are passing 2 parameters, then the first method will be executed. If you are passing 3 parameters, then the second method will be executed. So this is how the method overloading happens in Java. So the process of method overloading can be achieved by using 2 different ways. The first way is to change the number of arguments. So that's what exactly I've discussed before. Now the second way is varying the return type of the method. So with this, let's enter into the next question. Can we overload a static method? So as discussed before, the values of the variables or data manipulating methods will not be changed when we have used the keyword static in front of it. So the question is, can we overload a static method? Now let's discuss the answer for this. The answer is no. Java does not support overloading of static method. The process would throw an error reading static method cannot be referenced. So followed by this, we have our next question. So the next question is, define late binding. The answer for this question is, binding is a process of unifying the method call with the method's code segment. Late binding happens when the method's code segment is unknown till the method is called during the runtime. So followed by this, we have our next question. Define dynamic method dispatch. So the answer is, the dynamic method dispatch is a process where the method call is executed during the runtime. The overridden method is called through a reference variable of superclass. So this process is called as runtime polymorphism. Now we have our next question. Why is delete function faster in linked list than an array? So basically, linked list and array are the Java collections, or in other words, it's also considered as data structure. So to answer this question, you need to understand the analogy of linked list and array. So basically, an array is a complete memory block of consecutive memory locations. So consider that your memory location starts from 100 and your array has 10 locations. So it's a complete reserved block of from 100, 101, 102 to 109. So you have 10 memory blocks. So in case if you wanted to add a number or delete a number, then you had to make changes to the complete memory block. But when you come into linked list, you have the memory blocks used from the memory heap. So basically what you do here is you basically connect the nodes through addresses. So in case if you wanted to eliminate a number, then what you do is just to manipulate the addresses. So the address of the consecutive node will be changed. So that's the only change what you make. So now this is the reason why the delete function or any kind of manipulation function is faster in linked list compared to array. So now let's have a brief answer on this. Delete function is faster in linked list as the user needs to make a minor update to the pointer value so that the node can point to the next successor in the list. Now followed by this, we have our next question. Give a briefing on the life cycle of a thread. So the life cycle of a thread includes 5 stages, which are as mentioned below. Newly born state, runnable state, that is, it provides the JVM with a feedback that I'm ready to run now, followed by that the running stage where the thread is actually running, followed by that the block stage. So basically the thread will be blocked for some reasons, for some intermediate output or something, if the thread is waiting for an input from another source or something similar. So that's where the blocked state comes to existence. And finally the dead state. Once after everything is processed, the thread is eliminated by JVM. Now followed by this, we have our next question that says, explain the differences between the operators provided here. So the operators might look similar, but they are different. Now let's understand about these operators in a much better way through the answer. So the answer for this question is, although they look similar, but there's a huge difference between them. So the first operator, which looks like two greater than symbols, perform the operation of right shifting. So when you provide a binary number or binary value, then the bits will be shifted towards the right. And the second symbol or the second operator, which is having three greater than symbols, is used to shift out the zero filled bits. So this is the functionality of these two operators. Now followed by that, let's have the 33rd question. Brief the life cycle of an applet. So the answer for this question is, the life cycle of an applet basically involves the following stages. The first stage is the initialization stage, next is the start stage, third is the stop stage, fourth is destroy, and finally we have paint. Now the next question is, why are generics used in Java? So the answer for this question is, compile time type safety is provided by using generics in Java. So this approach allows the users to catch unnecessary invalid inputs at the time of compilation. Generic methods and classes help programmers to specify a single method declaration, a set of related methods, or with a single class declaration, a set of related types. So followed by this, we have our next question. Explain externalizable interface. So the answer for this question is, the externalizable interface helps with the control over the process of serialization. The externalization interface incorporates read external and write external methods. So we have listened to a new term here, which is serialization. So what exactly is serialization? Serialization is a process of sending your Java code or Java project from one computer system to a different computer system. So basically, if you wanted to execute some kind of Java program from a different location, then you serialize this particular code to a different location where you actually want to execute, and this particular process of transferring your code is called as serialization. Now the next question is, explain daemon thread. So the answer for this question is, the daemon thread can be defined as a thread with least responsibility. The daemon thread is designed to run in a background during the process of garbage collection in Java. The set daemon method is used to create the daemon thread in Java programming language. So we have our next question now. Explain the term enumeration in Java. So the answer for this question is, enumeration or enum is an interface in Java. Enum allows the sequential access of elements stored in a collection in Java. Now the next question is, why is Java considered as a dynamic programming language? So the answer for this question is, Java was designed to adapt to an evolving environment. Java programs include large amount of runtime information that is actually used to resolve access to the objects in real time. So this is the reason why Java is considered as dynamic programming language. Now followed by this, we have our next question. Can you run a code before executing the main method? So the answer for this question is, yes, we can execute any code even before the main method. We will be using the static block of code in the class when creating the objects at load time of the class. Any statements within the static block of the code will execute it once while loading the class, even before the creation of objects in the main method. Now the last question in the intermediate section is, how many times the finalize method is called? So the answer for this question is, the finalize method is called by the garbage collector. So for every object, the garbage collector calls the finalize method just for once. Now with this, let's enter the advanced segment of interview questions based on Java. So the first question in the advanced segment is, can the keywords this and super be used together? So the answer for this question is, no. This and super keywords should be used in the first statement in the class constructor. So the following code segment will give you a better idea. So you can see that we have used the keyword super and this in the class constructor. That is the first class constructor. Now this is how you can use super keyword and this keyword together in case if you wanted to use. So with this, let's continue with the next question in the advanced level. So the next question says explain JSP page. So the answer for this question is JSP is basically an abbreviation for Java Servlet page. So the Java Servlet page consists of two types of text. The first is the static data and the second one is Java Servlet page elements. Now the next question is explain JDBC. So the answer is JDBC is an abbreviation for Java Database Connector. JDBC is an abstract layer used to establish connectivity between any existing database and to a Java application. Next question is explain the various directives of JSP. So the directives are instructions processed by JSP engine. After the JSP page is compiled into a servlet, directives are used to set page level instructions, insert data from external files and specify custom tag libraries. Directives are defined between the following symbols. So these are the symbols that are used to specify the directives in a JSP page. The different types of directives are shown as below. There are three types of directives. They are include directive, page directive and taglib directive. So include directive includes a file and merges the content of the file with the current page. The page directive is used to define specific attributes in the JSP page like error page and buffer. The taglib directory is used to declare a custom tag library which is used in the JSP page. Followed by that we have the next question. What are observer and observable classes? So the answer for this question is objects that subclass the observable class maintain a list of observers. When an observable object is updated, it invokes the update method of each of the observers to notify that the observers that it has changed its state. The observer interface is implemented by objects that observe observable objects. Might be a little confusing, but you need to read this answer once again. You can pause it and you can read this answer once again so that you can get a brief understanding of this. Followed by that we have the next question. What is session management in Java? So the answer for this question is a session is essentially defined as the dynamic stage of a random conversation between the client and the server. The essential communication channel includes the string of responses and requests from both sides. Typically, the most popular way of implementing session management is the employment of a session ID in the communicative discourse of the client and the server. The next question is brief about Spring Framework. Spring Framework is basically the framework of frameworks. Now the answer for this question is Spring is essentially defined as the application framework and inversion of control container for Java. Basically, the chief purpose of Spring Framework is to create enterprise applications in Java. Also, it is especially useful to keep in mind that the central features of the Spring Framework are essentially conducive to any Java application. So the next question is explain JCA in Java. So the answer for this question is JCA is basically an abbreviation for Java Cryptography Architecture. So JCA provides a platform that gives architecture and APIs for encryption as well as decryption. JCA is used by the developer to combine the application with the security measure. It also helps in performing the third-party security rules. It uses the hash table, encryption message digest, etc. to implement the security. So the next question is explain JPA in Java. So the answer for this question is JPA stands as an abbreviation for Java Persistence API. The JPA is enabling us to create the persistence layer for desktop and web applications. JPA deals with the following: Java Persistence API, query language, Java persistence criteria API, object mapping metadata, etc. So the last question in our list is, explain the different authentications in Java servlets. So the answer for this question is, authentication options available in servlets are as follows. The first one is basic authentication. So the basic authentication consists of username and password provided by the client to authenticate as the user. The second one is form-based authentication. In this particular type of authentication, the login form is made by the programmer by using HTML. Followed by that, we have the third type of authentication, that is digest authentication. Digest authentication is similar to basic authentication, but in this the passwords are encrypted using hash formula. This makes digest more secured. And lastly, we have the client certificate authentication. The client certificate authentication requires that each client accessing the resource has a certificate that it sends to authenticate itself. This requires SSL protocol. Now, thanks to our training experts, with that we have come to an end of this Java tutorial. If you have any queries regarding the topics covered in this particular tutorial, or if you need the code documents that have been executed in this particular tutorial, then please feel free to ask them down in the comment section below. Our team of experts will be happy to resolve all your queries. Until next time, thank you, stay safe and keep learning.